Welcome to the course in Lightweight Java Web Development, Deployment, and Security. We're looking in my Emacs editor at a working file called courseoverview.txt, and as the name suggests, this is meant to be a very quick tour of what we're going to be doing. So let me start out with the guiding principle to give you a sense of the approach that's going to be taken. I love code examples. My 2 cents is the more code examples, the better. And so this is a very heavily code-centric introduction. The working files are going to include all sorts of deployable web apps. They should be able to run on any platform. With respect to background and requirements, programming familiarity with core Java or greater is what's required. The more recent, the better. All you'll need installed on your machine is core Java and some other software that I'll talk about later. So let's get to the heart of the matter, the programming APIs that we're going to be covering. So HTML5 and CSS, these are of course understood in any web environment. Once in a while, I'll be using earlier versions of HTML5, but for the most part, 90% of the time or so, I'll be using HTML5 and CSS3. Now we turn to the Java level. There's basically 2 levels that we'll be covering. Java servlets and JSP pages. Java server pages represent, in effect, the base level. So if you're going to do web development in Java, the assumption is that you know this level, and we'll be giving this thorough coverage. JSP includes what's known as the expression language. In fact, there are several variations of it. I'm going to describe these as the old and the new. We'll be covering both. You can intermix them. We'll also be looking at JSTL, which is a collection of JSP libraries, and more about that when we get into those areas. Java has many frameworks that are higher level than servlets and JSP, and the dominant one remains JSF, Java Server Faces, and so we're going to be using that as a representative of a higher level web framework in Java. And we'll do thorough coverage of JSF. For browser-side processing, nowadays, JavaScript and probably a JavaScript framework such as jQuery are unavoidable, and so the course includes coverage of both JavaScript and jQuery. Now, there are lots of supporting tools. Let me start with the most obvious. In order to do web development, we need a web server. We're going to be using Tomcat by default. It's Java-centric, production grade. It's an excellent piece of software. It's gotten better and better over time. Some of you may have an alternative installed. For example, Jetty is also quite popular. Jetty would be just fine. You could also use a Java application server, Glassfish, JBoss, that sort of thing, because those contain so-called web containers. But that would be a little bit heavyweight. It's doable, but my recommendation would be Tomcat or Jetty. We need a database. By default, I'm going to use PostgreSQL, which is just excellent, but again, alternatives are possible. If you're using MySQL, that would be fine. Even SQLite would be fine for this course. But by default, Postgres, I must admit that I like this piece of software very much. For talking to the database, we'll be covering 2 APIs. JDBC is the grizzled workhorse in Java, very good software, still used a lot. And JPA is a higher level API. So JPA is the Java Persistence API, and we'll be covering both with code examples in both. There are a bunch of utilities that I'll be using from time to time. I'll introduce them when the time comes. For example, I'll be using curl for doing some quick testing. Curl is available on any platform. And I'll also provide an Ant script to compile and deploy all of the examples, and I'll go into how to use that. If you're using Maven instead of Ant, that's just fine. We'll also be looking at regular expressions for data validation. This is the modern approach. To wrap up, we'll be covering both wire-level security, basically HTTPS, and users' roles security, authentication, and authorization. So that's the quick tour. What's going to follow, of course, is lots and lots of code detail. I think you'll find it enjoyable. I look forward to doing the course with you. In this lesson, we're going to look at an introductory web app so that we have context. We're going to examine this web app in detail, look at the code, talk about how to deploy it, talk about the requirements to get it up and running and so forth, and later on we'll refine it. But for now, the web app basically provides us with some context, something that we can talk about. The web app is deliberately simple, but it does contain all of the realistic features of a real-world production-grade web app. So as you can see, I have my browser open. I happen to be using Chrome, but any modern browser should do. And the browser is displaying a very simple form, and the form wants me to enter a temperature. It's going to be understood as a Fahrenheit temperature. So let me just do 123.34. I can hit return. That's going to cause a request to go back to my web server and my web app. It does the conversion. It's very, very fast, as you can see. I'm not actually going over a network. I'm on my local machine. And my response page has a little hyperlink, so I can do it again. So I'm back to my form. Let's do -40, because that's the same in both scales. So you can see -40 in Fahrenheit is also -40 in centigrade or Celsius. And I can run this basically indefinitely. So what I have in summary is a two-page web app. There's an input form that a user fills out, 9876, submits, and then there's a response page that contains the answer, if you like, together with a hyperlink. Let me now go to my Emacs editor. I have a very simple text document. It's called firstwebapp.txt. By the way, this file, together with the deployed web app file, which is called temp.war. The war stands for Web Archive. It's just a jar file. We'll get into details later. Those are in a zip file together for convenience, and that's called firstwebapp.zip. So let me run through the steps. There are 8 of them altogether. I start with step 0 because that happens behind the scenes. You don't see that. On my MacBook Pro, which is this machine, I've installed Tomcat, I've started Tomcat, and I've deployed the war file, temp.war. We picked up the example at step 1, where I open up the browser and I enter the appropriate URL. I show that down below here, but we'll get into details a bit later. This is just for reference. I enter the appropriate URL, which causes the browser to send a request over to Tomcat, and Tomcat responds with my input form, input.html, which is, of course, the traditional name for a welcome page. I have, by the way, information in this deployed war file up here that tells Tomcat that input.html is the appropriate page to send back in case the user doesn't specify anything. Again, this is a detail that we'll analyze carefully later. In any case, once the input.html is sent down to the browser, the user fills in the text box and submits, basically hits the button or hits return. In step 4, another request goes back to Tomcat. This contains the input data, so I'm assuming here -37.6 or whatever. The application on the server side then performs the so-called business logic, the application logic. In this case, of course, very simple. All it does is converts a temperature, generates a response page, which is sent back to the browser, which displays it. And of course, the response page contains a hyperlink, so we can go all the way back to step 1 and keep going indefinitely. So this first web example is going to provide us some context. In forthcoming lessons, what we'll do is analyze the code, talk about deployment, we'll talk about installing Tomcat, and all of that. But for now, let's take a short break. In this lesson, we're going to start looking at the pieces that make up that introductory web app. Here for quick review is that web app. It's a simple 2-page affair. The first page is an input form, as you can see, 1, 2, 3, and we click the button and we get the second page, which is the response page, which gives us the answer. Let me turn to my Emacs editor. There are 3 pieces in this first web app. There's the HTML page. We're looking at that. We'll get into some detail momentarily. There's a deployment file called web.xml. That's sometimes described as the deployment descriptor. We'll look at that momentarily. And then there's a third file called convert.jsp, and we'll look at that in the next lesson. So in this lesson, we'll look at 2 of the 3. As you can see, this is a very simple HTML page. It happens to be HTML5. It contains a little bit of embedding styling. So in a production grade example, we would want to break that out, put that in a style sheet. We'll do that sort of thing later. But the page and the styling are so simple that I've combined them for convenience. The page, by the way, is input.html. If you've done any HTML at all, you'll recognize some of these pieces. Let me get down to the essentials. Here's a form with an action, convert.jsp. In other words, when this form gets submitted by the web browser, convert.jsp is going to be the target. Tomcat is basically going to execute the code that's embedded in convert.jsp. We get into details later. And the HTTP method is post rather than get. Again, I'm going to put those details on the back burner for now. What's important is that we have an HTML form together with a submit button that's down here. When the submit button is pushed, the data embedded in the form will be sent to the web server. Now, the only HTML control in this form, other than the submit button, is basically this input box that you see at this line, and it's got some attributes: type equals text, name equals tempf, and for good measure, ID equals tempf. Some web frameworks focus on the ID attribute. Others, such as Java, and that's the important part, focus on the name attribute. So you can see here, I've got an attribute, which is just a key value pair with equals as the separator. Name is the key, and the value in this case is tempf. The name is arbitrary, but it's important for me to remember because my code needs it. So let me go back and refer to this convert.jsp page and give you the short version. In the short version, convert.jsp is going to say, in effect, give me the data in tempf. So I need to remember that name, whatever that name happens to be. The input form is straight HTML. We describe this in web speak as static HTML. In other words, there's no code in here whatsoever. So this is not an HTML template. This is just straight HTML. Now let me go to the deployment document called web.xml, and in Java, that's what it has to be called, web.xml, all lowercase. And this is a very simple version of such a file. As you can see by inspection, it's XML, and it's not too complicated in this example. Even in bigger examples, we may get into a web.xml that's about a page, occasionally maybe a page and a half, just to give you the sense of how big this file can become. But in this first example, it's very simple. Technically, web.xml is optional, but it would be indeed rare for you to have a web application that didn't have a deployment descriptor. That's what web.xml is sometimes described as, or a web descriptor. Now in this case, there's only one piece of information. It's the welcome file list, and the welcome file is input.html. So in the comment, I give you the long version. Let me here give you the short version. If a request comes in for the deployed war file, which is temp.war, but the request doesn't specify what's wanted inside that war file, then the welcome file kicks in. So in effect, what this line says is input.html is the default page. If somebody asks for the war file, but not for a specific item in it, give the requester input.html. So that means my URL, my request URL, can end with /temp instead of with /temp/input.html. This very quick overview of the first two pieces will help us when we look at the third piece, which contains the embedded code. so I'd like to do that in a separate lesson. In this lesson, we're going to focus on the JSP code that is part of the introductory application. To begin, however, I'd like to do a very short overview of JSP. It stands for Java Server Pages. It's a tried and true technology for Java web apps. We'll refine this overview as time goes on, but for now, there's a couple of points that should be made. So to begin, a JSP page is just a text document that has a .jsp extension, and it's a mix of HTML and CSS and code, and we'll see that in a bit. The code, by the way, is translated automatically, so you and I as programmers aren't responsible for doing the code translation. Now, there are different versions of JSP. There's version 1.x and version 2.x, with various subversions, of course, 2.3, 2.4, 2.5. I'm going to refer to these as old style and new style, and I'm going to begin with old style. There are still some advantages to old style. There are some things that are easier to do, in my view, in old style than in new style, but mostly we'll be seeing new style. You can, by the way, intermix the two. So, as noted, JSP pages are templates, but they are rendered into straight HTML, CSS, and perhaps, of course, with some embedded JavaScript. The JSP scripts, as noted a couple of times now, are translated, and they're translated into servlet instances. For now, I'm just going to rely on your basic understanding of what a servlet is. It's standard Java code. There are methods and so on. We'll look at that in detail down the road, but for now, what we care about is that JSP scripts actually become servlet instances. That's what happens during the translation. So, JSP, you might say, is really a specialized templating language that generates servlets. Now, with this very rough overview, let's move into the convert.jsp code. This is the third file in that introductory application. The first piece is input.html, that's straight HTML, web.xml, the deployment document, and now the conversion script. So you can see starting at the top, we begin with some HTML stuff, familiar HTML. We come down to the body, and now basically we get into the code. Deliberately, I've introduced three types of old-style JSP code. The first thing begins here. You see angle bracket, %shine, bang. This is a so-called declaration, and you can use this to declare fields or methods just as you would in straight Java. By the way, the declaration could actually occur any place in this file. I've put all of the stuff in the body in order to make the thing a bit more readable. The second sort of code, and we'll come back and look at the details in a moment, consists of a so-called scriptlet. So this is standard Java code. Think of this as the body of a method, because that's basically what it's going to become at translation time. Finally, down here, this is a JSP old-style expression. It's a convenient way to write things back to the browser. So you see it's angle bracket %equals, which basically means write this string as part of the response. Now, I'd like to go back and look at the Chrome browser to make a point, and that point is this. You can see here that we're looking at the rendered JSP page in the browser, and if we go in and view the source, I think it's pretty much what you'd expect. The code has gone away, and what remains, of course, is just straight HTML with a tiny bit of CSS. So a JSP page is rendered into what I'm going to call pure HTML. That's a bit of an overstatement because the HTML may include some CSS, it may include some JavaScript and other goodies that we'll get into later. But for now, this is a nice example of the sort of point I want to make. JSP, the code part, goes away. What comes down to the browser as the HTTP response is just a straight HTML page. Now, let's get back to convert.jsp and look a little bit at the details. So I'm going back to the declaration. I declare two variables of type float, far for the Fahrenheit temperature, cent for the centigrade temperature. These again are standard fields. They're going to be initialized during translation to 0.0f in the usual way in Java. This is now my little code snippet. So the first thing I need to do is read the user's input. And I'm going to get that as a string because, of course, the user input text in the application. So just to go back and review that very, very quickly, if we bring this back and go to another temperature, I put in 99.9. That, of course, is text. It's going to come to me as text. So I'm basically reading it as text in this line. And the line is request get parameter tempf. Tempf, again, is the name of that input box. I trim it just in case there's any white space on either end because I'm going to convert it in the next line. So I'm going to use a utility method provided in the float class. And then I'm going to do the conversion to centigrade. And there's the standard formula below. And finally, down here, what I'm going to do is write the result back to the browser. So again, just eyeball it. If you come back, you can see right up here, this is basically the line that we've just written. Now, since you're programmers, you can tell already that I'm taking a lot of things for granted here. For one thing, if you come down here, I'm assuming that the user actually did input something. What if I get the empty string? What if I get some nonsense like foobar or something like that, a string that will not convert into a number? What are we going to do then? I've not yet dealt with error handling and other things that we're going to have to come to terms with, but for now, the important points are this. You get a feel here for what a JSP page looks like. You can see the mix of HTML and code, and this is a good start for us. What we're going to do now with this application is to refine it. We'll redo it in various ways, but this very first introductory application will be a good start. It'll be something that represents for us the baseline. In this lesson, we're going to focus on a key piece of software, and that, of course, is the web server. Without the web server, we can't run any of our web apps, including the introductory one that we've been inspecting and analyzing. The web server that I'm using on my MacBook Pro, that's the machine I'm on, is Tomcat. It's free, and it's a production-grade web server. It's very, very good. There's lots and lots and lots of websites the world over that are being hosted on Tomcat. A nice alternative, equally lightweight, and also a very fine piece of software is Jetty, Jetty. Tomcat is available for free. You see the URL there, tomcat.apache.org. There are various ways to download it. There are installers and so forth, but you can also download it as a simple zip file and then just unzip it in some directory. On this machine, which I'm using only for development, I've actually installed Tomcat in my home directory. That way there's no fuss. I don't need any special privileges or anything else to run Tomcat. Now, Tomcat does rely upon the locally installed JVM. Most of you are going to have, of course, the JDK installed because you're going to be doing some software development as well, and the JDK includes the JVM. It's a good idea to define the environmental variable java_home, spelled exactly that way, all caps with an underscore in the middle, to point to your install directory. More recent versions of Tomcat don't actually require that, but it's not a bad idea. As noted, Tomcat is Java-centric, but it's production-grade despite its lightweight character. I think you're going to find it's a nice piece of software to use. Let me now make a very quick point about terminology. Tomcat technically is the web server, and a key piece of software in that web server is the Servlet container. That's basically the software, if you like, the middleware that hosts the various web apps that we're going to be deploying. In Tomcat's case, the Servlet container is named Catalina. In the case of Jetty, it's a little cleaner. The web server is Jetty, the container is Jetty. But the Servlet container is such an important piece of software that it's very common in the Java world to conflate Tomcat, the web server, and Catalina the servlet container. In other words, to use the term Tomcat to refer to both. And I'm going to do that. There's no need to be fussy. Occasionally, I may talk about Catalina as the servlet container, but mostly I'll just talk indifferently about Tomcat. Now, when you install Tomcat, and we'll see it on my machine momentarily, Tomcat_home I'm using to represent the install directory. Wherever you put it, it's just fine. And underneath it, there are a number of subdirectories. I'm showing you 5 of these. There are some others, but these would be the principal ones. For us right now, the 2 most important ones are the first and the last, the bin subdirectory and the web apps subdirectory. The bin subdirectory contains scripts to start and stop Tomcat, very important, and the web apps subdirectory and its subdirectories, you can do that to any level. The web apps subdirectory is where we put our web apps, our WAR files. To go over the others very quickly, the conf subdirectory contains configuration information in the form of XML documents. We'll get to that eventually. The lib subdirectory has jar files. These are libraries. Depending on which version of Tomcat you use, the current version as of right now is Tomcat 8.x. It contains jar files. As noted, you're going to have a couple of dozen in there. In this installation, for example, on Tomcat 8, I've got 25. You could add some, but that should be done with great caution. More about that downstream. The logs file, of course, really important for debugging and for keeping information. Tomcat does a professional job of logging. And then the web apps, again, is where the web applications go. In the bin subdirectory, there are 2 scripts that are of interest to you. One pair, ending with .sh for shell, are for Unix-type systems, and their counterparts with .bat extensions are for Windows. So they're startup and shutdown, and they're very, very intuitive. So the basic idea is this. You run the startup script to start Tomcat, and should you want to bring it down gracefully, you would run the shutdown script. So let me show you how these work. By the way, after a successful startup, the easy way to confirm that it worked is just to open up a browser to localhost:8080. 8080 is the port on which Tomcat awaits HTTP requests. So let me show you that first. I've already started Tomcat, and as you can see, I've opened up my browser. Let me refresh it for good measure. I'm refreshing it, and this is basically the Tomcat welcome page. There's all sorts of information. There's examples and tutorials and how-tos and all sorts of other goodies. And over time, we'll have a chance to look at some of those. Let me now go to the command line. And what I'm going to do is shut down Tomcat. I've got it running. And in my case, it's installed in my home directory under Tomcat 8. So I'm going to the bin subdirectory. And since I'm on a Mac, I'm using shutdown.sh. And this closes it down. Now what I'm going to do is start it up again. So I'm just going to do startup sh. And you can see I get some confirmation messages. And at the very bottom, Tomcat started. That's basically what we want to see. Depending on the version you're using, you may see a little bit of difference in the output from these 2 commands. I'd recommend Tomcat 8 if you're open to it. But the examples that we're going to be covering should work under Tomcat 5.5 or later. So there's a great variety. For example, you may have Tomcat 7 already installed, and you may be quite happy with it. I don't see any problem there whatsoever. This overview information is in the working file tomcat.txt. It'll be included among the working files, of course. And as we go through the various lessons, we'll have a chance to refine some of the information contained here. So this is meant to be as a quick start. You want to get Tomcat installed and up and running as soon as possible. And I think you'll find it a nice experience. The software is well designed and the install is straightforward. In this lesson, we're going to do a quick review of the languages and technologies that are at play in the first introductory web app. The document you're looking at in my Emacs editor is technologies.txt, and it's a simple summary of what we've seen so far. So we've seen different languages and different technologies. Let's do a very quick review. To begin, in the input.html page, we had basically straight HTML with a little bit of embedded styling. I'll get to that in a moment. It was an HTML document, and HTML, of course, is good for structuring information, field sets, lists, and so forth, and providing I/O controls, text boxes, buttons, and the like. And all of this is well suited, of course, when the client application is a browser. In other words, the client is using a browser to go against a web app. The web app typically delivers up HTML in some form or other back to the browser for display. The dominant example in the first web app was the field set. As the name suggests, it's a collection of fields. Embedded in that, a form. Embedded in the form, there's a text box, and that's at this line. You can see input type equals text, and there's also a button for submitting the data in the form. In general, a form would have more input controls than this. You might have drop-down lists and all of that good stuff. We're not going to do a rigorous, precise survey of each and every control available in HTML. The HTML is going to be introduced by example. I assume that as modern programmers, you've all had some acquaintance with HTML and you have a basic reading knowledge of it. We'll refine that through various examples. The first web app also uses cascading style sheets, CSS. The current version, by the way, is 3. In best practices, a style sheet would be broken out into a separate file, perhaps into several files. But it's so simple in the first example that I just encapsulate it in the HTML document in the Styles section. And you can see that here. I set a color for the legend in the field set. I set some properties on the input button and on the input text box, and also on the width of the field set. We'll get into richer examples eventually, and of course we'll see CSS files broken out separately. There's no JavaScript in the first example, but certainly we'll get there. We did, of course, need a web server. Tomcat, quite excellent. Or Jetty, also quite excellent, could be used. Tomcat is what I used in this example. And for us, the important thing is we deploy a web app to Tomcat or to Jetty by putting a WAR file in the web apps directory or one of its subdirectories. By the way, undeploying and redeploying are also straightforward. You undeploy by removing the WAR file. You redeploy by overwriting an existing WAR file. Very intuitive, very straightforward. You never, by the way, need to restart Tomcat or Jetty in order to undeploy or redeploy. Now, the first app had dynamic content. In other words, content generated through code. So we needed some place to put the code. I embedded all of the code in the JSP page. That, again, is not best practices. But to begin, in a very simple app, it's the easiest way to go. And so I did that. And I used only old-style JSP, in other words, version 1.x. I had 3 coding constructs in that example. The first one you see here, this is a declaration. Basically, I'm just declaring 2 fields, as I would in a regular Java class. They're called far and cent. They're of type float. They represent, of course, the Fahrenheit and centigrade temperatures. Then there's a little scriptlet. Conceptually, these 3 statements are the body of a method. That's what they're going to become when this JSP page is translated into a servlet instance. And finally, for convenience, this is an expression, old style, JSP 1.x, and it's used to write a response back to the client. So this basically just summarizes the conversion information. Now, on the web client side, we've seen that, of course. I was using a browser, in particular Chrome. Pick whatever browser best suits your purposes that you like. Any modern browser will do. I'd also strongly recommend the curl command line utility. And let me go all the way over here just to emphasize that here's the URL in case you don't have curl installed. It's available on every modern platform. Curl is a convenient alternative to a browser for doing preliminary checks. I find in development mode, I'm using the curl utility almost as much as I'm using a browser to hit a web app. So that's a quick review of the technologies in place so far. What we're going to do is look at some other infrastructure and at the same time push that first introductory example forward. We're going to refine it, we're going to add some error control, and so forth. In this lesson, we're going to take a step back from the coding details of the introductory web app and look at the big picture. Let me begin with Jargon. I've described the introductory example as a web app rather than as a website, although either term might be used. There's lots of jargon, of course, surrounding the web. There are web apps, web services, websites, web portals, and so on, and things can get a bit confusing. I'm not trying to standardize the terminology here, but let me make a couple of points about why web app seems a good term for our purposes. The app part of web app suggests, of course, that code is in play, so that the pages we're dealing with are, for the most part, dynamically generated. In other words, generated by code. We're not dealing simply with static HTML pages. In the first example, we did have a mix. Input.html is a static page, and convert.jsp, the JSP script, generates an HTML page. So you've got both in play. Now, in this working file, it's called sites services apps.txt. We're looking at it as usual in my Emacs editor. I have a lot of bullet points that goes over web apps, websites, web services, but instead of going through those bullet points one at a time, they're really for summary purposes. Let me come down to the middle to this depiction, which indicates how complicated things have become in the web world. And it also reinforces, I hope, the idea that web app is a good term to cover the sorts of things that we're going to be covering. So as you can see, in this crudely defined architecture, what I have in the middle is a web browser, and to the left and right of the web browser are two distinct web servers. They might be the same, but for emphasis, let's suppose that they are completely different physical devices. They're different hosts in networking jargon. I've also labeled the requests and the responses for ease of reference. So let's walk through very quickly what's going on here. The web browser, presumably with a human there using it, issues a request against the web server on the left for an HTML document, and that comes back. That's the response down below. Let's assume that this HTML page has some embedded JavaScript. We haven't seen that yet, but we will fairly shortly. Once the browser has the page displayed in place, the JavaScript can execute, and it sends out request labeled 3 over there to the right to another web server, and that web server delivers up a JSON document, JavaScript object notation. No doubt you've seen some of that. And a JSON document is simply the text representation of a native JavaScript object. In this scenario, then, what you have is the JavaScript in an embedded HTML page acting as a web service client. That would be the traditional description about what's going on the right-hand side. The entire thing can be described as one big web app. So there's a traditional website in play on the left, but there's also a web service in play on the right. So the way I would like to characterize everything that's going on here is as a web app. When precision is absolutely necessary, I may emphasize the website aspect of a certain web app or the web service aspect of a certain web app. But in general, my practice is going to be to use web app to cover the sorts of coding applications that we're going to be covering in these movies. So I hope this overview is helpful. It will become fleshed out and refined as we get into more elaborate examples, particularly examples that involve embedded JavaScript. In this lesson, we're going to focus on deployment because deployment is one of the challenges that any programmer is going to face when doing web apps. So let me start with a little bit of background. Many of you may be using an IDE, an integrated development environment, such as Eclipse or NetBeans or IntelliJ. There are many fine ones out there in the Java world. And those tools are very, very helpful because they automate tedious tasks such as deploying web apps. If you set things up right, you can do a click of the button and boom, the web app is deployed to Tomcat or to Jetty or to some other web server. In a learning environment, of course, we'd like to focus on some of the details that an IDE keeps from us, because we're trying to learn how things are actually working, and eventually, in debugging mode, this knowledge should prove useful. The IDEs in question, under the hood, typically use build scripts of some sort, so these are scripts written in a specialized language normally. And in the Java world, it's fair to say that Maven and Ant are the two dominant build languages. I think it's fair to say that Maven is higher level and more powerful, and that Ant is simpler. So my suggestion is this: if you're already familiar with Maven, stick with it. There are plenty of Maven build scripts to do what I'm going to be doing in a simple Ant script. And if you're not familiar with build scripts, then I'd recommend using the Ant script that I'm going to provide, because it's straightforward and it takes very, very little setup. We'll look at the Ant script in the next lesson. Now let me get to the challenge. On this line, in the working file, which is called deployment1.txt, and of course we're looking at it in my Emacs editor, you see a command I've issued from the command line prompt. I'm assuming that's the %, jar tvf temp.war. So jar is a utility that ships with the JDK. It's in the same directory, the bin directory of the Java install. The T is for table of contents, the V is for verbose, and the F is for file. And the file is temp.war, which is the war file that holds the introductory web app. So I've excised some timestamps. We don't really care about those. And here's what remains in the output. There's the meta-inf subdirectory. We don't care much about that or its contents. The webinf subdirectory, by contrast, is very important. It contains web.xml, the deployment file. In general, XML files are going to go into webinf. And then at the top level, the two main pieces of the first web app, convert.jsp, the JSP script, and input.html. These are both text files. You could put those in the top level directory or in a subdirectory. Now let me describe the constraints. In other words, basically the rules. So I have an imaginary web file I'm calling acme.war. It's going to be deployed, and here are basically the contents. At the top level, I've got two text files, index.html, the traditional welcome page, and by.jsp, which is a JSP script. We could put these in a subdirectory if we like, but putting them at the top level is also perfectly fine. Then we've got two subdirectories of interest, webinf, which we've seen before, and lib for library. So sometimes I'll call it lib, sometimes lib. I'm not consistent. The deployment files, the XML files, go into and must go into webinf for web apps. And library files, which are jar files, go into the lib subdirectory. I have one example here, JSTL, Java Standard Template Library. We'll be seeing this in a forthcoming example. Underneath webinf, there is a classes subdirectory, and here's the short version. Any.class file. So any compiled Java file has to go either in classes or below. So to illustrate, I've got a product list source file I'm showing down here. Its package is acme.org. So what this means is acme has to be a subdirectory of classes. Org has to be a subdirectory of acme, and the compiled product list class has to go there. By the way, the other sort of thing you're going to see underneath this classes subdirectory are compiled servlet files, and we'll get to those a bit later. Let me summarize. The whole point of a build script, including the one that we're going to be looking at, is to automate the construction of a war file. And the main task is to put the goodies in the right places. So the XML files have to go someplace, the jar files have to go someplace else, the class files have to go someplace else, and so forth. So we're going to automate this. It might be useful if you have time to take something like temp.war and unpack it. You can do that by jar xvf. That'll unpack it. And then to put it back together manually. It's tedious, but it could be useful to do it for one example. If you don't have time, that's perfectly fine. What we'll do next is turn to the build script in Ant. We're going to continue looking at deployment. In particular, we're going to look at the Ant build script. You see it right now in my Emacs editor. Everything in red is documentation. It explains the points that I'm going to go over shortly. Let me just give you a feel for how much there is. It's about 2 screens full of documentation. The script begins in earnest at this line, and there's one line that you're going to have to edit, and that's the first line within the script. And we'll look at that momentarily. To begin, however, I'd like to do a demo. Let me open up my bash shell, and I'm in a working directory. Any directory will do, and I want to show you what's there. So as you can see, there's build.xml, the default name in Ant for an Ant script. We can verify that we have Ant by doing ant -version. And you can see I'm using 1.9.6, so you might check to see if you have Ant installed already. If not, just Google Apache Ant. You'll hit the home page, and you'll see the installation is straightforward. Now let me clear and go back once more to show you what we have. We have the build script, build.xml, and then a source subdirectory. Let me show you what's in there. Those are the 3 pieces in the first application: convert.jsp, input.html, and web.xml. To confirm that this is not yet deployed, let me show you Tomcat. It's in my home directory, Tomcat 8 Web Apps. And you can see right now there's not much there. This is all of the stuff that comes when you install Tomcat. So I've removed everything that I'd already put in there. Now what I'm going to do is a deploy. So let me clear the screen just so it's easier to see. I'm going to type the following: ant -D. That's a command line argument. More about that in a bit. war.name equals. Now I need to give the name of the war file. Any name will do, but of course I need to remember it, and I don't want to duplicate a name already there unless I'm trying to overwrite an application. So I'm going to pick temp, and then I'm going to say deploy. Hit return. You can see there's a screen full of information. Basically, here's what's happened. Let me clear. You can see now to the left, there's a build subdirectory. So everything from source has been copied over to the build subdirectory, but put in the right places, you might say. And then everything has been packaged into temp.war. So let me show you the contents of temp.war. jar tvf temp.war. So as you can see, if you go down to about the middle, the web.xml has been moved into webinf. The convert.jsp and the input.html are in the top level. Everything is pretty much good to go. To confirm, I'm going to open up my browser. I had been testing before, but just to make sure, let me get temp, which is what we just deployed. And you can see it's there, 123.4. Hit return. So it's working as expected. If we go back to the command line prompt, go and look again at the Tomcat 8 Web Apps directory, you can see that temp.war is there. Notice, by the way, that there's also a subdirectory called temp. What Tomcat does by default, we could turn this off, but I'm going to leave it on, is Tomcat opens the war file and basically empties its contents into a subdirectory with the same name. Temp.war becomes temp. Foo.war would become foo, and so forth. This is described in Java as unwarring the war file. In other words, emptying the contents. To undeploy the application, we simply remove temp.war. So that's no big deal. I'm just going to do remove temp.war. that will automatically remove the temp subdirectory. So I don't have to remove that manually. You can see that both temp.war and the temp subdirectory have been removed. To redeploy, all you would do is redeploy the file. You would do an automatic overwrite. So I've now deployed it. I can simply redeploy it again and again and again and so on. So if I want to make any changes, I can redeploy. I strongly recommend that that's the way to redeploy. Redeploy the whole thing. You could go in and tweak something in that temp subdirectory, but redeploying is safer. Let me wrap up by returning to my Emacs editor and talking about what you need to change. So you can see inside the Ant build script, beyond the documentation, there's the project element. And then you see this property. The name of it is tomcat.home. What you need to do is adjust the value. On this machine, Tomcat is installed in users/martinkalin/tomcat8. On other machines, I have Tomcat installed in other places, so I need to edit this, and you need to edit this as well. Even if you're on a Windows machine, by the way, you can use the forward slashes because Ant understands the forward slashes. You don't need to worry about backslashes. So reset this, save the file, and you should be good to go. Now let me go back to the command line prompt and clear the screen just so it's easier to read. There are some other commands you can do with my Ant build script. If you just type Ant, what you get in effect is a very quick tutorial about how to use it. So this will remind you, for example, how to do the deploy. Ant deploy -d war name equals. The deploy can come first, as you see here, but it also can come at the end. You can do Ant clean. So let me show you the result of that. This eliminates the build subdirectory. And you can also do Ant compile if all you're trying to do is make sure that something compiles. Let me make one further point. What my Ant script does is basically copies the contents of the source directory into a build directory, so it doesn't change anything in source. That's deliberate. Nothing is ever changed there. You're going to put your things in source, and then I'm going to build a build directory with those same things and build and put them all in the right places. This is really our first look at the Ant script. As we get into more detailed examples, I'll go over it again, I'll remind you of how I used it, and I'll repeat it often. I use it all the time now. It's very convenient. If I'm not using an IDE, I find this is a nice, quick way to deploy to Tomcat. You could also adjust it to deploy to Jetty because deployment is essentially the same. This lesson introduces a deployment exercise. I hope you have the time to try the exercise. Just going through the steps at least once makes a lot of the details that we've been covering come clear. I'm in my bash prompt, as you can see, on my MacBook Pro. Let me show you what the working directory looks like. Build.xml, of course, is the Ant script that we've been considering. And there's the source subdirectory. Let me show you its contents. There's a web.xml on the right that contains a welcome file whose target is hi.jsp. And we'll look at hi.jsp in just a moment. So if the URL targets the war file, hi.jsp within the war file is picked up automatically. There's also a subdirectory called exercise1, and in there is a very simple source file for Java, hi.java. So as you might guess, this is Hello World done as a web app. Structurally, this is a bit more complicated than the introductory example because there's some Java that now needs to be compiled. So let me clear the screen and let me now do the build. Ant -d war name equals, we could call it anything, let's call it hello, and let's deploy it. So the screen now fills with these confirming messages. We'll clear once again. So as you can see, there is now the war file. Let's look at it very quickly, although I've got a document to go through the important pieces. You can see there's the web.xml in the right place. Hi.class, the compiled file, is in the right place. I also include the source code just for completeness. In a production environment, you would not include the source code, but it doesn't do any harm in this case. Let's test this just to make sure it's running. As you can see, I did that earlier, so I'll just do a refresh. And basically, you can see hello world, and I'm picking up some dynamic content here, the current time. Let's get into some of the details. So I'm going to switch over to my Emacs editor, and this file is called deployexercise.txt, and here are the important pieces. There's the web.xml, the hi.jsp, and the second piece, exercise1 hi.class. That's the compiled Java. All of that has been built from the build directory. We're going to see something a bit new here. We'll come back and cover it in more detail later. But hi.jsp has something we've not seen before, and that is down here. You see JSP useBean ID equals. So I've got two of these. The first ID is now, the second is hi. These basically act as object references in Java code. Corresponding to these are classes. This is, of course, a standard Java class, java.util.date. And this is my programmer-defined class, exercise1.hi. Notice when specifying the class, we give the data type, we don't give the name of the file. In other words, there's no extension here. With these two in place, I can now use an old-style JSP expression. So this is going to write the response. Hi is an instance of exercise1.hi. Get greeting. As you might expect, this is just a standard property. That's going to return hello world. I'm going to concatenate that with the @ surrounded by a couple of blanks. And of course, the Java compiler, as usual, is going to change that now into now toString conceptually. So what we're going to get is what we saw on the screen. Let's refresh just to show the thing is still running. So we get hello world @ and then we get the string representation of the current time. The programmer-defined class is in an explicitly named package. I'll repeat this several times, but that's really important. You want an explicitly named package for any of your back-end Java beans. I've got a no argument constructor just out of best practices. And here's my getGreeting method, which implements the read side of a greeting property. And as you can see, it just returns hello world. All of the pieces are in place, but the end script has to do a bit more work now, so it has to do some compilation. Let me go back to the bash prompt to do one more point. In this particular application, all of the compilation can be done using core Java libraries. Eventually, however, we're going to get into servlets, and core Java does not include the servlet classes. So for that, let me show you where we're going to be picking those up from the ant script. Tomcat 8 lib. This is the lib subdirectory, and as you can see, there's a couple of dozen jar files in here. The really important one is in the second column, third down. You see servlet API.jar. That basically has all of the standard packages for Java servlets. Immediately above it, you can see JSP API.jar, and there's some other jar files that are relevant as well. In general, my ant script is going to put all of these jar files that ship with Tomcat on the class path for compilation. In summary then, this first deployment exercise doesn't require any programming. That's quite deliberate, but I hope you get a chance to do it because I think the details of deployment will become much clearer then. We're going to focus on database technology. Most websites get their data from a back-end database. Of course, there are exceptions to every rule. You may have very special-purposed websites that, for example, generate their own data or use data that are not persisted. But think of any e-commerce site. There are products, vendors, orders, customers, on, all sorts of data sets, and those data sets typically are saved, persisted in a back-end database. It's fair to say, I think, that a website with a back-end database is the rule, not the exception. Now let's focus on the Java side. The Java side will become much clearer as we get into examples, and we'll do that in the next lesson, but for now, let's do a little bit of overview. Any Java app, including a web app, is going to talk to a database system through a so-called database driver, which is basically middleware. And that's typically delivered through a jar file. It might even be more than one jar file, but at least one jar file. The good news then is the Java app is insulated from the peculiarities of the database system because the Java talks to the driver and the driver talks to the database. So the good news is that if there's a driver, Java can talk to the appropriate database system. Now, Java's got a couple of different APIs. Sometimes these are described as supporting access patterns for talking to a database. There's the tried and true JDBC, officially no longer an acronym, but at one time, of course, it stood for Java Database Connectivity. This is relatively low level. It's close to the metal. You basically talk to the database through SQL statements, and we'll see that in the next example. The higher level API is JPA, the Java Persistence API. And you might say the way you talk to the database through JPA is in a native Java fashion. That is, you use constructors, you set properties, you get properties, that sort of thing. The SQL is typically under the hood. Java's JPA technology is basically its ORM technology, Object Relation Mapping. And this is very powerful, relatively easy to use because you don't have to get involved in SQL. It's also, for that reason, more portable. Some of these names you may have run into, for example, among the providers for JPA are Hibernate, easily, I think, the best known in the Java world, but there are others, including, for example, OpenAPA. One noticeable difference between JDBC and JPA is that in JDBC, you see the driver, in effect. You load it explicitly in your app. With JPA, by contrast, that sort of thing is really done in the background through configuration files, which is typical in Java, are XML files. And we'll see examples of all of that, so that will be fleshed out. Don't worry too much right now about the details. We're just trying to get an overview. So for us, the important thing is we can use JDBC, we can use JPA, and we'll use both. Now let me switch gears and talk about what database system to use. There are, of course, two broad types nowadays. There's relational, table-oriented, and there's non-relational, so-called NoSQL, which basically focuses on key value pairs that are persisted. Java is oriented in general towards relational database systems, but JPA in particular is sufficiently rich that it can support NoSQL database access as well. And I give an example basically of TopLink, which supports access to MongoDB, one of the better known NoSQL databases. We're going to use a relational database. Any one would do. So for example, if you're already using SQLite 3 or you're using MySQL or TopLink or anything else actually, if you have experience with those, you have a driver for those, I wouldn't change a thing. If you've not done anything with database, I would recommend PostgreSQL, which is what I'm going to use. It's really good. It is ready for prime time. It's production grade, industrial strength, however you'd like to describe it. The documentation over the years has gotten much, much better, and the installation has gotten to be much, much easier. If you're on a Mac or a Windows platform, it's basically a one-click installer. I've provided the URLs in this section. PostgreSQL also has extensions that cover, for example, NoSQL features. So I think it's an appropriate choice as a default. It's very powerful. It's what I'm going to use, but it's not what you have to use. So if you don't have anything installed right now, I strongly encourage you to go with PostgreSQL. But if you have something installed that's already up and working, a nice relational database management system, you can stick with it, and my examples should work with that as well. We're going to take a first look at JDBC code. The code in question is called basic-jdbc.java. I'm in my Emacs editor. We're looking at the code. For convenience, I've put the source file together with a jar file that we need, the jar file that contains the PostgreSQL driver, into a zip called basic-jdbc.zip. So that contains the jar and the source code. Before I compile and run this program, let me talk a little bit about what I needed to do to set things up. I'm on a Mac. When you install PostgreSQL on a Mac, on Windows, on a Linux system or other Unix type system, the installer installs the database system as a system service. So that, for example, when you reboot the machine, PostgreSQL should be running. The installer also starts it the first time it does the install. Now, Postgres ships with a utility called PSQL. You see it here in item 1. And there are different ways you can start that utility. You can do it at the command line. I'm going to use a GUI to get it started. And the bottom line is this. I need the PSQL utility to talk to Postgres in order to do 3 things. First, I want to create a user. Now, Postgres comes with a default user with a default password, but best practices is to create users of your own. I've created one called Fred, not too imaginative. Fred is a super user, as you can see. That means Fred can create databases, delete databases, create tables, and so forth. And Fred can be used for login purposes. I then give Fred a password. That's the second command you see here, the alter. And then the third command is I create a database called ski stuff. I'm going to use that database for my table, and then I'm going to populate the table with data. The program itself is going to create the table and then populate the table. I need PSQL to do these 3 things. 1, 2, 3. These are the commands you should enter in your PSQL. Let me show you how I got PSQL. Here's my Postgres. So I click it, and then over here on the right you see Open PSQL. It opens up a teeny tiny window over here. Let's enhance the font here a bit. And I'm already in the utility. I can type \h to get some help. If you're familiar with SQL, you'll recognize these as sort of standard SQL commands. I can get help on a particular command, \h select, and it'll give me information about select. When I'm done, I do the quit. But before I quit I did, of course, the 3 commands that we just looked at. So I'm going to exit here. I don't need this window anymore. Let me return now to my Emacs editor. So first, I did the setup thing. I got things ready to roll. I describe here a little bit about compilation and execution. Let me just make 2 quick points. You can see here for the compile, I just do the standard javac. I don't need anything special. All of the data types I'm using, you can see the imports above, ship with core Java. To execute, however, on the command line, I have to include the Postgres jar file because that contains the driver that we discussed earlier. Now, I'm doing a standalone app for convenience. If we were doing a web app, we would include this jar file in our WAR file. And we'll do an example of that, of course, a bit later. So here's the class, basic JDBC. For convenience, I've hardwired a bunch of data, 20 rows to be precise, and I'm going to populate a table with those rows. Down here in set login for DB, by the way, we're going to go through this very quickly the first time. We'll come back in the next lesson and look more carefully. I set the username and password. I need to check to see if the table already exists because I don't want to keep adding the same records over and over again. I want 20 and not more than 20. A little more documentation for later, but let me come down to this line to describe what I'm doing. I've got a string here, a URI, in other words, an identifier, a name. And you can see it has a very particular syntax, JDBC : PostgreSQL : and so on. The 3 variants for Postgres are listed above, and I'm using one of those. So I basically identify the database. That's called ski stuff. It's the one we created in PSQL. This is the all-important line for us. We load the driver. That's why we need that jar file. That's where the driver code is. We connect to the database. If the table already exists, I don't do anything. Otherwise, what I do is create the database. Technically, I'm creating the table, so that's slightly misnamed. And then I insert the rows. I commit all of the rows, so they're now in the database, and then I clean up a bit. Finally, way down at the end, I run a test. I go into the database, go into the table, grab all of the rows, and display them. So let me do that. I'm going to go to the command line. This is my bash shell. Just to be sure, I'm going to recompile. I've done this before, as you might guess, for testing. And now I'm going to run it. And as you can see, when I run it with the jar file. Let me clean things up and do the run again. So you can see Java -cp for class path. The dot is the current working directory. The colon is the separator. If you're on Windows, you might want to use a semicolon instead. PostgreSQL JDBC.jar is that jar file, and basic JDBC is the compiled Java file. I run it, bingo. There you go. You see the 20 records. Now, in a web app, of course, we would lay these out in a table or in some comparable way. We would do a bit more formatting than I've done. The leftmost column contains the IDs, 101, 102, and so forth. The reason they don't go 1 to 20, they go 101 to 120, is because I've done a bit of testing, and I'm letting Postgres automatically generate the ID for me. So Postgres is basically already circulated through the first 100 numbers during my testing, and these are now the current ones that it's using. If I run this again, by the way, I get exactly the same output because my program checks to see if there's already data in the table, and if so, it doesn't put more data in the table. In summary, we've had a very first and very quick look at the JDBC code. The code is meant to be both tutorial and practical. What I mean by practical is what I'm trying to do is automate the creation of a table and the population of that table with data so that we don't have to do that in a long, tedious fashion. It's also tutorial in the sense that it will acquaint us with driver managers, connections, statements, and so forth. So we'll get into those details in the next lesson. We're going to drill down into the details of the basic JDBC program. We're in my Emacs editor. We're looking at basic JDBC.java. This file is included in the zip called basicjdbc.zip. This file together with the jar file. So let me go through the imports to begin. All of these types are included with core Java, so we don't need the Postgres jar file for these. We can compile in the usual way, nothing fancy. Starting with the driver manager, this is what's going to handle communications between our app and the database system, in this case, Postgres. The same thing would occur, by the way, if this app were a web app rather than a standalone Java app. A connection is a connection, as you would guess, between our program and technically the driver manager. We connect to the driver manager connects to the database, but conceptually the connection is between the app and the database system. The statement type represents an SQL statement, a fairly standard statement, we hope, so we don't have to deal with peculiarities of different systems. A result set is a collection that we get back from, for example, a select query. We've seen that already. To be more precise, it's really a collection of rows, table rows or view rows. And an SQL exception, as you would also guess, is what can go wrong if we screw up. Properties is just a set of key value pairs. It's basically a subtype of a map. Technically not, but basically that's what it is. Let me get down to the code. Just to remind you, I've hardwired the data for convenience, 20 records. Properties we looked at before. Basically, this line sets the user to Fred, because we set that up in PSQL, and the password to secret. So if you don't have Fred as a user, and Fred doesn't have secret as a password, this isn't going to work. This code is a little bit tricky. I need to see if the table exists already when I run the program, because I don't want to keep adding the same 20 records over and over and over again. There are a number of ways that you might do this, so let me explain what I do. I have a flag initialized to false. Then I go into a try block. Everything is going to be in a try block. We're talking to a database. Things could go wrong. We create a statement using the connection. Here's the SQL statement we're going to execute. Select count star as total from the table. So basically what I'm going to do is ask the system, how many records do you have in that table? We execute the statement. The result set has an associated cursor, basically an iterator. So I need to position that basically to the next record. And then I check whether that count, which I'm saving as total, is greater than 0. If that's the case, then I've already populated the table, so I return true. Otherwise, I return false. So the first time you run the program, false is going to be returned, and the program's going to create the table and populate it with data. Here's the setup, which does most of the work. So this first line contains a URI. Sometimes you'll see it described as a URL. That's just a subtype of a URI. JDBC : PostgreSQL : localhost is the machine I'm on. We could be on a different machine. PostgreSQL supports secure connections to databases that are on different machines. We'll get into that when we talk about security. And ski stuff is the database name, and we created that earlier with PSQL. The properties are the username and the password. We grab those. Now we get to the critical lines. Class for name is a convenient way in Java basically to load a class file. And the class file we want is org postgresql.driver, and that's in that jar file that we use. So that loads the driver code basically. We then use the driver manager to get a connection object. These two lines are really the critical ones in setup. If we get by these two lines, probably we're going to be okay. Don't get me wrong, things can always go south, but we should be okay if we get by these two. I then check to see if the table already exists. If it doesn't, I create a statement. I use that. I call this createDB. I'm using that in a loose sense to mean the data. Really, it's a table. So I create the table. I insert the rows. I'm doing a commit after all of the rows are inserted. That's for efficiency. I close down the statement. I close down the connection. So at this point, I'm not connected any longer to the database. That's deliberate, because even the first time, I now want to do a proof of concept test, and that's test creation insertion. Here, by the way, are the grimy details of the SQL. Here's the create table code. So the table has 4 columns, an ID, which is an integer key. I'm letting Postgres generate those values. It's convenient. So this is an auto-generated integer ID. It's the primary key. A product is basically text, varchar, maximum size 50. Same with category. Price is a floating point value. Insert rows is also a little bit grimy, so you get the feel that we're really at a low level. So consider this SQL statement. Insert into skis, etc. the table. Product, category, price, not ID. Postgres handles that. Values. Now here's the catch. You can see these single quotes in here. It's a little bit ugly. The reason is that the product and the category are basically text. I've got to surround those with quotes. There are embedded blanks, for example, in the product names and in the category names. For the columns 2 down here at the end, that's basically the price. I don't need quotes there. That's a floating point value. So I iterate over my array, and then basically for each item in the array, I create a record in the table. Finally, we're going to test all of this. Again, we get a connection, a statement. This time the statement is very simple. It's a select star from skis, etc. It doesn't get much simpler than that. And then basically I iterate across that record set and print each one out. So for review, let me do that. I'm going to go to my bash shell and let me run this once more. And you can see there are the 20 records that we've seen a couple of times before. So let me summarize. This code is meant to be our first look at JDBC. We get a sense that it's low level. I wouldn't worry too much about each and every detail right now. This is also a utility for you to use, because by using this, what you can do is create a table and a database without having to enter the records one at a time. The program will do that for you. This lesson is a wrap-up of the first web app example and of the technologies that we had to put in place in order to get that example off the ground. It's not surprising that we've seen lots of different things so far. We've seen a web server, a database system, some HTML, some CSS, some JSP, and so on. And that's because we actually need a web server environment to do anything. Let me do a quick review, a little inventory of what we've seen, and also point ahead to what we're going to be seeing. So far then, on the programming side, the technologies have been pretty limited. We've used some HTML. It's been HTML5. Some CSS. The CSS has been embedded in the HTML. That's going to change. And of course, a JSP script. And in the JSP script, we both did some templating, but mostly some application logic. And as you're going to see in the forthcoming examples, the tendency is going to be to take the programming logic, the application logic, out of the JSP and put it into straight Java. Let me jump to that. The Java we're going to use are back-end POJOs, plain old Java objects, also known, of course, as Java beans. We're going to start relying on those more and more to do the application logic, and we're going to use JSP and other things. JSF is one example to do what I'm going to call HTML templating. And I'll describe that in more detail in the forthcoming examples. Eventually, we'll look at explicit Java servlets. The JSP scripts are translated into servlet instances, but we're also going to be dealing with some explicitly written servlet examples, and more about that a bit later. Eventually, we're going to introduce JSF, Java Server Faces, and of course, JavaScript. In particular, we're going to focus on jQuery, which is a JavaScript framework. For deployment, we've already got in place what we're going to be using. That is a lightweight, quite good Java-centric server known as Tomcat. Tomcat 8 is the current version. Jetty, which is an alternative, equally free, would be just as good. And there are other options as well. But Tomcat is just fine for our purposes. And the key piece of the web server for us so far is the servlet container. That's the middleware that basically manages the dynamic features of the web app. In other words, the code that executes in the web app. For data persistence, we have, of course, a relational database management system. There are lots of options. I invite you to use anything that you're comfortable with. The default is PostgreSQL, which is what I'm going to be using. It's quite good. And in addition to being a relational database management system, it also has what might be described as some NoSQL features, and more about those also in later examples. The core requirement for any database system we use is that it must have a Java driver. There must be middleware, typically delivered in the form of a jar file, that lets our web app talk to the database system. And in the next programming example, we're going to do exactly that. We're going to have a web app that talks to the database system. This lesson introduces a second JSP example, and the focus of this example is interaction between JSP, the Java side, and the database. So you're looking at a working file called JSPdb.txt in my Emacs editor. All of the files that we're going to be looking at are for convenience in a zip called JSPdb.zip. Before I do an inventory of the pieces of this second example, let me actually show it to you, and we'll begin by going to the command line prompt. You can see my working directory. To the left, I have build.xml. I'm going to use my AND script. JSPdb.txt is what we were just looking at. You see the zip file that contains everything and the source directory. So let's take a very quick look at that. You'll see there are 2 JSP scripts, 3 jar files, a CSS file. So I've broken the styling out, and the usual XML file for deployment. So let me now deploy this to Tomcat. Ant -d, war name equals, any name would do, we'll call this JSP, db, deploy. We get some feedback. The app has been deployed to Tomcat. Let me now go to a browser. As you can see, I've tested it already. But for proof of concept, let me do a refresh just to make sure nothing's broken. And you can see I've got tabular data. This is fairly typical, of course, in websites. And I've got all 20 records there. What we're going to do is examine the pieces that allow the JSP to talk to the database and basically get the data out of the database and format the data as you see here displayed on the screen. So let me return now to the Emacs editor, and let's go through the inventory. We'll really drill down into the code details in the next lesson. So let me start with the JSP parts. skistuff.jsp is the welcome page. It's the main page, and it uses what's called JSTL, Java Standard Template Library. This is part of JSP 2.x, and JSTL, to give you the short version, introduces customized tags into our web app. So you're familiar with standard tags. Let me just focus on 2 of them. There's HTML, there's body. You've seen that sort of thing many times, I assume. Those are standard HTML tags. Here's a JSTL tag. You can see C:\core. That's obviously not part of HTML. So that comes from JSTL. A customized tag needs backend code, as you'd imagine, and that backend code, as usual in Java, is stored in a pair of jar files. We also have now an error page. The error page in this app is very simple, so it's a proof of concept error page. So let me do very quickly an overview. In regular Java, you have methods, try blocks, and so on. You're familiar with those constructs. And if an exception is thrown, for example, in a try block, then control transfers to the appropriate catch block or to a finally block. It's possible, but not convenient in a web app, because the working modules in a web app are really pages. HTML pages, JSP pages, JSF pages, whatever. So what Java provides is an alternative to the standard way to handle errors and exceptions. And that standard way is to have a page such as skistuff.jsp. That's our main page. That's not an error page. And to let this page designate an error page. So the idea is if skistuff.jsp generates an error, control transfers automatically to this second page, error.jsp. By the way, an error page can have any name. I've picked error.jsp just because it's so obvious. Our app has, as usual, a web.xml, the deployment file. It designates skistuff.jsp as the welcome file, in effect. The web app, the war file in other words, encapsulates the Postgres driver file, the jar file, because we need that. We're going to be talking to the database. And the JSTL comes in a pair of jar files. One of them, you can see here, is for the API, so it's the interface effectively. And the second one is the corresponding implementation. All of this is encapsulated in the WAR file, and the deployable WAR file is included in the zip file that I mentioned earlier. Finally, we're going to look at new style expressions in this example. So what we've seen before, let me jump all the way over here to the end, are old style JSP expressions. We saw that in the first example, angle bracket percent equals. We're going to replace those now with new style, and now we have $, brace, expression, closing brace. This is known in JSP as EL, the expression language, and like JSTL, it was introduced as part of JSP 2.x. In this lesson, we're going to focus on the code pieces in the second JSP example. In this case, we're getting the data from the backend database. In my case, PostgreSQL. So let's take a quick look again, a very fast review of what's displayed in the browser. There are all together 20 rows of data. You can see them. They've been formatted into a table. The rows have alternating colors for readability. And there's a little bit of formatting going on basically in each of the columns. And we'll get into more detail about that momentarily. Now let me jump to the first of the code pieces. It may sound a little surprising to call this code. This is style.css. It's part of the deployed WAR file, and it's included in JSPdb.zip. All of the files we'll be looking at are included in that in the working files. But CSS is a language. Of course, it's a language that is targeted at visual design. So let me go through these pieces very quickly. This is a really simple CSS file. We'll get into more elaborate examples later. In this case, what we're going to do is alternate table row background colors. So you see the TR at the beginning for table row, and you see background over to the right, and then in hex the colors are written. Basically, the colors are light gray and white. For alignment, the numbers we're going to right align. So for example, the ID and the prices we're going to right align, and the text we're going to center align. So there's basically different alignment formats. Now let me switch gears and go to some JSP. I'm going to go to the error page. Recall that we have two JSP scripts, the welcome page if you like, which we'll look at last, and the error page, and control switches to the error page should an error occur on the main page. So here's the error page. There's something new, something we haven't seen before. This is a page directive. It starts out with angle bracket percent at, and then you see the keyword page. Then there are three attributes. The first is error page equals true. So we have to say that we're an error page basically, declare ourselves to be so. There's the familiar Java import. So I'm importing all of the types in java.io. We'll see that below. And this last attribute advertises that I'm going to be generating plain text. This is a really, really simple error page. Down here, I'm reverting to old style expressions, JSP 1.0 expressions basically, angle bracket percent equal, exception, get message. So if an exception is thrown, we're going to display it. The question that comes up, of course, to any programmer is, where does exception come from? That's clearly an object reference. It's not declared here. Recall that all JSP pages are translated into servlets. The underlying servlet is going to have a bunch of fields and local variables, which are known as implicit object references. That is, they are usable in a JSP script. I just need to know the names. Exception is one of those. There's also request, response, session, out, and some others of interest. 2 handfuls, roughly speaking. And then you can see this is a very geeky error page. What I'm doing is displaying the stack trace. This is not very friendly for the ordinary user, but for us, it's proof of concept. We want to know the mechanics of doing an error page, and basically, we write an error page as a JSP page, and we declare it to be an error page. That's the important part. Let me go to the really important one. That is skistuff.jsp. By the way, you can see in the editor the jar files that I need. Those are for JSTL and for Postgres. But let's jump into skistuff. This is the main page, the welcome page, if you like, in web.xml language. Once again, I've got these directives. The first directive, and all of the directives are basically metadata. So the first directive is a page directive, and it identifies my error page as error.jsp. We just saw that. These directives, by the way, could occur in any order. The next two are tag lib directives. We'll get into the details of those a bit later, but the short version is this. We're going to use two pieces of JSTL. The core, that's at this line, and also the SQL stuff, that's at this line, and you'll see those momentarily. Now we begin the straight HTML. So there's some HTML here. This particular line brings in the style sheet, so there's a link to that. And now we get to the stuff that's of interest to us as programmers. This is the first JSTL customized tag, SQL set data source, and I think you're going to find this very friendly. It's got 1, 2, 3, 4, 5 attributes. Those attributes, by the way, could be in any order. They could be on the same line, so there's no formatting restrictions. So the first thing I do is identify an object reference. I'm going to call this myDS, and I'm going to use myDS later. We'll see that in just a second. I identify the driver. We saw that in the standalone Java code. Org PostgreSQL.driver is the class. The URL I've changed slightly. In this case, I've included, just so we can see it at least once, the port number. So PostgreSQL by default listens on port 5432. Easy to remember. And then, of course, we've got our username Fred and our password secret. This particular customized tag sets things up. It identifies the data source, and then I use the data source down here in the second JSTL piece. So this is a query. The var is basically the record set. It's a reference to the list that's returned, and you can see the data source is specified here. This is the new expression language. $brace and then some expression, in this case, myDS. That's the myDS from all the way up here. So I'm referring to the data source. Basically, what I'm saying is run the query against the database. The query, of course, is here. Select all of the rows from skis, etc. Order by ID. They're going to be ordered that way anyway, but I just wanted to show some variation in the SQL and have list stuff refer to that record set. Now we're going to put all of that to use. We have a table. This is straight HTML. Now we're getting into core JSTL. We need to iterate over that loop. So core JSTL has something called for each. It starts here, ends here. That's basically our loop. And you can see I've got two attributes, var equals item. So basically, item is going to refer one at a time to the rows in the record set. So this is my iterator variable, basically. And the items themselves are list stuff rows, and list stuff, once again, is back up here. So that's the object reference in my query. The first time you see this, it's going to look a little bit complicated, but after you've seen a couple of examples, I think you'll find it becomes fairly natural. So we're going to iterate over the record set and basically do a layout. And that's done here with this customized tag, cout, output it. The value is the product ID. The product itself, that's basically its name. its category, and its price. And you'll notice here in front of the price, I've got a $$ because I want a $sign in front of that. So that's a quick overview of the code. Let me now return to the browser and make a couple of points. So the first point is this. This is not a very good page for shopping. It doesn't allow me, for example, to click something and say I want 10 of those, 2 of those, and so forth. So it's really not a completed shopping page. It's also not a good administrative page because I should be able to delete rows, edit rows, add new rows, all of that sort of thing. We will do all of those things in good turn. The idea right now is simply to have JSP talking to a database, and I think you'll find, if you inspect this code, that it becomes fairly straightforward to do with the very nice JSTL packages. So in particular, the SQL package is very nice for talking to the database, and then the core package with its for each is very nice for iterating over the rows to create a table or a list or whatever. In this lesson, we're going to discuss extending the JSPdb example into something that's more useful, more realistic. To that end, I've displayed yet again the current page. So you can see we have a table that represents the ski equipment inventory, so at least we can talk to the database. Without that, we couldn't go any further. There are basically 2 ways we might extend this. First, we might make it an e-commerce web app. Or, to use a different phrase, we might make this the classic shopping cart application. We would display the equipment, provide some checkboxes, maybe some drop-down lists with numbers, so that, for example, a user could decide for item 103 to order it by clicking a checkbox and then picking out how many of this the user would like. The default, of course, would be 1. That's a little bit pricey. We don't want to make a high default number. In any case, there's some other things we would have to add. We would need, for example, a submit order button and so forth. Eventually, we'll do such an application. But for now, we're going to go in a different direction. So the second way to extend this application is to make it a web interface to a backend database. This is something an administrator might use. For example, the admin would come in, get a list of the current inventory. We see that here. And then have the ability to create a new ski item, edit an existing ski item, delete a ski item, and so forth. We would need to provide some administrative appropriate operations for the admin to perform. And that's the route that we're going to take. Let me now jump to my Emacs editor. I've got a working file called restfulrouting.txt. Let me explain these terms. The acronym REST stands for Representation State Transfer. It's not something we have to worry about right now. Roy Fielding, well known in the computing world, coined that acronym in his PhD dissertation, but it's taken on a life of its own, really. It's come to stand for a very simple, sort of a minimalist CRUD-based approach to websites and web services, and by CRUD, yet another acronym, I mean create, read, update, and delete, which are the standard operations that programs perform against data stores, such as databases. We'll get a better sense of RESTful and CRUD as we get into the code example, but right now, let's just take this as a convenient way to describe what it is we're going to be doing. Now, let me make this point. Let me give a shout out to the Rails framework because they popularized the approach that I'm going to be illustrating in this example. In other words, the extension of the JSPdb Web App. Rails takes very seriously the relation between the CRUD operations and the HTTP verbs. So I have a little simple table here to describe those. The create operation in CRUD is the post verb in HTTP. So post basically means create a new. A get is a read. A put is an update or an edit if you prefer. And a delete is a delete. So basically, we need to implement these 4 CRUD operations. Now there's a catch. Modern browsers will generate only post and get requests. They won't generate put and delete requests. So even Rails has to basically fake it. And the way we're going to do it is in the standard sort of way. We're going to use HTTP post to do both create and update. And we're going to use get to do read and delete. So we're going to take a very straightforward approach to this whole thing. What Rails has also popularized is a set of patterns, or idioms if you like, that cover the CRUD operations. Let's look at all of this from the user's point of view. In this case, by the way, the user is the admin. The user wants to create a new ski item. So to that end, the user gets a form, it's empty, fills out the form, submits the form. This is very close to, by the way, an edit. You could actually use the same form because when you create, the form is empty, but when you edit, the form already has data in the fields. So in any case, you should have a form that allows you to create something from scratch or to edit an existing item. And in any case, when you do that, you should get confirmation. In other words, you should be shown what you have just created or just edited. Read operations are a little bit tricky in this sense. Sometimes you want to see everything, so you'd like to see a list of all of the items in the inventory. At other times, you might want to see them one at a time. There should be a read all and a read one, and we'll implement that. Delete is, of course, always a dangerous thing because a user might delete by accident. So when we delete, we're going to ask for confirmation. We're going to say, are you absolutely sure that you want to do that? And if you do it, we're going to delete the item. And then as confirmation, we're going to show all of the items that remain. You'll be able to see that the item just deleted is not in the current list. So that's the game plan, basically to extend the JSPdb Web App so that it becomes an interface to the backend database. And we're going to try to do a RESTful version of this, inspired by the sort of thing that is commonplace in the Rails framework. This lesson focuses on what I'm going to call the JSP-CRUD Web App. You're looking at the welcome page, which displays all of the ski equipment. We've seen that before, but there are now a couple of really important changes. For one thing, we can create a new ski product by clicking here. We'll do that in a bit. We can look at each of the equipment items individually if we want to get better focus. We can edit a given item, and we can remove a different item. In effect, then, what this web app does is provide support for all of the CRUD operations: create, read, update, and delete. What we now have is a web front end to a back-end database. Let me go out to my command prompt, and let's take a look at the pieces. Just momentarily, we'll inspect them a bit later. So you can see there's a bunch of JSP scripts. There's one to do a create, a delete, and so on. And we'll look at the flow of control a bit later. In the second column over from the left, you see 3 jar files. 2 of those support JSTL. 1 of those contains the driver for the database. So we'd expect that sort of thing. And then over to the right, there's a style sheet now broken out separately, along with the familiar web.xml, which is our deployment descriptor. I can deploy this in the usual way using my AND script, but if you have a Maven script or some other way to do it, that's great too. I'm going to use the AND script to deploy, and I'm going to call this JSP-CRUD. The deployment succeeded. Let me come back to the browser and refresh, just to be sure we get the new version. And now let's step through some operations. One thing you'll notice is I have a relatively short screen here on my Mac, and so not all of the 20 records show up at once. I have to do a little bit of scrolling. This, of course, suggests a nice exercise. What we might do is display 10 at a time. For now, however, our focus is on functionality. So let's start out by creating a new product, and I get a form to do that. I'm just going to call this test. We don't really care about the details right now. I'm going to call this test C. And the price, I'm using HTML5. What I'm trying to type in here right now are non-numeric characters. Notice that my browser refuses to accept them. I've basically said in the HTML I want numbers, 1, 2, 3, dot, 4, 5. And now we click Create Product. We get confirmation that it's been created. Notice there's some standard navigation here. I can now go back. Down there at the bottom, lo and behold, is the new product. So the create works. I can do a show on this. So this is the read one at a time, if you like. We just did the C in CRUD, create. We're now doing read one at a time. If we go back, we're doing read all. Let's go down. Maybe we'll pick the second to last one. Let's edit this guy, Atomic Red Star Skate Ski. And let's change that price. So let's assume we have a sale, big sale. We'll knock this down to $191.99. We could change the other two fields here as well. Notice, by the way, that we cannot change the ID. We wouldn't want to give the user that option. That's basically set by Postgres. We can save the edits. We can go back. We get a confirmation. Let's jump down. Lo and behold, that's changed to $191.99. So we've done the show. We've done the edit. The edit, of course, is the U or the update in CRUD. Now let's do the delete. We could delete any of these, but let's delete the one we just added. So we click delete, and another JSP script executes, and we get this, are you sure? Eventually, by the way, we'd want to do this in JavaScript for efficiency reasons. But right now, we're going back to the server. We're getting a JSP script that says, in effect, are you sure? If we cancel, of course, nothing happens. But now we'll do it for real. So if I do the delete again, and I confirm that I want to delete that product, the product is deleted. I get confirmation. If I go back down to the bottom, you can see, of course, that that record has been removed from the database. Now, the code that carries all of this out is basically the SQL package and JSTL. We don't really have any application logic beyond talking to the database, and so JSP is good enough to pull all of this off. As I mentioned in an earlier lesson, what you really have here is a style for a web interface that is inspired by Rails. This does not follow exactly the Rails style, but it's fairly close. I'm now going to jump to my Emacs editor. I've got a little working file called JSP-CRUD.txt. By the way, the entire application, this file, and some other files we'll be looking at later, I'll put those all together in a zip called JSP-CRUD.zip. That will include the WAR file with the source code, and so forth. So in any case, this page summarizes the flow of control. The welcome page, the main page, is ski-stuff-crud.jsp. Again, just for very quick reference, that's this page. That's our welcome page. And then there's a series of other pages which basically come in pairs. So let me jump down here to the end. For example, if you want to create a new piece of ski equipment, you get a form. It's an empty form. That's create.jsp. And when you submit that form, a post request goes back to Tomcat and basically tells Tomcat to take that request and send it to save.jsp. So save.jsp needs to read the data that the user entered and then do the appropriate update to the database. We'll look at those details, of course, in a bit. Edit.jsp, I send that to save edits. Notice, by the way, create and edit are very similar. Create has a form that's empty. Edit has the same form, but basically it's filled with the current data. You can change those. So the first two pairs are very, very similar. Delete is a little bit different. When you pick delete, there's basically a link, and that link takes you over to delete for sure, which asks for confirmation. Eventually, we'll do that sort of confirmation with JavaScript, both for efficiency and for a better user experience. It'll run faster, it'll look better, and so forth. In summary then, what we have in the JSP-CRUD Web App is a front end to our Postgres database, in particular to a single table, skis, etc. And this is the form. It supports all of the CRUD operations, the creation, the read all, the read one at a time, the update, which is edit, and the delete. In this lesson, we're going to focus on some database issues that arise in the JSP-CRUD Web App. Just for a quick refresher, here's the welcome page for that web app. We looked at that in the last lesson. And in my Emacs editor, we're looking at dbsecondlook.txt. This is included in the zip file jspcrud.zip. So let me begin by describing one problem. When I first created the skis, etc. database table, for the price field, I picked the PostgreSQL data type real. This is a 4-byte floating point type. It corresponds basically to Java's float type. And the problem is that the Java float type and the Postgres real type are not well suited to represent currency. There are problems inherent in binary decimal conversions. There's information loss and other problems. We can't get into the full details now, but the point of interest is that the Postgres data type decimal is better suited to represent money. It's basically intended to support arbitrary precision arithmetic. In Java, you get that sort of support from, for example, the big decimal data type. And there are also standards such as BCD, binary coded decimal, that are intended to address the problems in going from binary to decimal representation. The point that I want to make is decimal would have been a better choice. I didn't realize it, let's assume, until later. So now what I need to do is change the schema, the structure of my table. In general, this is a bad idea after you've entered data, and we've done that. In this case, we'll be okay because real and decimal are both numeric types, so we're not going to lose any data. The way I did this is I opened up PSQL. You can do this in a number of different ways from the command line, for example, but there you see my little Postgres guy. If I come back here, you'll see that I've already opened it. Here's the icon for it. When I open up PSQL, again, I get this little window. I'm not going to enlarge it, but that's basically what I worked in. So let me close this and go back to the Emacs editor. Of interest is what I entered, and this is the command right here. So I said alter table skis, etc. That's our equipment table. Column price, change the type to decimal 10-2. So decimal, again, is a numeric type. The 10 represents the number of significant digits. It's called the precision in the Postgres documentation. The 2 represents the number of digits after the decimal point. In Postgres, it's called the scale. So I made the change to the database, and thank goodness, no data were lost. I then did \d+. I'm basically asking Postgres to tell me everything that it knows about the skis, etc. table. And here's the output I got. I got information about it. So if I come over here to the left, you can see the columns. And we've seen these before. ID, product, category, price. The next column is the data type. Integer for the ID. Character varying for the product and the category. And then you see numeric 10-2. So decimal is basically an alias for numeric. And then some other properties to the right. Postgres, by the way, has automatically created an index for efficiency reasons on the primary key, the ID. So it's fast to, for example, sort and search by key. Now let me switch gears a little bit, and I want to talk about some of the code we're going to be looking at in the next lesson. Because mostly what the JSP-CRUD app does is talks to the database. And it does that via queries, and we're using the JSTL SQL package. So some of the queries are very simple. For example, in show.jsp, you get this query, select star all from skis, etc., where ID equals, and that param ID, more of that later, but intuitively, this is basically the ID associated with a particular piece of equipment. Again, for context, let's jump back here. So Scott Synergy is basically the first guy. If I want to show that, you see the ID here is 101. We get all of the information about Scott Synergy. So we pick up that ID and display. Other queries are a bit trickier. Here's save edits, which is a bit of a mishmash deliberately. This is not best practices by any means, but I wanted to show you various styles to use. So this is going to be an update query, as the name tells you. And so I start out by saying update skis, etc. Set product equals question mark, category equals question mark. This is a so-called parameterized query. Sometimes it's called a prepared statement. It really is the way to go. For security reasons, if you're dealing with usernames and passwords, you absolutely want to go this way. I'm doing it here to introduce the syntax. So the question marks are basically placeholders, and the values then come in order from the param statements. So the first question mark becomes the product. The second question mark becomes the category. Now for the price, I've reverted to old-style JSP expressions, and I've done it for one reason mainly. That's convenience. I find this is an easier way to go than to use new-style expression language. I also want to underscore that you can intermix old-style and new-style JSP. The reason this guy is tricky is the price, of course, is a numeric value. I'm getting the price as text from the user. I need to convert it. So I'm using float, parse, float. And we've already talked about how this is a bit tricky because we're going from decimal to binary. And then the ID, of course, is picked up as usual. These parameterized queries in general are probably the way you want to go. They're clean. They make clear what the underlying structure of the query is. And they also help to thwart so-called SQL injection attacks. Later on, when we talk about security, we'll focus a bit more on that. But I wanted us to have a first look. So when we go in and inspect the code in the JSP-CRUD Web App, we're going to see lots of queries. The one you see here from Save Edits is about as tricky as any of the queries is going to get. We're going to take a closer look at the code in the JSP-CRUD web application. Yet again, I have my browser open. We're looking at the welcome page. It lists all of the ski equipment inventory items. All of the CRUD operations, again, are supported. We can create a new product. We're looking at reading all of the products. We can read them one at a time. We can delete. And I'm going to focus on edit because that code is representative of the rest of the code. So let me click this just by way of review. We get a little form to do the editing. All 4 columns are displayed. However, the ID is read-only. I've got my cursor pointed there. I'm clicking, but notice I don't get focus because I can't change anything. I could edit this, I could edit this, and I could edit this. Let's edit this to $499.99 just for the fun of it. We'll save the edit. We get confirmation. We go back and we confirm that indeed the price has been changed to $499.99. What I'd like to do now is look at the backend code to get a sense of how the browser, HTML5, and the JSP script itself all work together to provide the functionality that we see here. So I'm going to jump into my Emacs editor. We're looking at edit.jsp. That's included in the zip file, but I'm going to break it out separately in the working files as well because I've reformatted it. So a quick overview. I set the error page to error.jsp. All of the JSP pages share the same error page. Here are the tag lib references to JSTL. I'm using core and SQL, so those are both included. I have a reference to my style sheet. Let me show you that very quickly. So that's just called style.css. My visual styling is, as you already know, a work in progress, but I want to give you a sense of the size. So as you can see, it's about a page and a half or so of styling information. In the JSP templates themselves, I also have a little styling because sometimes I need to override. So let me go back now to edit.jsp. The SQL set data source we've seen any number of times. That's unchanged. And the query in question is a select. So we select from the table where the ID matches the parameter ID. Remember, that parameter ID comes along for the ride, but it's read-only. It cannot have been edited. What we get back is a list. There's going to be only one item in that list, so we're going to pick the first and only item in the list in order to populate the controls that you saw, the input boxes for editing. Now let me jump down here. This is the all-important HTML form. It extends from this line all the way down here, and right near the bottom there is a submit button. When that button is clicked, all of the input items, there are 4 of them, all of those input items are sent via a post request to saveedits.jsp. So recall that modern browsers issue GET requests. When you type something in the URL window, when you hit a hyperlink, those are typically GET requests. And they also generate POST requests. Those typically come in a submitted form. So you can see here the HTTP method is POST instead of GET. Let's go over this a little bit. So as noted, I do some overrides on my styling here. I'm going to come down to this input and notice there are 2 attributes. One is called ID, another is called name. Some web frameworks, for example Microsoft's .NET, trigger things off the ID. Other frameworks, Java in particular, go off the name. On the receiving side, when this form is posted, the way we would get the value of the ID is by referencing the name, and the name is ID. So to keep this simple, my practice is this. I usually set both ID and name, and I set them to the same value. However, we could delete the ID attribute and things would work just fine. The value here is the param ID. I'm using new style JSP, the expression language text, and this is very nice read only. So my browser, I'm using Chrome, knows HTML5, it's going to enforce this. It's not going to let anybody edit this field. As you move on down, all of these are pretty similar. This is the product. The type is text. That's editable. This one, same idea. Text. It's editable. This one is a number. The step is 0.01. In other words, that means I could change the price from 9.98 to 9.99. And the minimum value is 0. So we're not going to have negative prices. Wouldn't make any sense. And again, this is the submit button. Way down at the bottom, what I'm trying to do here is to illustrate some of the so-called implicit object references you get in JSP. So this is a hyperlink. This allows us to go back to the welcome page and notice the expression page context. Recall that in Java, a context is really everything we know about something. At the implementation level, it's a map. That map includes the request object reference and the context path. The context path is basically the path to my WAR file. In this case, we call that thing JSP-CRUD. So if you go to JSP-CRUD/ski-stuff-crud.jsp, that's the welcome page. So again, if I revert to the browser and do the edit thing, and then hit back, I'm back on the welcome page. This is a little bit cluttered. Anytime you have a templating language, you have a mix of, in this case, JSP and HTML. It is a little bit cluttered, but the nice thing is we're able to do basically this entire web interface in JSP. There's really no straight Java code anyplace. I'm using JSTL pretty much exclusively. A little bit of the core JSTL, but mostly the SQL package therein. So the clutter is something one gets used to over time. What's nice is that this is relatively simple to do. And just as proof of concept, let me bring up the create.jsp page. It's not quite as nicely formatted, perhaps, similar, not exact, but you get the idea that this is very, very similar. The only difference here is that there is no SQL query because we're presenting the user with a blank page, basically, a blank form. In the case of editing, we're presenting the user with a form with data already in the fields to be edited. So that's the overview of the backend code. If you look at the other JSP code, you'll see it is simpler than what we've looked at in edit.jsp, but it follows the same general style. I'm going to suggest a programming exercise. You're looking at my Emacs editor. The working file is called exercise-pagination.txt. It goes over the approaches that might be taken, but it's easiest if we return to the browser and just look at the JSP-CRUD application once again. So here's the welcome page, and the downside on this particular machine is that I have limited screen real estate, so I can't show all 20 records at once. Basically, I get about 13 and a half. And so the user is forced to scroll up and down, and that's not very pleasant. That accounts for the fact that I have these create a new product at both the top and the bottom. Normally, we'd have that link one place only, not both places. So the exercise is to paginate this application so that, for example, maybe we would display 8 records at a time or 10 records at a time, whatever number we decided. Now let me go back to the Emacs editor, and we'll come back to this screen momentarily and talk about approaches to this. One approach, of course, is to roll your own. In other words, to implement pagination on your own. The upside of that is you would get exactly the functionality that you needed and nothing in addition. So you would have written the code. It takes a little time. It's a good exercise, I think, to learn JSP. But the real upside is you get lightweight. You get what you need, nothing more, nothing less. And the obvious downside, of course, we know this as programmers, is that you have to write it. And if you're like me, you'll underestimate the amount of time that it's going to take to write it. That's notorious among programmers. Another way to go is to get a pre-built, customized tag library, something akin to JSTL, but provided third-party, and I'll give you an example of that momentarily. And the nice thing there, of course, is that the functionality is supplied for you in a library. It's a nice way to go. One downside is that you have to learn the API, and the related downside is that the API may be more complicated than you need. You may have features in this customized library that you don't want, you don't need, and that just get in the way. In other words, too many bells and whistles. Let me note that more advanced Java frameworks, and we'll see an example of this later, provide pagination out of the box, but JSP does not. So this is why this is a nice exercise. The pagination exercise is nice for JSP. Now let me go back to the browser. I've got a link to this next page in the exercise document. And this is displaytag.org 1.2, and you see on the screen an indication of what this little library can do. What they're showing in this particular example is 8 records at a time, and they have little links. You can see it down here, little links in gray. So we're looking at the first set of 8. We can get the second set of 8, the third set of 8. There are little links to go to the first page, to the last page, to the previous page, to the next page. So you would want functionality akin to that. For this exercise, if you do it your own from scratch, you should do whatever strikes you as reasonable, whatever you have time to do. Down at the bottom is an indication of the downside I was referring to. Notice what you also have here are some export options, so you can take these data, export them in CSV format, in Excel, in XML, and so forth. This is not something you may want. This is built into this pagination tag library, but it may not be a feature that you really want, and so it represents for you and I clutter. It just gets in the way. In any case, I hope that you'll have time to give this a shot. These sort of exercises really teach you a lot. You'll know JSP a lot better after the exercise than you do going in, so it's nice to get your hands wet with this sort of thing. So as I said, I hope you have time to give this a shot. This lesson focuses on a critical part of all programming, which of course is debugging. In my Emacs editor, you're looking at the working file debugsteps.txt. It provides an overview of what we're going to be doing. I'm not going to cover each and every point in detail right now. Let me just talk a little bit about the approach I'm going to take. If you're using an IDE, Eclipse, NetBeans, IntelliJ, that sort of thing, they provide excellent support for debugging, but my goal is to be IDE neutral and to get as close to the metal as possible. So we're going to be looking at the side of debugging that is used by these IDEs. We're going to go a lower level. These IDEs are excellent at debugging, but we want to understand exactly what's going on, what sort of problems can arise, and what sort of information the IDEs are exploring. Testing, which is related, of course, to debugging, is equally important. We're going to look at that, but that's going to be a bit downstream. So let me explain the strategy. What I've done for an example, I want as simple an example as I can get. So I'm going to revise the introductory example, which does temperature conversions. So let me run that for you. 1, 2, 3. We'll just take a simple example. I'm going to convert that to centigrade. As you can see, it works. So far, so good. Now, I'm going to go into my text editor, Emacs, and I'm going to go into convert.jsp. By the way, all of these files I'll put into zip for convenience, and they'll be called debug.zip. If you recall, in that JSP script, we had some old-style JSP, JSP 1.0. This, again, is a declaration. This is a little code snippet down here. Part of it is commented out. I'll come back to that in a moment. But in the declaration, I declare two variables, one called far for Fahrenheit, one called cent for centigrade, and I use those variables in the code below, so I'm going to change cent to centigrade. This should break the program. So I want to give you an idea of the challenge that arises. So let me save this and go to the command line, and let me now deploy this. So I'm going to deploy as usual with my Ant script. It's deployed successfully, and this, of course, is misleading. We're going to have an error, but the error is going to occur when we test it because, again, that JSP script, after it's deployed, is going to be translated into a servlet instance. In other words, the build script is not going to pick up the problem. The problem is going to occur at a later time, and it's going to occur right here. So let me refresh, and let me go back and do 1, 2, 3 again. This time, there's going to be bad news. We go to convert, boom, we get an error. This error page is helpful because we're using localhost. In other words, the browser and the web server are on the same machine. I get from Tomcat a lot of valuable information. I think you'll find it's very useful. IDEs, by the way, suck up this information and present it to you. So as you can see, the big error, this is an HTTP 500. If you're a server-side programmer, you hate to see this guy. That means you did something bad. Unable to compile class for JSP. And then the particular reason it gives you is this. There's an error at line 25. That's right here. And it's complaining about this, as it should complain. It's saying basically there is no field called CENT. We change that. And there's a related error down here at line 34. Same deal. There is no CENT. So if we go back into the Emacs editor, of course, and fix that, save it, just as proof of concept, and rebuild. I'm going to do that very quickly. We don't care so much about the details. and go back to the browser. Be very careful. Give it a moment to make sure it's redeployed. What I'm now going to do is 1, 2, 3 yet again. Kaboom, it works. Now let me go back to convert another temperature and to point out a related problem. The first lesson, if I could summarize, is this. Tomcat, if you're working in development mode on localhost, is going to give you very good error messages, including, as we just saw, line numbers at which errors occurred. I'm now going to introduce a more subtle error. Instead of entering a temperature, I'm going to leave this blank. I could, of course, put in foobar or something else silly, but I'm just going to leave this blank, hit this, and as you can see, I got another error. An exception occurred processing the JSP page. Again, very helpful. Tells me the line number, 24. So here's what it didn't like. I tried to do float value of far as string. And far as string, unfortunately, is the empty string. The same error, by the way, would occur if I did something like this. We do the standard foobar thing. We get exactly the same error because we can't convert the empty string or a string consisting of non-decimal digits into a number. So we have a problem. Now there are various ways to attack this problem. Let me come back here to my editor, and I'm now going to go to the input page, input.html. So this is HTML5, and if you come down here to this line, we have an input box. Notice that the type is set to text. That's not really the appropriate type. In earlier versions of HTML, we might not have had a choice here, but I can change this from text to number, and I can also change step, or introduce, I should say, step to 0.01. This will allow me to enter, for example, 99.02, 99.99, that sort of thing. So I can get some data validation from HTML5. So let me now do this. So I'm going to save this. Once again, I'm going to return to my bash prompt, and I'm going to redeploy. So I've done the HTML fix. Let me return to the browser. I'm doing this to give Tomcat a little time to make sure it's redeployed. Good, it's redeployed. I'm now going to come here and I'm going to try to enter foobar. Notice it won't let me. I'm going to try to enter nothing. When I enter nothing, I still get the error. So I need to fix that problem. I'm going to go back, but at least it corrects the foobar part. We'll put in 99.0. And notice with that in place, we're okay. So to summarize where we are at this point, HTML5 has helped us with the foobar problem, but not with the empty string problem. We could fix that at the HTML5 level, but even then, we'd have a problem. Maybe the browser we're using doesn't support HTML5. Maybe it supports some of the features, not all of them. So what I'm going to do for the sake of robustness is go back to my code to convert.jsp, and I've cheated a bit. I've already written the code, but commented it out, so I'm going to uncomment it and then summarize what I've done. What I now have is an if-else construct. At this line, I'm reading from the request the temp f that the user has input. This is coming to me again as text, so in Java as a string. Now what I'm checking here, and this is always a good check, first of all I want to make sure I didn't get null, and then I want to make sure that the length of the string was greater than 0. I'm depending again on the browser to make sure that those are only numerals that are entered, if anything. And then I do the conversion as usual. If there's some problem, I need values for far and cent, because down here in this expression where I give you the answer, I use both far and cent. So I need default values, and just for emphasis, I'm picking the minimum value for a float in Java. This is not a completely satisfactory solution, but it shows you the spirit of the sort of code that you need. what we have to do in effect is be highly skeptical of user input. Eventually, we'll turn to regular expressions to do that, but for now, we want to work our way up. Let me go once again back to the bash prompt. Let me redeploy yet again. Return here. What we'll do is try the foobar. Still doesn't work. 4, 3, 2, 1 should work. We'll go back. We'll now try empty string, and that works. And as you can see, we get these humongous numbers, which are the float min values in Java. This has been our first look at debugging. What we've done is broken some things and done some fixes. What we'll do in the next lesson is expand this theme, and we'll talk about how Tomcat can come to our aid in debugging. In this lesson, we're going to continue with debugging. Let me review quickly what we did the last time. In order to make the temperature conversion web app more robust, we used two tools. First, an HTML5 input control that ensured that we couldn't enter strings such as foobar or ABC instead of numbers. Basically, the HTML5 control ensured that we had only decimal digits, the plus, the minus sign, and the decimal point. And then we use back-end code to ensure that the user input was not blank. We can use the HTML5 also to ensure that the user does not input the empty string, and we'll do that momentarily. And I'm also going to do a slightly more robust back-end code data check. The reason for this is the following. The normal way that users are going to hit our web app is through a browser. And so the HTML5, if you have a browser that can handle it, and Chrome of course can, the HTML5 can provide some data validation protection. But the user might be using something else, a utility such as curl, an arbitrary application, and so the bottom line is basically this. The back-end code needs to assume that the user input could be tainted. We need to safeguard against tainted code, and we're going to do that. Eventually, we'll use regular expressions. They're wonderfully powerful. They're perfectly suited to this task. But in this example, I'm going to use some old-fashioned Java to do basically the same thing, to guarantee that what we got was numeric input. I'm going to push on to a second theme, and that's the Tomcat log files. Under Tomcat Home Logs, you have an extensive number of log files. In fact, occasionally in a production environment, you need to clean out that log directory. You're typically going to use a tool to do that for you automatically. But the log file of interest for us is one called Catalina.out. We're going to use this basically to do a little bit of tracing. I'm not going to do anything significant in this example, but we will get the idea. So here is the idea. Suppose you're doing a lot of back-end processing. You're massaging the data, filtering data, doing all sorts of things. It can be very helpful to log intermediate results. In fact, this is often critical for debugging. Tomcat gives you a nice, familiar way to do this. In Java, when you print to system out or system error, the output normally goes to the screen. But the web container, Catalina, in the case of Tomcat, will redirect such output to the Catalina log file. Very, very helpful. So now let me turn to the changes in the code. First, this is input.html. Again, what we want to ensure now is that the user cannot enter an empty string. That's easily done in HTML5. You have an attribute called required. So all I did was add required to the end. And now let's look at convert.jsp. So I've made the following changes. What I did last time, I've just commented out, so you can see it here. So again, I read the user input. I then go into a try block where I try to convert the string into a floating point value, and then do the centigrade conversion as well. If that fails, because of a number format exception, I got the empty string, I got foobar, I got something that's inappropriate, Then once again, I set the two temperatures to the minimum floating point value. That remains a hack. In a production environment, we would need something better. Finally, way down here at the bottom, I have a system out println statement. System.err would work exactly the same way. So this basically is going to perform customize logging. It's just the old hello greeting, but we're going to be able to inspect that this occurs in Catalina.out. So let me now jump to the command line. And just for good measure, let's redeploy this. Make sure the fix isn't in here. We'll go and run it. So I'm going to open up Chrome. I'm going to try to submit the empty string. Notice Chrome is not having any of it because it sees that required flag. I'm going to try to enter foobar, having none of it. 1, 2, 3, 4, 5. Boom. We get the sort of conversions we would expect. Back to the command line. Let me clear the screen. I've, of course, tested this before. So on my machine, Tomcat 8 is in my home directory. Logs is immediately under that. And here's Catalina out. I've cleaned this out fairly recently, but you can see there's already quite a bit in there. And now you can see those prominent highs displayed. There's one about a quarter up from the bottom. That's because I did some testing earlier. And then the one at the very bottom is the one that we just generated by running the program. Let's go back to debug2.txt. In summary then, the 2 points of interest are this. We need to take the mindset that any data we get from users might be bad, might be tainted. We need to protect against that. And over the course of forthcoming examples, we'll take different approaches, most of which will center on the use of regular expressions. Tomcat has wonderful logging facilities. We can easily do customized logging, which can aid in debugging just by putting system.out and system.error statements in our own code. In this lesson, we're going to focus on parameter passing. That is, how data get from the web browser via input controls over to our web app. We've seen this in action. We've looked a little bit at the code, but in this lesson, we're going to drill down into the details. Let's start with a general point. Recall that a modern browser generates only two types of HTTP request. A GET request. So for example, when you type something in the URL window up here and hit return, the browser generates a GET request. The browser also generates a GET request when you click on a hyperlink. So I'm going to click here just to demo and then immediately go back. The other type of request is a POST request. That's typically generated when a HTML form is submitted, and all of the data then become the body of the HTTP POST request. Let me go over this demo a little more carefully, and then we'll drill into details. The first product in this table has an ID of 101. If I click delete, we're going to get a GET request, and the data are going to be passed over to this other JSP script called delete.jsp. You can see that the 101 is picked up here. The data are basically sent here in a query string. You can see that here in this line. I'll highlight it. You see the question mark after delete.jsp. That introduces the query string. You see ID equals 101. So the query string consists of key-value pairs. Technically, you could have just keys with no values, but normally key-value pairs, if there are multiple ones, you would have an ampersand separating each one of them from the other. So let me go back, and now let me do something slightly different. I'm going to edit this first item. I'm going to change this to 499.01, and then do Save Edits. And you can see that the edit took. This results in a POST request. There's an HTML form that represents the data to be edited, the product, the category, and the price. And when the Save Edits is hit, this is the Submit button. Those data are packaged up and sent over to our web app. What I'd now like to do is drill into the details at the code level. So I'm going to bring up a working file called parameters.txt. At the beginning, I review what I just went over, and in particular, I talk a little bit about the format of the query string, the keys and the values, and I talk a little bit about the post request. What I'd like to do now is focus on these in the flesh. Let's start with the query string example. So in the welcome page, the table that we were just looking at, there's a delete link, as you know, for each of the records. And basically, the underlying code looks like this. When you click the link, so the term, of course, is delete. You see that way at the end. Basically, what happens is that the browser is going to generate a GET request for delete.jsp, and here we see the query string, ID equals param item ID. And of course, item ID is the EL expression in JSP2, and for the first record, it's going to be 101. So basically, that ID is sent over to delete.jsp. In the main part of delete.jsp, you get this, are you sure you really want to do this business? And notice what we pick up on this side is param ID. What we care about right here is param. That's one of those implicit object references that you get in JSP 2.x. It represents all of the parameters sent in on the request, whether the request be GET or POST. I'll come back to that point momentarily. And of course, you have the option of canceling or of actually deleting the product. And if we delete the product, we're going to call delete for sure JSP. And again, we're going to send the ID along for the ride as a query string key value pair. The key is ID, and the value again is the param ID. Now let's look at a post request example. This basically is the form for creating a new piece of ski equipment. And as you can see, there are various inputs. Let me put the cursor here in a little more useful position at the beginning. Here's the input for the product name, the input for the category name, and the input for the price. All of this occurs within, notice, a form. So that's the important thing up here. The action for the form is save.jsp. So when this form is submitted, the data are going to be sent to save.jsp, and you'll notice at the end, the method is post rather than get. The submit button is down here. So the submit button within the form, when clicked, causes the data in the form to be packaged up and then sent via a post request, in this case, over to save.jsp. Here's a little summary of what's going to happen in this case. You actually have three things of interest. There's the product, the category, and the price. Recall again that Java triggers off the name attribute, not off the ID attribute. But just to be safe, for each of these inputs, I do this as a matter of habit. I set the ID equals price. You could delete that, wouldn't change a thing. And name equals price. Name is what JSP is going to care about. Now let me talk about the very good news in Java. It's had this from day one, and it's an excellent idea. Regardless of whether the data come in a query string or in an HTTP form, Java doesn't care. It's going to, and by it I now mean technically the web container, is going to take those key value pairs, put them in a map, and deliver them in a usable way to you and me, the programmers. In JSP 2.0, so what I've been calling new style, the name of that map is param, P-A-R-A-M. In old style, there's a little more typing to do, but it's the same basic idea. So to illustrate the old style, what I'm doing here is going to the save.jsp. So we're basically going to create a new record. You see insert into. And now here's the important thing. You see request. That's an implicit object reference. It represents the HTTP request, get or post, get parameter. We're going into this map and get the thing with the name product. Has to be spelled exactly like this. So the name attribute on the HTML side has to match this. And same thing for the category, and then the same thing for the price. For the price, we have to do a little bit of parsing, that sort of thing. New style is a bit friendlier. You can see down here with new style, we pick up the ID just by doing param ID. We can pick up param product and param category. By the way, in new style, there is an alternative syntax. You could have written here param square brackets quote ID square brackets, but I prefer the dot notation, easier to type, less error prone. In summary, Java is very friendly with respect to delivering user data to our application, regardless of whether the data happens to be query string data. Those data travel in the HTTP header because a GET request has no body, or HTTP form data from a POST request. In either case, it's the parameter map that's of interest to us, and we'll see many more examples of extracting data from that map and using those in our app. We're going to do a quick overview of the JSTL libraries and then take a look at one of the very useful ones that we haven't seen so far, and that has to do with formatting. In my Emacs editor, you're looking at the working file JSTL-overview.txt. This is included in a zip file with the app we're about to see, and that zip file is called format.zip. So it contains the war file, this text file, and of course all of the source. So let me do the quick overview. Of the 5 JSTL libraries, we've seen 2 of them so far, and we've used them fairly extensively. There's the aptly named core library. We've seen, for example, cset to set variables, C for each. We've used that to loop through the rows of a table, CIF to check whether an SQL update succeeded, that sort of thing. And the directive for that, in other words, this would be included at the top of the JSP page as we've seen, you see on this line. The prefix C you see over here, this is actually arbitrary. We could call it something else other than C, but C is standard. It's the URI that's really important. Eventually, we'll hone in on the details of this XML syntax. The SQL library we've also used quite a bit. Very convenient. It eases the task of talking to the database. I think it's just terrifically well designed. And we've seen, of course, set data source and query quite a bit. You see the directive here. The URI, again, is the important part. The format library is particularly useful for so-called I-18N tasks, that is, internationalization tasks. So, for example, we want websites that display the date in one way, for example, for Spanish-speaking countries, and it might even differ between, for example, Mexico and Spain. We want to do data conversions. We want to take a number and convert it to currency, that sort of thing. The format library is ideally suited for that, and I'm going to do an app on that momentarily. The last 2 libraries I don't find to be all that useful. The XML library allows you to do XML processing in JSP pages. I much prefer to do that in behind-the-scenes code, but that's a preference. The XML library is available, and eventually we may take a short look at it. There's also the JSTL functions library. These are mostly string manipulation functions, and again, my preference is to do those sort of tasks in code behind. But you could also do it using this library, and I've given some examples. Now, let me run the app. Let me show it to you. The war file is called format.war. It's very simple. It just illustrates the possibilities. So let me walk through this page and explain what's going on. Under Number Formats and Conversions, you can see in the very first, I've got unformatted. I've just got a floating point value, 1234567.8912, and then I formatted in various ways, 1 through 8 below. So you see here, obviously, currency. Here I've got the same number of digits to the left and to the right of the decimal point. Not too meaningful, of course, just a proof of concept. Here, similar to currency, but without the $sign. So the $sign is thrown in. As you'd expect, it could be the pound sign, the euro sign, the yen sign, or some other sign. The next formatted line 4 dispenses with the commas. All things are possible. The next 3, 5, 6, and 7 show various ways to format percentages. Again, don't worry too much about the values. I haven't done anything meaningful here. I'm just showing you the formatting possibilities. And then finally at 8, we have so-called scientific notation format. The E6 basically shows how many positions to the right the decimal point should move. For conversions, I take this unformatted value all the way up here. That's a string, convert it to a floating point value, and then convert it to an integer value. So these are basically parses. And we've seen that in Java code before. The date formats, I've got various examples down here. The local time, CST, is Central Standard Time. I'm in the Midwest. And by the way, this is live, so if I update this, you're going to see the times are going to change slightly. So this is the typical Java date two-string format. You've all seen that at one time or another, no doubt. This is formatted for Germany. So the small DE is German and the big DE is the German in Germany, as opposed to the German in Austria, that sort of thing. English US, English UK, they happen to be the same. And then I just show various possibilities. Sometimes the whole date, sometimes the short format, sometimes the medium format, sometimes the long format. Now let's look at the source code for this to get a better sense of how much code is involved. As you're going to see, not too much. The WAR file again is included in the zip. Here are the tag lib directives. As usual, I'm using all of the standard prefixes, C for core, FMT for format. And I start out by using the core to set the variable sample to the value, as you see on the right. So sample is essentially a string variable. So then I print that out, and now we go into some formatting. The first one, currency, extremely useful. The next one, we start playing around with the maximum number of integer digits, the maximum number of fractional digits, and so forth. We do some grouping, some max and mins on the digits. All things are possible. So mostly I'm trying to suggest here some possibilities. And then finally down here, this is the scientific format. We can get very elaborate, if we like, about how the layout is to occur. The format parse number I find very useful. I did an example earlier when we did debugging, but I did that actually in straight Java code. We could have also done it this way by using this format function. So you can parse a number. The first case is a floating point. The second case, you can see at the end, integer only equals true. That attribute basically truncates the value. And then down below are the various examples of formatting the time. So 7 in all. This will give you a good sense, I hope, of the possibilities here for formatting and how useful this particular library is as well. In summary then, I find myself using core, SQL, and format pretty often. Once in a great while, I use XML and JSTL functions, but again, you should explore on your own and see what works for you. In this lesson, we're going to return to the temperature conversion example. It's slightly different than the earlier versions we've seen. We've seen 2 so far. The introductory example was 1, and then in the debugging example, we fixed some things. The idea now is to try to follow best practices, to put everything together, and to come up with a JSP example that implements separation of concerns, a very important principle in modern programming. So let me start with the demo. I've got my input screen. It just asks for a temperature. The temperature I give it is going to be converted 2 ways. First into Fahrenheit, then into centigrade. So I'm going to try to enter the empty string. That doesn't work. I'm trying to enter ABC. That doesn't work. So we're using HTML5 to control the input. We'll also do some data validation on the back end. So let's do 1, 2, 3, 4, 5. Boom. And let's try one more for good measure. Just for integrity check, we'll do -40 again. It should be the same in both scales, and it is. Let me turn now to my Emacs editor, and you're looking at tempconverter.java. The working files will include the deployed war file, which will be temp-pojo.war, and it includes the source code. I've included here as a comment an overview of the pieces. So the style sheet, style.css, is now broken out separately, as it should be. Input.html we'll look at in a bit. It's straight HTML5, and it provides some support for data validation on the browser side. Convert.jsp has changed quite a bit. It's mostly templating now because the back-end data validation and application logic are performed by the class that we're looking at. And that, of course, is tempConverter. As you can see here, this is a straight POJO class, plain old Java object class. It doesn't implement anything. It doesn't explicitly extend anything. It's got one public method, convert. It takes in a string, and it returns a string. And the first thing it does, of course, is data validation to make sure that that user input, temp, represents a floating point value. It tries to parse float. If all goes well, it does the conversions. Otherwise, it's going to return bad input. The private methods F to C and C to F do the actual application logic. They do the conversion, but this is the only public method exposed. Now let's turn to convert.jsp, because that's really the biggest change. Now I've included an error page, again, just out of best practices, but you can see that this is mostly HTML5 and a little bit of Java code, and the important piece of Java code is here. This is a customized tag, JSP:\useBean. I've set two attributes. The ID, temp converter in this case, is going to act as an object reference later on. So that temp converter is this temp converter. So it's a string up here in useBean, but it's used as a straight object reference in the expression language. And I need to specify the class. I've got to give the fully qualified name, tempc.tempConverter. Then, in the expression language, it doesn't get any cleaner than this. I use the object reference, I invoke the convert method, I pass in the parameter tempIn, and we'll take a look at that now, because that, of course, is in input.html, and you can see that right here. That's the name of this input control, which accepts numbers. Input is required. We limit the input to numbers instead of arbitrary strings, and so forth. If we go back now to the backend Java bean, what we have here is a much better example of a JSP application than we've seen so far, precisely because of the separation of concerns, and principally because we've taken the data validation work and the application logic and put those in a backend bean. The JSP script, convert.jsp, is much cleaner, and input.html is, as before, straight HTML. This will be a good example for us going forward as to how things should be done. Increasingly, the application logic and that sort of thing is going to be confined to back-end code so we can keep the templates as clean as possible. This lesson is a wrap-up of the main points we've seen in the JSP and JSTL examples, but it's also a look ahead to what we're going to be doing next. So first, the review. JSP, as we've seen, is really designed to do HTML templating, but the examples I've shown have used it to do a bit of everything. There's been some templating, there's been some application logic, there's been some talking to the database, a little bit of data validation, and so forth, all done in JSP pages. The temp POJO web app does illustrate good separation of concerns. The style sheet is broken out. There's a separate HTML, pure HTML page for data input. The JSP page, convert.jsp, sticks pretty much to templating, and it references a back-end POJO or Java bean to do data validation and application logic. This is a practice we want to follow more now in our applications because we're beyond the introductory stage. We've covered the basics. We now can pay more attention to best practices. In terms of review, keep in mind that JSP does have different versions. There's the 1.x and the 2.x. I've been calling these the old style and the new style. They can be intermixed. There's no question that the expression language in JSP2 is cleaner than the corresponding expression language in JSP1. I tend to prefer it, and I think you'll find this common among Java web application programmers. Once in a while, I revert to JSP1 because I just find it more convenient to do so. Things are easier to do, and programmers should always follow that principle. You go the easiest, cleanest way possible. So as noted, what we want to do as we move forward is to practice clear separation of concerns. And so I'd like to turn our attention to the model view controller architecture that's become so popular in web development. A lot of this popularity is due to the Rails framework. Rails certainly didn't invent MVC. MVC goes all the way back to the Stone Age. It goes back to the 70s and the Smalltalk programming environment. MVC should not be seen as a straitjacket, as a set of rigid principles that have to be followed in exactly one way. It's really a design architecture, so let's go over it very quickly and then talk about how this is going to impact what we're going to do next. So in MVC, I've done a very simple depiction here. You have models, controllers, and views. The idea that these are, depending on the language, different code modules. So, for example, the role of the models is to maintain the application state, the data, if you like, and also to persist the data if this is part of the app. And in web apps, as we've seen, that typically is the case. So models might be classes, they might be JSP scripts that embed the SQL library, and we've seen quite a bit of that. The views on the other end provide the user interface. In other words, what they do is display the models. They display the data, and we want the models and the views to be as independent as possible. We might want to reuse views. For example, there are tabular views, there are hierarchical views. There's no reason that these can't be used with different data. In other words, across models. And models should be designed independently of the views. For example, some of the data validation, in fact, as much as possible, can be pushed into models, and that should be quite independent as to how the data in the models is to be displayed. The traffic cop, if you like, or the intermediary in between, is the controller. And there may be multiple controllers, of course. The controllers, from the HTTP viewpoint, are actually endpoints. In other words, when a client hits a web app, what the client hits technically is a controller. This has been the case for us so far in the sense that our JSP scripts are translated into servlets, and servlets in the Java world are natural controllers. So implicitly, you might say, we've been using servlets as controllers. The job of the controllers, of course, is to help the models and the views to interact in a disciplined manner. Now, I list below some implementation options, how to do these sorts of things. The big missing piece for us is on the controller side because we've not yet looked at explicit servlets. In other words, we've not written Java code that are servlets, and the next examples are going to cover that. Finally, I should note that there are in the Java world some MVC-specific frameworks. The Spring framework is one such example. There are also others, but you can do MVC in a very lightweight fashion as well. That is, without using a specific MVC framework, but rather building and architecting your application in a specific way. So that's a wrap-up of what we've seen so far, and also a hint as to where we're going to go next. This lesson focuses on servlets. It represents our first official look at Java servlets. And in my Emacs editor, you're looking at the working file servletsoverview.txt. So we'll go through this, and that'll put us in a good position to look at some examples. Let me underscore that all of the classes required to do servlets belong to Java EE, Enterprise Java, not Core Java. So we need to pick up those classes in a jar file, and we'll do that through Tomcat. The Ant script does that automatically, but you should be aware that you can't compile any of the servlet code straightforwardly from the command line using just Core Java. The javax.servlet interface declares 5 methods, shown here. I've grouped them for convenience. There's an init method that's called when the servlet is first loaded into the web container. The web container has the freedom to load and unload servlet instances as needed. When the container unloads, then destroy is called on the instance. By the way, the servlet container may have several instances of a given servlet, in which case init would be called on each of those instances. Then there are a couple of methods to get information about the servlet, in particular getServletConfig. We'll see how that comes into play in a bit. The most important method from our point of view is service. It takes 2 arguments. The servlet request represents all of the incoming information. It's basically a map. And the servlet response is a channel back to the requester, back to the client. So that's what allows us to communicate directly with the client. Now, the servlet config interface has a couple of convenience methods: get init parameter by name, get an enumeration of all of the init parameters. These are basically strings. The middle guy is the really important one. getServletContext returns the servlet context. That's a map of core information about the web container. In effect, if a web app wants to talk to the web container, wants to communicate directly with it, it does so through the servlet context. And we'll be putting this to use in later examples. getServletName is pretty straightforward. Now, that's the interface. The generic servlet, as the name suggests, is generic. It's transport neutral. It's not related specifically to HTTP. For example, you might use generic servlets, you might deliver them over SMTP. That sounds a little bit strange, but you could basically support generic servlets on transport protocols other than HTTP. The generic servlet implements the 2 interfaces shown above, together with the serializable interface, which of course is empty. So there's nothing to show there. Basically, the generic servlet adds a couple of convenience methods. There's a no argument init, there's a couple of log methods, but mostly what it does is implements the methods shown above. Now, here's how we do a generic servlet, and the first example for proof of concept will be one. We would write a public class that extends generic servlet, and then we would override at a minimum the service method. We might override init, we might override some other things as well, but this would be the main method because every request against the servlet is going to hit this service method. So it's the primary method. I'm going to do one example of a generic servlet just so we get more familiar with the API, but most of the action is going to be on a subclass called HTTP servlet. It extends generic servlet, and it is now transport specific. In other words, the big difference is this. The generic servlet can be delivered over HTTP, but doesn't really know anything about it. The HTTP servlet knows about HTTP, and so it has some, what I'm going to call, filtering methods. And these filters work basically by the HTTP verb. So for example, there's a do get, a do post, a do put, a do delete, and a few more. I've listed just the 4 CRUD operations. You'll notice that each of these takes 2 arguments, as you'd expect, a request and a response, except these are now HTTP servlet requests and HTTP servlet responses. So the emphasis is on the HTTP part. in the base class, HTTP Servlet, these are all basically no-ops. They don't do anything. So the way you and I would write a servlet is we'd create a public class, any name will do, and we would extend HTTP Servlet, and here's the nice part. We would now override the do methods that are of interest to us and ignore the rest. We can also, for the rest, throw exceptions. When we get into security, I'll cover that option. But to begin, we'll override what we care about and ignore everything else. This is sometimes described as the adapter pattern because what we're going to inherit in my HTTP servlet are the no-op versions defined above in our parent class. So we'll quickly move from generic servlets into HTTP servlets because they're better designed for the sort of work that we want to do. Now, as mentioned right at the beginning, in order to compile any of the servlet code, you need those libraries, and Tomcat delivers them in a jar file called servletapi.jar. By the way, Jetty uses exactly the same name. Other web servers may name the thing a little differently. Occasionally, you'll see a huge jar file called j2ee.jar. That's a bit old school, but you'll still find that around. In any case, if we compile with the Ant script or something comparable, again, you may be using a Maven script or an IDE, then we still have to pick up the classes in that jar file. So that's a very quick overview, just a little bit of orientation. The details will become clearer as we get into some examples, and we'll do that in the next lesson. This lesson covers a Java servlet example, in particular a generic servlet, and the focus is going to be on flow of control, because that changes a bit now that we're dealing with servlets. So let me run the web app for you. As you can see, it looks familiar. The user interface is essentially unchanged, so 123.4, and we get the conversions. We can go back and do it again indefinitely. Let me jump to the command line prompt and show you my source directory. I built this using the Ant script. So you can see two JSP scripts, an HTML page, same as before, the style sheet, the web.xml, which is a bit more robust. We'll look at that in a bit. And let me show you the temp s subdirectory that contains the temp converter servlet.java. That's a generic servlet, and we'll get a chance to look at that code. Now let me show you the jar file that's deployed. It's called gs.war. And the thing to notice is right about in the middle, you'll see the compiled temp converter servlet.class, and that's under webinf classes. So again, in a war file, all .class files have to reside someplace under webinf classes. In this case, in the subdirectory temp-s, and again, the Ant script or equivalent takes care of that. Now let me bring up the Emacs editor. I've got a working file called servlet flowofcontrol.txt, and this goes over the flow of control because things are now a little bit more complicated. By the way, I should note that in that war file, there are no jar files. We're not using JSTL, but we are using the expression language. So, back to flow of control. The welcome page is input.html as before, and the difference now is this. In the input form, the action is set to converter. That's a name. There actually isn't anything called converter.class or converter.jsp. It's just converter. And what happens is the web.xml, the deployment document, handles the mapping. So let me go over the important details. You see here a servlet tag. It introduces a name. Any name would do. I just call this temp c servlet, and it's the name of a implementation class, temp.s.tempConverterServlet. So the fully qualified name is required. Always best to have an explicit package, in this case, temp-s. The important part now is the servlet mapping section. So here's the name again. We're referring to that servlet by its alias, and the URL pattern is /converter. The slash basically means what comes after the war file name. In this case, that's GS. So basically, GS convert/converter gets us to the servlet. So the converter up here under action is the converter down here that takes us to the servlet. The first time this is a little bit tricky, a little bit obscure, but we'll see sufficient examples that it will become second nature. In general, when you're dealing with a servlet, the web.xml file, the config file, is going to handle the mapping. There's some other flow of control. Basically, a client request comes in because of that mapping to the servlet. The servlet does the data validation, it does the application logic. In other words, it does the conversions, but servlets are not very good at user interface. In other words, they're not very good at the visual part of things because they would have to use print statements to generate HTML or some other sort of hack. So instead, the natural thing to do is to have the client request come into the servlet, have the servlet do its thing, and then, again, under the principle of separation of concerns, division of labor, have the servlet send the results to a JSP page and let the JSP page handle the user interface part. And that's precisely what we're going to do in the first example. I think you're going to like this a lot. In the JSP page, there is almost only HTML5. There is a teeny tiny bit of expression language. You see it right here. $, brace, result. Result is an attribute that's been set in the servlet and is picked up in the convert.jsp page. We'll get into the details when we look at the code, but it doesn't get any cleaner than this. So here's a depiction of what happens. The servlet puts an attribute in the servlet requests. It then forwards that to convert.jsp, and convert.jsp picks up that attribute here. The name of the attribute is, in this case, result. That name is arbitrary. So that's an overview of the flow of control. What we'll do in the next lesson, then, is dig into the code details. In this lesson, we're going to focus on the implementation code for the first servlet example, and recall that we're dealing with a generic servlet. In my Emacs editor, we're looking at the servlet source. It's called temp-converter-servlet.java. It's included in the war file gs.war as a matter of convenience. And at the top, I've put some documentation just to review the pieces. So we have a separate style sheet, style.css, that hasn't changed. We have web.xml, which takes over the job of mapping the client request, in this case to something called converter, to a servlet, to an instance of this class. Input.html is the welcome page as usual, and that's where the user inputs a temperature to be converted. We use some client-side data validation with the help of HTML5 and our browser. There's the servlet that does the back-end data validation and the app logic. This is basically unchanged from the back-end Java Bean example. And there is convert.jsp, which is changed, and convert.jsp represents the response that goes back to the client. There's also an error.jsp, but it's generic. I've not bothered to list it here. These imports are all things from Java X Servlet, as you can see, except for the last one, which is a core Java class, java.io.io exception. But these others, all of these class files, are in the Servlet API jar that comes with Tomcat, and for that matter, Jetty as well. Let's get to the main code. So this is the temp converter servlet. As you can see, it extends the generic servlet. It does only one override. You would override this in every case if you were doing a generic servlet. Otherwise, you wouldn't be able to do anything. And this is the public void service method. Again, 2 arguments. The request is everything coming in from the client. It's basically a map. And the response is a channel back to the client. So here's the application logic. First, we get the client input. Request get parameter temp in is the name of the input box on input.html. This is unchanged from the backend Java Bean example. We then validate that to make sure it's okay and do the conversions. That code is also borrowed from the Java Bean example, and then we do the dispatch result to client. Notice 3 arguments: the request, the response, and the result. Let's just look very quickly at validate and convert. As noted, this is pretty much unchanged. We parse the user input. It's a string. We have to make sure we have a legitimate floating point value. These 2 private methods do the temperature conversions. We don't care about those so much. We've seen them a bunch of times. The real interest is this dispatch result to client. So let me pause here. What you can do in general is adapt different tactics for talking between servlets and other parts of the application. Other servlets, JSP pages, whatever they may happen to be. In this case, I'm going to do a forward operation, and in later examples, we'll do other operations. So the idea here is this. The servlet has now done its job. It's done the data validation and the application logic. It needs to pass this result off to a JSP script, which is going to handle the user interface, convert.jsp again. So to that end, we create a request dispatcher, and we're going to be dispatching the request, as you can see, to convert.jsp. We'll look at that in just a second. What we're going to send along for the ride as an attribute called result, any name would do. The string result is the key. The result is the value. So we're going to send that result off to convert.jsp, and that's done right here with the forward. So basically, as soon as forward is called, the GenericServlet's job is done. It said, I've done what I have to do. I'm now going to send off to convert.jsp, which will finish the job. So it's a nice division of labor. So now let me show you convert.jsp, which is wonderfully simple. Java has done a terrific job here. So as you can see, there is a page directive for the error page, but the rest of this is all HTML except for this line, and basically this is just a simple expression, part of the expression language, $result, so the result is picked up automatically. Frankly, Java could not have done this any better. This is about as clean and simple as it's going to get. In summary then, we've gone through a generic servlet. It looks familiar in this sense. What we're dealing with here on the back end appropriately is standard Java code. We have assignment statements, we have try blocks, we have all of the usual things. So servlets are well suited for application logic, including data validation. In this lesson, we'll take our first look at an HTTP servlet. I've already built the web app and deployed it. The WAR file is called http://tc. You can see that in the URL window. Things should look familiar because the user interface, once again, is unchanged. So we'll just do 123.4 to make sure. We get the conversions, and then we can continue indefinitely. Now let me go to the source code. Some things are completely unchanged. The most significant change occurs in the servlet itself, which is no longer a generic servlet. It's now an HTTP servlet. The other pieces are the same, and the difference comes up, of course, in the imports. So you can see that the package name changes from javax.servlet, that's where all of the generic servlet stuff is, to javax-servlet.http. And then we've got the HTTP version, we've got the counterparts of the request and the response, and we're going to do something with what's called the HTTP session, but more about that in a bit. The public class, I'm keeping the same name, TempConverterServlet, and changing only the parent class. In this case, it now changes to HTTP-Servlet, and I'm overriding doPost, one of these various do verbs that basically mirror the HTTP request methods. And you can see the arguments now, again, change from servlet request to HTTP servlet request, from servlet response to HTTP servlet response. The logic is essentially the same. We grab the parameter, that's the same. We do the validation and the conversion. But now, instead of doing a request dispatcher forward, we're going to do a redirect. And I'm going to explain that in just a moment. First, however, I've got something that's a bit controversial. If you look at input.html, let's do that very, very briefly, just to remind ourselves. So we'll go back up here and take a very quick look at it. Notice that the submission method here is post rather than get. It's possible, of course, that somebody might send us a GET request instead of a POST request, and the question becomes, what should we do about that? So there's a number of things we could do. We could simply ignore it, treat it as a no-op. We could throw an exception, signal our displeasure at a due request. What I'm doing here goes against what I would describe as RESTful best practices. What I'm doing if I get a GET request is simply sending it to do POST and doing the same thing. In other words, I'm pretending, in effect, that a GET request is a POST request. Now, this is not the greatest thing in the world because, of course, in the RESTful world, POST is create and GET is read. POST changes things, GET does not. So this contravenes those principles, but it's also highly convenient. I just wanted to illustrate the possibility. I'm not recommending this as a practice, but I wanted to show you that it's easily done, and I'm doing it. The validate and convert are completely unchanged. The big change comes down with how this servlet is going to interact with the convert.jsp script, which provides the user interface. In the previous example, we did a forward. Basically, we never left the server. The servlet simply forwarded information to the JSP script, and the JSP script responded by sending, in effect, an HTML document back to the browser. This time, we're going to do something different. So I'm going to start at the bottom. I'm going to do a redirect. The redirect is a response back to the client. We assume it's a browser. And it tells the browser what you need to do is send a brand new fresh request for convert.jsp. So we're doing a round trip. We got the initial request, we did the application logic, we do a redirect back to the browser, and now back to convert.jsp. So the question becomes, how should the servlet get the information to the convert.jsp script? The request dispatcher is not going to work in this case, but there is a very important alternative, and that's the so-called HTTP session, which is basically an in-memory map. It's on a per-client connection basis. It's thread-safe. By default, it's visible across all of the pieces of our application. That is, everything in our WAR file shares one and the same session, and so I'm going to use that. The syntax is very similar to what we saw before, and in convert.jsp, there are no changes whatsoever. So the way this now works is the following. I call getSession on the request object. That gives me the HTTP session. If there isn't one already created, a map already in memory, then getSession will create it. So I get either the existing session or a fresh one. I then call setAttribute. This was basically the same thing that we used with the request in the request dispatcher example. I do setAttribute. The key is result. Lowercase r is important here because in the expression language, this is going to be treated as a sort of property. Any key name would do, of course, and then I'm going to store the result there, and then the redirect. The round trip back to the browser, and then from the browser back to the server to request convert.jsp. Convert.jsp needs to access the session. Let's take a look at that. I'm going to bring up convert.jsp, and Java is just wonderful here. I have to say, this is exactly the same as before. In the expression language, notice there's no JSTL. This is just straightforward expression language. I just have result, which is basically the key of that value, and it picks that up. Boom. This is displayed back in the browser. So to go back and look at it, just to review, our input screen, 1, 2, 3. The servlet has done its thing. As you can see, we're in convert.jsp, and it has displayed the result. In summary then, we've moved from generic servlets to HTTP servlets, and we're pretty much going to stick with HTTP servlets. There's no real reason for us to use generic servlets. We're going to be doing everything over HTTP and HTTPS, and the convenience of do get and do post is a convincing argument to use HTTP servlets. This lesson recommends a programming exercise that deals with some of the points that we've been looking at recently. The main point of emphasis is tracking state information across the pages that make up a web app. Let's begin with a commercial example. Suppose that I go shopping at Amazon. I may visit various pages, order things off of various pages. When I go to checkout, obviously Amazon has to collate all of the items that I've picked from different pages and present them to me in a meaningful way. And I get a chance, of course, to confirm, do I really want to buy this, that, and the other thing? How many of each do I want? And so forth. We're going to do something like that, but of course not quite so involved, at least not quite yet. So the main point of emphasis is to track information across the pages in a web app. And that means, of course, that we need at least 2 pages. More would be better, but 2 would be enough to get to the basic idea. Another thing we want to do is get a better feel for having Java code, particularly in servlets and backend Java beans, interact seamlessly with JSP scripts and HTML pages. Increasingly, we're trying to look at JSP pages simply as templated HTML. So we've got the presentation layer, if you like, HTML, JSP, and then we've got the business logic layer, servlets, backend Java beans, and so forth, and we want those to interact in a clean, seamless manner. Now, for tracking information across pages, for having servlets and JSP pages share information, the HTTP session in Java is very well suited for these tasks. It's a map, it's straightforward, it's thread safe, something we'll emphasize a bit later downstream. So let me get to the example. I assume it's familiar to most people, but if not, I've got a very quick synopsis. It's a game, rock, paper, scissors. It's as old as the hills. It's a 2-person game. It can be played in person, of course, and players simultaneously pick, usually with hand signals, either rock, paper, or scissors, and the rules are down here. So if both pick the same rock, for example, it's a tie. If one picks rock, the other scissors, rock wins, and so forth. By the way, there's a nice AI-based implementation. Here's the URL. This implementation tries to figure out what your pattern is and then basically play against that. So it's fairly cleverly done. Now let me get to some implementation hints. The user, of course, is one player, and basically server-side code is the other player. So the user needs to make a choice. An HTML radio button is nicely suited for this task. You can get some documentation online if you're not familiar with it. I've sketched the basic idea here. For the backend code, a servlet really is well suited because of its closeness to the HTTP layer. So for example, you can have the overrides of do get, do post, whatever you decide to do. Those methods, or that method, if you pick just one, can then use a random number generator to make its choice. So the choices won't be simultaneous. The user will pick, and then the server-side code will pick. But of course, we're assuming no cheating here. The server-side code picks independently, in other words, before it actually knows what the user has picked. We transmit the user choice to the code makes its choice, the code then determines who wins. As noted, the HTTP session is nicely suited to this. What I'd like to do is leave this as open as possible so you get a chance to explore a bit. HTML, JSP, servlets, whatever you think is appropriate. The minimum requirement is that you have at least 2 pages because we need the sharing of information. So in terms of functionality then, let me sum up. The user should be able to make a choice, one of the 3, rock, paper, or scissors, submit it, and see the outcome of this particular game. The user should be able to play as long as the user likes and see the current history. In other words, the user may have played 10 times already, get the results, who picked what, who won, and so forth. And the user should be able, if the user gets too discouraged, to clear the history and then continue. In this version of the game, there's not going to be any persistence, so we're not going to save anything, but we'll come back and add that a bit later as another exercise. But to begin, once the user terminates the session, the HTTP session, by the way, goes away automatically, so it's recovered on the server side. It's in-memory storage, basically. So if the user plays, stops playing, plays again, the new game starts afresh. So I hope you get a chance to try this exercise. I think if you do, you'll learn a lot from it. In this lesson, we return to the ski equipment example, but this time with an eye to making this example more realistic, in particular with respect to data validation and other processing on the servlet side of things. So the interface, as you can see, has remained unchanged, but I can show some difference in functionality right away. If you look at the very first record, 101, under Category, you can see that it's telemark boot. The T in telemark is capitalized, but not the B in boot. So I'm going to edit this and not do anything except save it. We'll jump back. And you can see now that the B in boot has been capitalized. So part of the processing now is to do some refinement of the presentation. In particular, we have a company policy that when you have separate terms under product and category, each of the terms needs to be capitalized. So that's been implemented. The more significant changes, of course, have to do with data validation. So let me now jump into the Emacs editor. I've got a very simple working file called ski-servlet-overview.txt. For convenience, this file, the deployable war file, and everything else is in a zip called ski-servlet.zip among the working files. The assumption we're going to work under is that the user input is tainted. The price may contain non-decimal digits and so forth. The product name may be too short. We're going to assume the company has a policy about a minimum name. The same with the category. So we're going to do some checking both on the client side. So I'm going to enhance our use of HTML5. There are some attributes we haven't seen yet that can be used for client-side data validation. But the more important change is going to be on the server side because we're going to do quite a bit more than we've done before. If you go back and think about those CRUD operations, there's really only two of them that need to concern us right now. That's create and update, because that's the only chance that the user has, for example, to set the product name, to set the product category, and to set the price. That's where our focus is going to be. And in order to handle that, I'm going to use an explicit servlet rather than a JSP script as the target for a submitted create or edit form. In other words, when the user creates a new product or edits an existing one and then submits that form, that request is going to go to a servlet rather than to a JSP script as before. We could have used a backend POJO in order to do this extensive data validation, but a servlet is attractive because one of the other features I'd like to emphasize is how to filter on HTTP verb. So in this version of the ski inventory program, we're going to accept post requests, but completely reject GET requests. And we'll see how that's done a bit later. The revised code also highlights prepared statements. We've seen those implicitly. We're now going to see them explicitly. More about that when we look at the code. And I've mentioned before that the floating point type is not very good to represent currency. So I'm going to move over to big decimal, and we'll see how that interacts with the database as well. The Java support in JDBC is quite good. So let me summarize now the flow of control. We're interested in create and edit. When those forms are submitted by the user, we want the target to be a servlet. The servlet is called the data verifier, and the data verifier has various methods. We'll look at those when we examine the code in order to do server-side data validation, which augments the client-side data validation. The data verifier also does capitalization. We've seen that already. Once again, the web.xml deployment document is going to be a bit more complicated because of the servlet mapping, but once we've seen one of these, it's pretty much copy and paste, but we'll review that very briefly. Finally, when the data verifier is done, it's going to do a redirect to one of two pages, either goodresult.jsp or badresult.jsp. And in order to share information between the servlet and the JSP script, we're going to use the HTTP session once again because it's so convenient. It's really well suited for the task at home. We're only going to accept post requests to the servlet. We want to reject GET requests, and so the question is how best to handle the GET request. What might be called the nuclear option is to throw an exception. And we'll see that Java has very nice support for doing this. So for example, if a user tries to submit a GET to us, we're going to return a so-called HTTP status code of 405, which means method not allowed. At some point, we'll look more carefully at all of the status codes, but for now, that's not the focus. In the current implementation, all I'm doing is sending back a simple error message. So I don't throw an exception, but I do let the user know that something is wrong. For example, the product name is too short, the price contains invalid characters, and so forth. We're going to focus on the source code in the revised ski inventory example. All of the source code is included in the WAR file, and the WAR file is contained in ski-servlet.zip in the working files, just for convenience, so you don't have to worry about a bunch of isolated files. What we're looking at to begin then is edit.jsp, which is mostly unchanged from the earlier version. We're still doing some JSTL, some core and database stuff. You can see that. So we need to edit a particular inventory item. There's a select statement to do that. But now as you jump down here to the edit form, you can see something has changed. The action is no longer save edits.jsp. That's what it was before. It's now data verifier. That's the identifier for a servlet. And we'll look at that momentarily. The method is still post. I've enhanced the client-side data validation a little bit, not a whole lot, with these changes. If you come down and look at the entry for product, so the text box, notice now we have a minimum length set to 8, and we're requiring this. The same for the category, and we already had fairly extensive client-side data validation for the price. For example, you can't enter a negative price. The step is 0.01. You have to enter a number, that sort of thing. So the big change is that when this form is submitted, the same thing for the create form in create.jsp, the target is going to be the data verifier. So let's look at web.xml just to review how that works. So if you come down here, for a URL pattern of data verifier, the target is the servlet named dvServlet, and that in turn is the data verifier. So the fully qualified name has to be used. The package is data v. And the welcome page, as usual, is the table that presents all of the inventory items. Now let's go to the servlet because that's really where the action is. So I'm going to go to data v, data verifier.java. So I've included all of the imports just by way of clarification, so you can look at those. A few changes, for example, we're now going to use big decimal. That's in the java.math package. We're going to be using a prepared statement together with a statement. I'll also suggest some things that can be fixed. But let's cut to the quick. On a post request, doPost is called as usual. So we get a connection to the database. That's pretty much unchanged from before. This is the big change. Verify user inputs and update DB. That's down here. If a doGet is called, in other words, if the user sends us a GET request, I've commented out the nuclear option, but just to show you what it would look like, we could throw an exception and in effect tell the user absolutely not, no GET requests allowed, only post requests. What I'm doing in this case is simply sending back an error message. So send response, request response, message, and that last argument true means that this is an error. If it were false, it would mean no, this is just a normal response. Now let's come down to this all-important method, verify user inputs and client DB. And I'd like to walk through this systematically just to give you the feel for the sort of verification that ought to be done. So the first thing we check is to make sure we got all of the parameters. We got all three: product, category, and price. The ID we're assuming came along for the ride, but we could put that in as well. That would be a possible enhancement. So I first check to make sure that none of these is null. So getParameter will return null if there is no such parameter. I then do some length checking because we're now enforcing a minimum length of 8 characters on a product name and a category name. Same idea. We try to convert the price to a big decimal. If a number format exception is thrown, we're going to get back null and basically tell the user there's something wrong with the price. You put ABC in there or something like that. If we get by those preliminary checks, then we capitalize the parts of the product name, capitalize the parts of the category name. We now check to see if there's an ID. So if you'll recall, the difference between create and edit is that create creates a fresh product. There is no ID. The database sets that. With an edited product, there is an ID, so that comes along for the ride. Another check, we want to make sure there are no duplicate product names. So I check to see if the product name is already in use. We'll look briefly at the SQL, but it's a little inefficient and it could be made better. And as you can guess, that's a programming exercise just waiting to happen. If the product name is in use, we basically send back another error message saying, no, you can't do that. Otherwise, what we do is handle the request. If that goes okay, we send back a positive response. If for some reason it's not okay, we send back a negative response. So we're having database issues, basically. In the else clause, we do essentially the same thing for the edit. We try to handle the edit. If everything goes well, we confirm. If something goes wrong, we also send notification that something went wrong. So if you look very briefly, for example, at handle create, handle is essentially the same. What I'm now using explicitly is a prepared statement. So you can see here's my SQL, insert into database table. Those are the columns, values, all parameterized. And then down here, our prepared statement. We then set the parameter values. The category, the product are both strings. The integers, by the way, refer to which parameter. 1 for the first question mark, 2 for the second, 3 for the third. Very intuitive, very straightforward. And notice that JDBC supports big decimal. So for the third one, we have a big decimal representation of the price. We can set that. We update the query. We set the flag to true because if we haven't thrown an exception by now, that's good news. Handle edit is essentially the same, except there's an additional parameter. That's the question mark at the very end where ID equals, and of course the ID is an int. So prepared statements in general are the way to go. Stored procedures would be yet another way to go. We'll defer discussion of that until later. To send a response, we grab the HTTP session. We store either the good news or the bad news there. And then if it's an error, we go one place. If it's not an error, we go someplace else. We could actually share a JSP page for this and do some logic on the page to determine whether it's an error, but I find this is a cleaner way to go. Let me just show you bad result JSP, just to remind you of how nice this is in Java. Recall that the result message is just put in an attribute called result, and so on the JSP page, it's as simple as this. This is going to display the message in question and then give you the option to go back to the main page. So this is our first look at the source code and the revised inventory example. In the next lesson, we'll dig into details a bit further. This lesson continues our code review of the revised Ski Equipment web app. Just for focus, I'm showing the welcome page for the app. Now let's jump to the Emacs editor and continue the code review. In the last lesson, we looked at edit.jsp, and in the original Ski Inventory app, create was also a JSP page. But now, I don't need any JSTL. All I need is straight HTML, and so I've changed create.jsp into create.html. Once again, we're going to use some HTML5 attributes to do client-side data validation. So, for example, you can see min length equals 8, just as it was in edit.jsp, and you can see that our product name is required. Same with the category, and once again, we're doing some filtering on the price to make sure that we get a good number for that. The real action, however, as we know, is now in the servlet. So let's jump to that code. All of this code, by the way, just to remind you, is in ski-servlet.zip, the deployable WAR file, but also, for good measure, the source file with all of the source code. I'm now starting at the bottom of DataVerifier.java because I want to look a little bit more closely at the database and raise some database issues. I've changed things up a little bit from the original application. For example, set login for DB now takes a username and a password. They're the by now familiar Fred and secret. Up here, the getConnection method, a utility method, does in Java code what we were doing before in a JSTL library. So the URI remains unchanged. Just recall the syntax. So it's JDBC : Postgres : and then there's some variation. I'm using the simplest form. Ski stuff, again, is the name of the database, not the name of the table. We set the username and the password, and then load the driver as before. So we need that, and that's in a jar file. And from the driver, we now get the all-important connection. The connection allows us to build statements, and statements then can be executed against the database. So this is how you would do this JDBC setup at the straight Java level. It's fairly straightforward. Now let me move up here to product name in use and remind you what this is all about. When a user creates a new product or edits an existing product, we want to make sure that the user does not change the name in such a way to duplicate a name. In other words, if the name's already in use, it cannot be used again. So I need a check. What I'm doing here works, so it's effective, but it's not particularly efficient. I create a statement. I don't need a prepared statement here, by the way. In the way I'm doing it, a straightforward statement is good enough. You can see the SQL, very simple, select product from skis, etc. I now get the result set. And here's where the problem arises. I'm basically getting the product names from all of the records in the table. Now in this case, there's only 20, so it's no big deal. But if there were several thousand, it might be a big deal. So the real question is, should I do the filtering for a particular product name on my side, or should I let the database do it? In other words, I could actually put a where clause in here in select product from skis, etc., and let the database do the filtering. Instead, I do it. And this is not a good thing. It would be better to let the database do it. So what I do then is iterate over the returned records, and if I happen to find a product name identical to the proposed product name, we basically say, no, it's already in use, that's a no-go, and the end result is going to be a bad result. In other words, we're not going to accept the edited product. Capitalized parts is fairly straightforward. By the way, there are some third-party libraries. If memory serves, Apache Commons, for example, I think includes a capitalized method, but it's relatively straightforward to write, so I've done it here. The idea is if you have a string such as rosignol space, super space, downhill space skis, and everything in there is lowercase, what we're going to do is split that string on blanks and then basically capitalize the first term in each of those parts. So the capitalized parts are straightforward. I've thrown it in here just to have some additional data massaging. This is typical of the sort of thing you might do in back-end code. Convert price is similar to what we've seen before, but not identical because we now use big decimal, which is appropriate. And it's pretty straightforward. We call the big decimal constructor on the string representation of the price. If we get a number format exception, then null is going to be returned. Otherwise, we're going to return the big decimal representation. And this is better than float for the reasons we discussed a bit earlier. Let me finish up by looking a second time at send response and underscore the options and talk a little bit about my reasons for going the way I did. I get the HTTP session because that's where I'm going to store the result for the JSP page, and I have two distinct pages, bad result and good result. They're very, very similar. It's just that bad result does everything in red and good result does everything in a friendlier green. The question is, couldn't you combine these and use some JSTL logic in the page to determine whether to go red or green? And the short answer, of course, is yes. This is a design decision. I'd rather keep the pages as simple as possible. I do, by the way, need JSP because I need the expression language. Let's do bad result.jsp. And I'm in the wrong directory, so bear with me. So the reason I need JSP is because of this. This is basically extracted automatically from the session. It's the name of the attribute, and this is the message that's going to be displayed. So I need that. That's the only place I'm using any JSP on this page. Otherwise, this is 100% HTML, except for that little change. Now let me go back. So my 2 cents is this. I'd rather keep those pages as simple as possible, as clutter-free as possible, and so having one for a bad result and another for a good result is my preference. But there are other ways to go, and you may want to tinker with this, have a single page, and use some JSTL to determine whether this is good news or bad news, and adjust the color accordingly. That completes our code overview of the revised ski inventory application. What we'll do in the next lesson is look a little bit at testing. How can we be sure that the data validation is actually kicking in? Because after all, we're also doing data validation at the client side through HTML5 with the help of the browser. We're going to focus on how to test whether the data validation added to the ski equipment web app actually works. Now, some of the testing we can do straightforwardly. So as you can see, I've got the welcome page open. And notice that the very first record has a product name of Scott Synergy. So what I'm going to do is try to create a new product. As you might expect, I'm going to put in there Scott Synergy. Remember that the capitalization is done automatically, so it doesn't matter. And then I'm going to come down here to category. We don't care about this, so I'll just put in some meaningless text, make sure I have 8 characters. And for the price, 111.22. I'll make sure the price is legitimate, and I'll try to create the product. And as you can see, that fails. So I get back the error page. It tells me that this name is already in use, and by inspection, I can check to see that that record has not been added. There's a problem with doing some of the other tests, and so let me bring up the source for the create page. So this is create.html. We're looking at the source in my browser. The font is a little small, but let me come down here and highlight this part in blue just for emphasis and look at the input ID equals product. And you can see there it requires on the second line a min length of 8 characters. Now, if the browser is able to implement this HTML5 feature, and the Chrome browser is, I'm not going to be able to create a product, for example, that has too short a name. So if I come back here, again, just as proof of concept, and I try to create a product called one, with a category called 1 and a price called 111.11, and I try to save this, the browser intervenes. So the client-side data validation kicks in and it tells me, no, you need a longer name. So the question becomes, how do we test these other features? So let me now move to my Emacs editor, and we're looking at a working file called howtotest.txt. This file and another file are combined into howtotest.zip, and I'll talk about that other file shortly. So again, let me just repeat the challenge. I'm using HTML5 on the client side to do some preliminary data validation, and if the browser goes along, then the tainted data, too short a product name, too short a category name, a bad price with non-numeric characters, that should never make it over to the server side. So that leaves us with the challenge of how to test the data validation over in our servlet code. Now, there are various ways to do this. We could get a browser, for example, that's not as good as Chrome. We could get an older version of Chrome. That's a little bit tedious and a little bit ad hoc. There really are better ways, and one way is the curl utility. I've talked about it before. It's useful particularly for cases such as this. And the second file I talked about is something called curltest.sh. This should work on any Unix type system. The individual curl commands should work on any system, Windows and so forth. So let me explain the strategy. In that curltest.sh file, which I'll run, I have commands such as this. I'm using again the % as the command line prompt, so you can see curl -- request get. By the way, you could leave that off. -- request get is the default for curl. I'm giving it the URL of the welcome page, and as you'll see, it's going to display all of the HTML as you would expect. Now, the get commands, and I have a second one here, aren't really the commands that are tricky for us because they don't change the data, so no data validation kicks in. What we need to test are the post commands, and here's an example. So you can see -- request post. Now here are the data. These are the body and the post request data. Recall that the body consists of key value pairs, and the way you write those key value pairs here is key equals value, space, key equals value, and so forth. So you can see here we have product equals foobar, boss. So I've deliberately left that in there. I want to see the capitalization kick in, next key value pair, and next key value pair, and so on. The key value pairs can come in any order. The / at the end just means I'm continuing on the next line. The -L, the capital L, basically tells curl, I'm interested in the redirects. Please follow those. Because as you recall, this URL that leads to the data verifier is going to do its thing, and then it's going to do a redirect, and we'd like to take a look at that redirect. When I run this the first time, that particular post command, I get back a good result because it takes, but if I immediately run it a second time, I get a bad result because the name is already in use. And then, of course, I could run other tests such as this. I could send product names that are too short, category names that are too short, prices that contain non-numeric characters in them, and so forth. So the idea is we need a client that bypasses the HTML5 data validation checks, and curl is ideally suited for that. So let me go to the command line prompt and actually run curl's test, curltest.sh. It's interactive. It basically shows you the command it's about to run, asks you to hit a key. I'm going to hit the key. This was basically get all, so you can see the end of the HTML there. I'm going to hit again, and this time it's going to be get one, basically get product one. And you can see that. Again, hit any key. Now I'm going to do the new product thing, and that was successful. Now I'm going to try it again, and it was unsuccessful. And the reason it was unsuccessful again was that the product name was already in use. So let me go now back to the browser, and let's refresh this page just to confirm that things worked. So you can see down at the bottom, the silly entry, the foobar boss entry, actually worked. The capitalization worked, but there's only one copy of this, which means that the product name already in use kicked in. If I hit continue with those curl scripts, you would have seen that the next entry, which had all sorts of bad data in it, would not have made it. In summary, we need a way to test things like data validation on the server side, and curl is a really excellent utility for doing this. You could, of course, use something else. You could use a Java client. You could write a client in any other language that you like, Python or something like that. But curl is well designed. There are plenty of examples out there, and the documentation is just excellent. So I would recommend it strongly. In this lesson, we're going to take a step back from the Java web framework, servlets, JSP scripts, and so forth, to get a closer look at HTTP. We've been using HTTP from the get-go, but Java has disguised most of the details. Actually, Java on one side and the browser on the other. But what we want to do now is take a look under the hood. Later on, this will be very useful, particularly when we do security. But now seems like a good time to take a first look at HTTP Basics. The working file is called that, http-basics.txt. So let's start with the structure of HTTP messages. And of course, as we've seen, there are two types. There are requests from client to server, and there are responses from server to client. The structure you're going to see is fairly similar. In the case of a request, the first thing is a start line, and this consists of the HTTP method, so the verb, followed by the URI. So in other words, it's actually verb noun. And way here at the end, you see an example. Post is the verb, and then you see the URI for the data verifier, /ski-serv/data verifier. The third piece there is optional. That's the version of HTTP in use, and it's 1.1. After the start line come the header elements, called the headers for short. These are key value pairs with the colon as the separator. And again, here's one example. Content type, colon, application, blah, blah, blah. The application /xww form URL encoded is the MIME type and subtype. So the content type, the information given here basically is that what's being sent is an encoded HTTP form. This is a POST request. Recall that all POST requests have a body. Next are two new lines. Technically, a carriage return followed by a new line, but two new lines would do, followed by the body. Some requests have a body, post and put. Some do not, get and delete. The response, you have a start line, again, the optional HTTP version, followed by the status code, numeric, and in English. So for example, 200 OK is always good news. The 100 level status codes are informational. 200 are basically good news. 300 range status codes are redirects. 400 client errors. 500 server errors. And we'll get into some details later, but right now, that's good enough. Again, you have the header element. So for example, you can see over to the right server, Apache Coyote. That's basically Tomcat. Two new lines followed by a body. A response always has a body, although the body could be empty, and we'll actually see an example of that. Now to illustrate from the command line, I did a curl post request. What I tried to do is recreate yet again the foobar boss product. It's not going to work because it's already in the database when I ran this. And you can see that I'm doing verbose, which is telling curl, give me lots of detail. I could get even more detail, but let me explain what I have. Anything that starts out with the greater than sign is produced by curl. Anything that starts with a star is metadata. It's curl explaining what's going on. Anything that starts with a less than sign is coming from the other side. So in this case, from the server back to curl. Here's the post request. There's the start line, post, URI, so verb, noun, HTTP version. Some header elements. The user agent is not a browser, it's curl. Under HTTP 1.1, this header element is required, host : localhost 8080, because notice the actual host, the machine that's hosting the web app, is not given in the start line. It's given in a header element, except leaves the door open. We'll take anything, any MIME type and subtype. By the way, there are more than 4,000 possibilities now, and that number continues to grow. Content length 61, content type, again, is a post form. So a little metadata, things were sent off, very small request, 61 bytes. Here's the response. 302 is a redirect. We're doing a redirect. You can see here, set cookie JSession ID. The HTTP session, remember, is client connection specific. It's identified by a cookie by default. If cookies are turned off on the client machine, there's a workaround, but that's the default. That's a 128-bit number, basically, that uniquely identifies each client session. We get the location, so we're redirecting to the bad result page because we have a problem. The body is empty. There's nothing in there. So there's a little bit of metadata here. The third item basically says, well, you're doing something that's not really so great. You've got a post request and you're doing a redirect for a GET request. This will work perfectly fine, but as you can see, it violates basically a spec. There's a little more metadata, and then we get the post request to the bad result. The user agent, again, is curl. And then finally, to wrap it all up, we get the much looked for 200 OK. So that's success. We get repeated information about the server, the cookie, the content length, and so forth. By the way, if we wanted, we could actually see the body of these responses, but I decided to turn that off because it would be a bit too much clutter. In summary, this is our first look at HTTP under the hood. Mostly, we'll ignore the HTTP basics. We won't really look at items in the protocol. We'll let Java handle that for us. But later on, it will be useful to have at least a fundamental understanding of how HTTP works. This lesson focuses on another technical matter that's been around right from the beginning, and now's a good time to bring it to the surface. So the technical issue is concurrency in both Tomcat, our web server, and PostgreSQL, our default database system. So let me begin with Tomcat. Tomcat implements what is sometimes called the one thread per request model to handle client requests. At startup, Tomcat creates a pool of threads. Creating threads is a relatively expensive operation. It's best to do it at startup, and then you can amortize that cost across the lifetime of the server. It's exactly what Tomcat does. As a request comes in, that request is delegated, dispatched to a particular thread from the pool that's going to handle the request, and once that work is done, the thread is going to return to the pool and await another request. Tomcat itself, more specifically the web container, does not do any thread synchronization on behalf of the programmer. In different terms, the responsibility for thread-safe code falls to the programmer, not to Tomcat. A simple example should illustrate. Suppose we have my servlet, so it's an HTTP servlet. Suppose the only method that we implement is doPost, so the only place we touch request count is in doPost, and of course what we're going to do is increment it. Now the problem is multiple threads might at the same time execute this code. This results, of course, in a so-called race condition. In short, this code is quite emphatically not thread safe. Now there is a straightforward workaround. Java has some very nice thread-safe data types. So the cursor and the working file, by the way, is concurrencyissues.txt. So the cursor right now is to the left of an import, java.util.concurrent.atomic.atomic-integer. That's a thread-safe data type. When I implemented the request count as an atomic integer, the problem of the race condition goes away. but there are still remaining problems. So let me touch on those. Here's the remaining issues. Tomcat is allowed to create as many instances of a servlet as it sees fit. So the typical scenario would be Tomcat will load a servlet instance when the first request comes in. So Tomcat is doing what might be described as lazy instantiation. In other words, if I deploy a web app and it contains a servlet, either explicitly or because it has JSP scripts, Tomcat, by default, doesn't do anything until a client requests that web app, because maybe I'm deploying something that's never going to be accessed. As business grows, as we get more and more requests, Tomcat might see fit, for example, to instantiate the servlet 2, 4, 8 times. That would be quite a few. And Tomcat is also free to unload instances if business drops. In other words, we may have, in effect, multiple instances of a given servlet and therefore multiple instances of the request count. So as the request count is being incremented, even in a thread-safe manner, there may be more than one. So we're not getting all of the requests to that web app captured in a single instance variable. We could change that, of course, by making the request count static. But once again, Tomcat is free to unload and load classes as it sees fit. So the only really safe way to keep a request count would be to persist it, for example, in a database. Now let me turn to the issue of concurrency in the backend database, Postgres. Most modern databases take roughly the same approach to concurrency management. I'll mention what that is shortly, but let me focus in on an issue that we've seen so far. We've had various JSP scripts and backend servlets do update commands against database tables, in particular the ski equipment table. That's the one that we've seen the most. So we've had statements such as this, update something, blah, 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 blah. What Postgres does under the hood for single statements effectively is to wrap those in transactions. So at the Postgres level, you would have a begin statement, which is the beginning of a transaction, a single statement, and then a commit statement, which marks the end of the transaction. So if we execute this in our source code under the hood, this is actually being executed. In effect, we get concurrency safety automatically. The rub comes in when we have multiple statements that need to be executed in a non-interruptible way, as if they were a single statement. So at the Postgres level, the code would look like this. Start a transaction, multiple statements, end the transaction. The JDBC API, of course, is not targeted at Postgres. It needs to be more general and flexible than that, but it is sufficiently rich to handle this, and what we'll see in the next example is how to do this sort of thing using JDBC. Let me make a final point about Postgres. As you know, I'm enthusiastic about it as a free production-grade database system. Postgres uses something called MVCC, quite a mouthful, multi-version concurrency control, in order to manage transactions under the hood. This is a very popular concurrency mechanism. It's been around as a research project for at least 3 decades. It's widely used in industry. For example, a lot of the big database systems, IBM DB2, Microsoft SQL Server, and so forth, use this mechanism. It's used in relational as well as in NoSQL database systems, so it's widely popular. It's implemented in certain programming languages as well. The important thing for us from a database point of view is that it supports the so-called ACID properties. I've listed them there. And it uses a timestamp sequence in order to serialize updates to the database. The long and the short of it is, under MVCC, you have lots of commits, but very rarely do you have a real rollback. Now, we don't care about those implementation details so much. What we care about is JDBC, because that's how we're talking to the database mostly. And let me underscore yet again that the JDBC API is sufficiently rich to support transactions implemented in various ways, including via MVCC. That was quite a quick run-through concurrency issues. We'll flesh this out in the next lesson with an example. This lesson covers the setup for the forthcoming transaction example using PostgreSQL or any other database that supports transactions, and virtually all modern databases do that. So in terms of the example, let me present the big picture. What we're going to have in the web app is an editing form that's going to display data taken from two tables. So far, all of the editing forms we've seen have dealt with one underlying table, so we're going to change that. And the idea is when we save the edits, we want to make sure that either both of the underlying tables get updated or neither one. That will be the goal of the transaction. The two tables, to keep life simple, are both going to be in the ski stuff database, so we don't need a new database. We'll pretend that these are employees in the ski inventory company. I'm going to, for simplicity, call the tables emps for employees and sals for employee salaries. There is some real-life motivation here. The DB admin might want to keep those two tables separately, in particular, not to display the employee salaries and the regular employees table. For example, the admin might want to limit access to the salaries table, encrypt the data that go into the salaries table, and so on. So the web-based edit page is going to list all of the editable fields. It's going to list as well the keys, but we're not going to allow the keys to be edited. Those are the auto-generated numbers from Postgres. I'm going to follow that practice. Now, these tables could be created as we did earlier with a simple Java program, but it's also easy to work in PSQL or, if you're on some other system, a comparable client interface to the database system. So the idea is I open PSQL either from the command line or through the GUI, whichever way is convenient. There's the Postgres GUI. If you click that, you'll get a link to PSQL. By the way, this working file is transactionsetup.txt. So I go into PSQL and I create the two tables. There are various ways to do it. I've tried to keep it as short and sweet as possible. The emp tables is straightforward. The primary key is an auto-generated integer value. Postgres is going to provide that. You see the name and the department. We don't want any of that to be empty. The sals is a bit trickier. Again, we've got the auto-generated primary key, the salary, which is decimal, and now we need a link to the other table. So you can see this third line is emp ID int references emp's ID. This in database jargon, if you're not familiar with it, is a so-called foreign key. In earlier versions of Postgres, you had to put foreign key in explicitly. That's no longer the case. They've simplified the syntax. The emp_ID and the salary table is going to have the same value as the ID field in the employee table. And we'll see how to do that. The Postgres PSQL tool has lots of nice shortcuts. I'm showing you one of those right here. \DT for describe tables. I get a list of tables. They're using the technical term relations. And what you see is the name of the table, the type of the table, the owner. The notorious Fred with password secret is the owner of all of these tables. After listing, I did some insertions. So I insert some data into the tables. To keep life simple, I've manually put in the so-called foreign key. So for Mo, for example, I know the key is going to be 1. There would be a better way to do this if we were doing tens or hundreds of records, but we're just doing a few. I'm going to have only 3 records in there. We need some data. We don't need a lot of data. So at the end, I now run some queries. Now notice up here, I capitalize insert into and values and so forth. Down here, I use all lowercase. My practice in the JDBC for emphasis is to capitalize the SQL terms and to leave my stuff uncapitalized. I'm not absolutely religious about following this, and down here, as you can see, for convenience, I'm not using any caps at all. As you'll see, PostgreSQL, because it follows standard SQL, is in general not case sensitive. I do a general select. I get the EMPS table, ID, name, and department. I do the same for salaries, and you can see via inspection that basically the foreign keys point back to the appropriate rows in the employee table. And this now is the sort of query we're going to be using in our JSP script to do the editing. This is a so-called join. It's the most complicated thing we've seen so far. Select star, all rows, all columns from EMPS, sales, and those are the two tables. So that's the join in effect. And now we set a condition. We want the EMPS ID and the salaries in the employees table to match up with the EMP underscore ID and the salary table. And as you can see, the resulting view is here. We've got the ID, the name, the department, then the ID for the salary table, the salary, and the so-called foreign key. Obviously, we don't need all of that information. For example, we don't need this second ID. We could dispense with that. But as a first run through, I wanted to show everything. At this point, we now have a very simple database. We've got the inventory table, the employees table, and the salaries table, and we're going to use the employees and salaries tables in order to illustrate, in the next example, a transaction at the JDBC level. We're going to look at the revised ski inventory program, and in this revision, we're going to use an explicit JDBC transaction. Let me start with a very quick demo. So I have a form that's prompting me for a user ID. I'll put in 1. I now get the data for Mo Stooge. The data come from two different tables, recall. The EMPS table has the name and the department, and the sales table has the salary. So just as proof of concept, we'll take away 99 cents, and we'll put Mo Stooge, comma, the third. Save the edits. We get confirmation. If we come back and bring Mo up yet again, we should see that the changes took, and indeed they did. Let me go back. If we put in a bad ID, so 99 for example, we get back an error page telling us that there is no such employee. So under the hood, there's an HTML page, a JSP page, and a couple of servlets at work. So let's jump to the Emacs editor. You're looking at the working file transaction app overview.txt, and this gives us, as noted, an overview of how the application works. I'd also like to begin with a talk about a design issue that's always been there, but again, this is a good time for us to bring it to the surface. So let me repeat. There's an HTML page, a JSP page, and a couple of servlets at work. In general, when you're writing web apps in Java, using tools such as JSP and explicit servlets, when should you use which of these? And unfortunately, as we know in programming, there is rarely a clear-cut answer. There are guidelines, there are trade-offs, but at the end of the day, it comes down to a judgment call. If we use something like the JSTL SQL library, there's no question, I think, that the JDBC code is easier to write. So JSTL SQL is very, very nice there. What I find, however, is that the JSTL core can be a little bit clunky if we have to do a lot of application logic. So if we need if tests and loops and that sort of thing, it's much easier, or perhaps better said, it's more natural to do that in plain old Java. There's a trade-off here. The JSTL libraries certainly do let you write terse code. That's a good thing, but at times you need the flexibility, the full expressive power of a general purpose language, and that, of course, is what Java gives you. So my tendency is to put most of the application logic in servlets or POJOs and to minimize the use of JSTL. In this app, I am using, of course, JSP, including the expression language, which I think are just great, but the JSTL has been put on the back burner. Now let me focus a bit on the flow of control, so when we go and look at the code, it'll make a bit more sense. Find emp.html is the welcome page. Again, it does a little bit of filtering on data input. It looks for integers, for employee IDs, that sort of thing. And then it issues a post request, which targets the find emp servlet. So this is the first of the two servlets. And the job of this servlet is to determine if such an employee exists. So there is an employee with ID 1, but there is no employee with ID 99. If there is no such employee, then findEmp does a redirect to badresult.jsp. And as we saw, there's a backlink so we can do it again. We can get back to find.html. If there is such an employee, then the servlet takes the relevant data, the name, the department, the salary, that sort of thing, and it uses the HTTP session map to share that data with the editemp.jsp page. So it does a redirect to editemp. The data are filled in, ready for editing. Once editing is completed, the data in editemp.jsp are posted to the data verifier servlet. It's very close to the earlier version we saw of a data verification servlet. And this servlet verifies the data. The big difference now is that it needs to update two tables, emps and sals, and so it uses an explicit transaction to do that. And we'll look at that code in a bit. In the program we saw some time ago, basic JDBC.java, there actually was a transaction, but we didn't talk about it much then. We didn't focus on it. In any case, once the data verifier has done its job, if everything goes well, it does a redirect to goodresult.jsp, confirming the changes. And if something's wrong, so the database is down, there's some problem with the channel to the database, we get a bad result, and we get acknowledgement of that fact. That's the overview and a little bit of discussion on the design trade-offs between JSP pages and straight Java code. In this lesson, we're going to focus on the source code for the revised Ski Equipment web app. And in this revision, there's an explicit JDBC transaction. We'll get to that in a bit. To begin, this is the welcome page. Find emp.html, it's straight HTML5. All of the source code we'll be looking at is included in the deployed WAR file called transact.war, and that's included in the working files. So as usual, we've got a backend style sheet, pretty straightforward HTML. We do a little bit of input filtering here. For example, you can see with this input control, we require a number. It's got to be an integer. You can see step equals 1. The minimum number is 1. So you can have 1, 2, 3, and so forth, but you can't have an ID, for example, of 1.5. When this form is submitted, it goes to find emp.s. That, of course, is the alias for the servlet, and that's set up as usual in web.xml. So now let's look at this servlet. The actual code is in a file called empfinder.java. This is the source code. And as you can see, it's a standard HTTP servlet. There's a do post and a do get. The do get is deactivated, so if somebody tries to hit this servlet with a get request, we're going to send a thanks but no thanks message. If we get a post request, and basically the only thing coming to us is an employee ID, then execute query and redirect is called. That does all of the work. That's down here. Most of this is familiar, so we'll look at the parts that are slightly different. We go into a try block as usual, make sure that we really did get an integer and not something else, and then we basically go through a query. This query is a bit more involved than anything we've seen so far, but it's a single query. So we're going to select EMPS ID, the name, and the department. Those three come from the EMPS table. And from the sales table, we're going to grab the salary, but there are conditions. For one thing, the EMPS ID has to be the ID submitted by the user. That's the EID converted to an int. And the EMPS ID and the sales.emp_ID, the so-called foreign key, those two have to match. So for example, if we get ID 1, that's for Mo, we have to make sure that we pick up Mo's salary, not Larry's salary. So that's basically what this condition ensures. There are a couple of other new features. So we execute the query as usual, and in this case, I'm going to use a slightly different approach to see if we got something back. So when you execute a query, such as a select, you get back a result set, and the cursor is set before the first record. In other words, it's not set at the first record. If you're thinking about an array in Java is indexed starting at 0. So you might say the initial index is set to -1, not to 0. The record set has a nice convenience method called isBeforeFirst, which tells you whether the cursor is set before the first record. If that's false, it means there is no first record. Now I grant you it would be clearer if the method were simply called something like, are there any records? Something like that. But the impact is the same. We can do a quick check. If there is a record, there's going to be only one because of the select query. So we reposition the cursor, rs next. We're now at the first record. And then basically, we grab the data items, the ID, the name, the department, the salary, and we're going to send those off to edit.emp.jsp. So let's look at that now. Edit.emp.jsp is going to receive the data and display them for editing, and you've seen this sort of thing before. This is a familiar type form. Upon submission, with a post request, it's going to go to the servlet aliased as verify and save. We'll look at that guy momentarily. There's a little bit of client-side data filtering. The name, for example, has to be at least 6 characters long, same with the department. And the salary needs to be a number, and again, we can increment that by a penny. When this is submitted, we're going to go to the verifying servlet, data verifier, T for transact.java. It's similar to the servlet we've seen before, but not identical. There are a few differences, and the main difference, of course, is the explicit transaction. Here's to do post, and down here's to do get. I've not put in the @overrides. That would be better. I put them in the earlier servlet, but just as proof of concept, the servlet will work fine with or without the explicit @overrides. But those annotations are better included than not. So here's where the action occurs. Verify user inputs and update DB. And now I've been a bit more careful. In an earlier version of the verification servlet, I checked everything at once. If this equals null, or that equals null, or the next thing equals null, send an error. Now I'm doing them one at a time so I can get better error messages. The name is missing, the department is missing, and so on. So this is basically to help us as programmers. Finally, after converting the salary, for example, to big decimal and all of that good stuff, and capitalizing anything that needs it, I'm going to call handle edit, and that's going to do the transaction. So we'll move down there. If things go well, we send a response that confirms things went well. Otherwise, we send a message that says something broke. This is handle edit, and here's the idea. There are now 2 separate SQL statements that need to be executed. The first, SQL1, updates the EMPS table. The second, SQL2, updates the sales table. We're going to use prepared statements for both of them, just because it's a good idea. Here's how we do the transaction. First, we set auto commit to false. So basically, we're telling the underlying database, don't wrap each of these single statements in a transaction because we need them to go into a transaction together, the pair, not one at a time. So again, a little more parsing, setting the parameters. Now here's the critical part. We're going to execute the first update to the EMPS table, then execute the second update, that's to the sales table, and then we're going to commit both of those at the same time. This either works or it doesn't. If for some reason it doesn't work, we get a rollback. Otherwise, the changes are committed as if they had occurred in a single statement, and that's the whole point of a multi-statement transaction. So it's fairly straightforward in JDBC. It's pretty clean. Now there's a little more complexity, and that's mostly because we now have to close the statements and close the connection. But the key part of the code is between set auto commit false and explicit commit, and in between should be the statements that we need to commit. This lesson is a wrap-up of some major points in recent examples. We've covered a lot of ground, so it's worthwhile to pause for a moment, look back, and try to draw some lessons from those examples. Let me start with a theme that I've tried to push throughout these examples, and that's the following: how the labor should be divided among simple JSP pages, JSP pages that include JSTL, explicit servlets, that is, extensions of the HTTP servlet class, and backend POJOs isn't crystal clear. There are trade-offs no matter which way you go, and at the end of the day, web app programming, like any sort of programming, forces us to sit back, think the matter through, and decide these are the best tools to use from the toolbox. For some very simple examples, JSTL, SQL, and JSTL Core, and even JSTL format are outstanding. So let me go back and remind you of that very first example we did with the database. This was the first display of the ski equipment, and we used a JSP page with JSTL. So here's the set data source. It's short and sweet. Here's the query. It's a simple select query, so it's a read-only query, equally short and sweet. And this is also quite nice. We need to iterate over the rows of the table, and we do that with a for each loop, nice and clean. And then basically for each row, we output the ID, the product, the category, and the price. It's hard to beat JSP, JSTL in this particular example. By the way, you'll notice that we're using new style JSP here, the expression language. Now, where things get complicated is that if you have to do some back-end logic. So take something as simple as capitalization, one of the things that we looked at, let alone, for example, converting strings to integers and all sorts of things like that. Even for something like capitalization, we could do that in a JSP page. We could use, for example, some of the facilities in core JSTL, but in my view, that gets to be a little bit clunky. My own preference is to work in standard Java. Java is a general-purpose programming language. It has all sorts of wonderful libraries that we've become familiar with. I just find it easier to revert to either a servlet or a backend POJO to do that sort of thing. But again, there are trade-offs. The HTTP servlets that we've looked at are appealing, of course, because they so closely match the structure of HTTP. And by that I mean the so-called HTTP verbs, because servlets have methods that mirror those verbs. There's doGet, doPost, and a bunch of others as well. The nice thing is that we have the adapter pattern. That is, if we care about a do method, we can override it. If we don't care about it, we can ignore it, or we could override it and throw an exception, or we could override it and do something a bit friendlier, just send back a little caution. And that's basically the strategy that I've been following in these examples. The arguments to each of the do methods gives us exactly what we want in doing web apps. The HTTP servlet request is a map of all of the incoming request data. We certainly haven't seen all of it so far, and we'll get into more of it later. We'll even get into some of the header data, which we haven't looked at yet. There's a map API to read the request items. There's get parameter. That's the only one I've used. There's also get parameters. You can get a list of all of them. There's get parameter map. There's a bunch of related get parameter methods in the API. It's very friendly and straightforward. Get parameter by itself is good enough. That's all we've used so far. And of course, the HTTP servlet response, the second argument, is a channel for communication with the client. By the way, it's a two-way channel. You can use it to write back, but you can also use it to read information from the client. Along the same lines, the HTTP session, it's available obviously either in an explicit servlet or in a JSP page. It's very friendly. It's also thread safe, and it's an efficient way because by default, the session is stored in memory to share data among the different modules in a web app, pages and servlets and POJOs and so forth. All of the components in a given web app have access to that HTTP session map. And as we've seen, this is similar in style at the API level to the parameters because you can get an attribute, set an attribute, and so forth. Backend POJOs, same idea. Absolutely straightforward to use in JSP pages. All you really need is JSP useBean to create an instance of such a POJO, and then you can access it through properties or indeed arbitrary methods. A final theme that we've been pushing in these recent examples is no matter how good the client-side data validation may be because of HTML5 or later HTML5 in combination with JavaScript, we still need to assume in our web app code that the data we get may be tainted. So there has to be lots of care given to validating any data that comes from users or from any other source outside of the application. This lesson recommends two programming exercises that involve database code. It would be great if you have time to do them both. One of them is a little bit longer. The second is fairly short, and it's more a conceptual exercise than a coding exercise, although both do involve some coding. So let me start with the longer of the two. There was an earlier exercise to implement the rock, paper, scissors game, basically a two-player game, and the suggestion then was to save the results of the game in the HTTP session, which is ideally suited for that sort of thing, since the session map is visible across pages in a web app. What we're going to do then is have a backup database representation of the game outcomes. So there'd be a table in a database. You can just go ahead and use the ski stuff database. If you've already been using that, that's just fine. We don't care about the database. We just care about the table, and it can be called anything you like. It needs columns to represent what each player picked and, of course, who won, and any other data that you might think relevant. For example, if you'd like some experience with timestamps, PostgreSQL and other modern database systems have timestamps, and you might use one of those as a column. We need a clear operation on that table. If you're like me, you don't like to be reminded about how you've done at these games, so the clear operation would delete all of the records from the table. And there's a delete from command in standard SQL. So the documentation for Postgres and these other systems is quite good nowadays. It's easy to get little tutorial hints. One of the questions that naturally arises is, when should the outcome of a game be persisted? Right after the game is played or later? One issue, of course, is that going against the database repeatedly can be inefficient, although modern systems have improved that enormously. But what you might do in the spirit of efficiency is keep the results of the game in the session map, and then only when the user decides to close, to quit for the day or whatever, would you persist the whole thing at once. So you would basically do one big operation rather than a bunch of small operations periodically. In the table, let me suggest that you just assume for simplicity that each player has a unique username. So for example, the username could be the primary key. In any case, you could do simple lookups against a username, so you can actually use one table to store the results for all players. We're going to assume that this isn't going to get into the tens of millions or anything like that. Now let me turn to the second exercise. This is actually from the ski equipment code, and this is the product name in use method. So let me remind you of how this worked. When the admin is going to enter a new piece of ski equipment, the admin has to provide a name, a category, and a price. And one of the integrity checks that is done in the backend servlet is to check whether that name is already in use. So we don't want to have duplicate names. We can, of course, have duplicate category types. We'd expect that, and even duplicate prices, but not names. So here's the way it's done in the current code. There's the execution of a query. You can see the query here, select product from skis. So this gets a list of all of the products. We now have a result set. We're going to iterate over the elements in that result set. And basically, if we pick up a name that's the same as the suggested name for the new product, we're going to say no. Now the problem is this iteration. I need to go through all of the records start to finish. It's basically a linear search, and there is a better way to do it. For example, what we could have done with that skis, etc. table was to create an index on the product column. Postgres automatically creates an index on the primary key. In this case, it's the numeric identifier, but it doesn't automatically create an index, for example, on product. Now, we could create such an index, and then the SQL would be more efficient because, in effect, we could let the database do the searching, and it would do the searching in a straightforward way. It would check against the index to see whether such a product was there. If so, deliver it to us. If not, deliver the bad news to us. Now, indexes do have a cost. They do up the cost of doing an insert or an update, but they lower the cost of doing a select, a find operation, in other words. So if we think we're going to be doing lots and lots of find operations, indexes probably are worthwhile. In any case, the exercise is to change this code so that we no longer need a loop. What we can do is refine the query so we get a very quick and efficient yes or no. You see, is there such a record in there already for that product, or is there not? The second one I think is reasonably straightforward. It's more a conceptual exercise, as noted. And the first one, if you have time, I think will be really good to become acquainted with PostgreSQL or whatever backend database system you happen to be using. In this lesson, we're going to take our first look at a shopping cart web app. E-commerce, of course, is one of the principal uses of the web, and you could make the case that the shopping cart app really put the web on the map. There's more to the web, obviously, than just e-commerce, but we've all used shopping cart apps in one form or another over and over and over again. We're going to start with a relatively simple implementation and then add features as we go along, and we're going to focus on some of the tricks of the trade, how to get the web app to do what we need it to do in the most straightforward way possible. You're looking at the working file, shoppingcartoverview.txt. For convenience, this document and all of the other documents we're going to be looking at in this initial web app are in shoppingcart1.zip in the working files. What I have here in the working document is a summary of the points that I'd like to make, but it's easier, I think, if we contrast the shopping cart web app with something we've seen already. So let me jump to my browser. You're familiar, of course, with this by now. This is the JSP-CRUD app. It's one of the many variations of the ski equipment web app that we've done. And all of those variations have been focused on the administrative side of things. Our goal was to write an app that provided a CRUD interface to a backend database. So just to review quickly, just to highlight the contrast. In this web app, we can create a new product. I'm not going to bother to do that now. We've done that before. We can show all of the products at once. That's basically what the welcome page does. So that's the read all. We can look at one at a time. So that's the read one at a time. We can, of course, edit. That's the update in CRUD. And finally, we can delete. So I'm just going to cancel for now. Since this app is designed for admins, what's really important here is functionality. We have to support the CRUD operations. We have to do so in a straightforward manner. We need to do some data validation. We've been through that sort of thing. But the interface is not all that important. It's the underlying functionality that really gets the highlight. Now let me contrast this with where we're moving. Let me bring up version 1 of the shopping cart. So I'm calling this ecom. By the way, the deployed WAR file is included in that zip. So as you can see, up at the top it looks the same. It's still Kelly's ski equipment, Kelly for no particular reason. You can see now that the row structure has changed. So there's a checkbox here. You can check it on, check it off. And obviously, if you don't check, you're not buying. We're being overly friendly, perhaps, to the user. To buy something, you need to check and to change the quantity. So for example, if you check with a quantity of 0, you really haven't bought anything. You're pretending to buy. But you can buy as many as you like. This is going to get a little pricey very quickly. So we'll come here, we'll buy 2 of these. You can't have too much sports equipment, as we all know. So I'm going to do yet another. So now let me go to the bottom of the page. I haven't implemented pagination, as you can see. I'm going to submit the order. And now I get an order confirmation page. In a friendly shopping cart, you always give the user the chance to rethink the purchase. And this, of course, is a little bit pricey for toys. We're at $5,500 already. So maybe now we think the better of it. By the way, HTML5 has this very nice numeric quantity where you don't have to type anything in. You can just lower or increase the amounts. And let's bring this down to a more sensible 2. So in the confirmation page, the only column that's editable is the quantity. Everything else remains the same. The checkbox goes away. The checkbox is our initial commitment, you might say, to buy. And then we do the confirm order. And we get to a final confirmation page. We get a final total, still pricey, but a little bit better than before. And we get the promise of an email. Right now, that's not implemented. That's a feature that we're going to add later. And now we can place the order. And when we place the order, as with any decent e-commerce site, you're right back to the shopping page because, of course, the vendor hopes that you're going to want to buy more. As you can see, we're not really implementing the CRUD operations here. We're implementing standard shopping operations. This version doesn't have all of the bells and whistles that we need, but it does illustrate the essentials. And some of the features we'll be looking at basically is this. How do we get the information from the shopping page over to the back-end servlet that then processes the shopping page? So I'm using a mix of JSP with JSTL and back-end servlets, but more about that structure a bit later. Let's go back to the working file, shoppingcartoverview.txt. And as noted, what I do in this first section is review what we did with the original ski inventory web app with the CRUD operations. And now in the second section, we're shifting our focus and we're going to be looking at these issues down here. So this is just a summary of the points that I made in the very short demo. Right now, by the way, the order is not saved in the database. This is one of the big issues that we're going to discuss because we're going to move towards a model view controller architecture. So we need to get clear on what's the best place, what's the best way to save things to the database from an order. In this lesson, we're going to focus on the flow of control in version 1 of the Shopping Cart Web App. You're looking at the working file, shoppingcartflowofcontrol.txt, This file, together with all of the ones we'll be looking at in version 1, is included in shoppingcart1.zip. I'll come back to this page momentarily. Let me jump back to the welcome page in the app. I've reduced the font a little bit just for readability. And let me come here and check an item and set the quantity up to 1. Basically, what you have in a given row is a checkbox, a quantity, a text box not editable that has the product ID, the product name also not editable, the category can't be edited, obviously the price can't be edited in this app. When we submit the order, all of that information, of course, has got to go over to the target servlet that's going to go through the data, validate the data, put together the order. But there's other information not displayed that has to go along for the ride. In particular, the number of rows in this table. So one of the challenges we face right away is how to send that number of rows. We don't want to hardwire that number because somebody might be editing the data. The admin might be in there deleting records, adding records, and so forth. So one of the things we'll focus on is how to transmit that information from the JSP page over to the servlet. So we get a confirmation, and again, we get a chance if we want to spend some money to up the quantity. We do a confirm, and we're now at another page. At this point, by the way, nothing is editable. It is, in effect, too late to do any editing. You can place the order or not. And we'll talk about alternatives to this approach. And if we place the order, then once again, we're back at the initial page. Let me return to my Emacs editor and now talk a little bit about the flow of control. There are 4 main components. There's some others as well, but the big ones are these 4, and they come in pairs. There's a JSP page that uses the expression language and JSTL, and there's a back-end servlet that's the target of a post request. So shop.jsp is the welcome page. It's the big page we were just looking at. When you do your shopping and hit submit, you wind up at the order handler, which is going to put together the order, and the order is going to consist of a list of line items. A line item is my class. We'll look at it later. It's a very traditional class, nothing very fancy. It's a POJO class. Once you submit the order, if everything is okay, then the order handler is going to redirect to confirmorder.jsp. Here again, you get a chance to change the quantity if you like, but you can't change anything else. If you really don't want to order, you set the quantity to 0. And of course, in effect, that takes it out of the shopping cart. You then wind up at the order placer, which is another servlet which redirects to a final confirmation page. So the real issue is getting the information from the JSP pages to the backend servlets, and when we get to the code, we'll focus on how to do that. In particular, we need to know the row count. So the servlets need to know how many things do I have to go through in order to put together the order. Here's a little more detailed look at these things. So I show, for example, the welcome page is shop.jsp. Upon submission, there's a post request over to the servlet. And what goes along for the ride are basically all of the rows. And then the servlet determines which ones were checked. Was the quantity set above 0? If so, then we're going to add this. By the way, all of the arithmetic now is being done in big decimal because we're in the e-commerce world and we don't want to be using the float type in Java to represent currency. So as some points of interest mentioned before, we need to know how many rows are sent, and the trick that's used in this particular implementation is one of the oldest tricks of the trade in HTML. The row count is sent as a so-called hidden field, an input. So HTML from the get-go, including now HTML5, has an input whose type is hidden. So it's not displayed on the page, but it's just like any other input type, and it's a very easy, if a bit old-fashioned way, but still very convenient to send goodies from the browser over to the server. So I go into some details here. Most of the database access is just done through JSTL SQL package because that's good enough for what we need to do. And then finally, down at the bottom, I summarize what the order handler servlet does. It puts together a list of line items. In effect, that's the shopping cart. It does some data validation. It does some very simple arithmetic. And then it's the line items, if you like, that are displayed in the confirmation page. So you might say, in the welcome page, the table is displayed. In the confirmation page, it's the list of line items that's displayed. In this lesson, we're going to focus on the source code for the Shopping-Cart Web App. To begin, let's very quickly review how the app works. So I've brought up my browser, and I'm going to, just for simplicity, pick two items near the bottom so that I can do the submit very quickly. So we do a submit, we get a confirmation page. There's a quantity of 2 for one of the items, a quantity of 1 for the other. Let's reduce that to 1. We'll confirm the order. We get a confirmation page, a promise that an email will be sent. That's not yet in place. And if we now place the order, we go back to the shopping page because, of course, the vendor is encouraging us to continue. Let me jump into my Emacs editor. For a quick overview, there's basically JSP pages and then servlets that are the target for post requests from those pages. There's no straight HTML. Let me also make the point that you can actually get on the web a pre-built shopping cart component. We're going to build it from scratch because, of course, we're trying to learn various ways in which you might provide the functionality. But shopping carts are available basically nowadays in almost every framework. We, again, are going to build it from the bottom up. So here's the welcome page, shop.jsp. It uses JSTL, as you can see from the tag libs up here. And this is familiar. We set the data source, so this gives us access to the database. And here's the very simple select query. We're basically getting all of the contents from the skis, etc. table. Again, I'm not using pagination. That would be a nice feature, but I've not implemented it. Now let's get to what's of interest to us. The table looks like this. There's a checkbox that allows you to buy. If you don't click the checkbox, there's no purchase, no matter what you do with the quantity, which comes next. If you hit the checkbox but leave the quantity at 0, the default value, this is going to show up in the shopping cart, but you won't have purchased it until you change the quantity to at least 1. The product ID, the category, the price, and so forth are all read-only. Here's the first challenge. What we need to be able to do on the back-end servlet is to figure out what the user checked. The approach I'm going to take, very old-fashioned, but fairly straightforward. I'm going to set a variable called ind, or index, and I'm going to initialize it to 1, as you can see here. And then I'm going through a for each loop. So I'm iterating over the record set that I get from the database. So let's look at just the first one to get the idea of how this is going to work. So you see there's an input type checkbox, and you can see the name is check dash that number. So the first one is check dash 1, check dash 2, check dash 3, and so forth. And so for the other fields, the quantity is num dash 1, num dash 2, and so on. The item ID, same idea. The product, same idea. The price, same idea. Each of these has a name that begins some name, price, for example, dash, and then a number. I've deliberately omitted from the HTML the ID attributes and left the name attributes to underscore that Java works off the name attributes. At the bottom of the loop then, of course, I increment the index by 1. The next record will be 2, 3, 4, and so on. As noted in the last lesson, I need to know how many rows are in this table, and so I'm using an old-fashioned trick. Input type equals hidden. This has been around from pretty much the start in HTML, and the value is that record set's row count. So this is not displayed. That's the nature of a hidden input field. but the goodies are going to travel with the post request to the servlet. So when the user hits submit order, we're going to be at the order handler servlet. So let's look at that. So I've overridden in the servlet only do post. I've left do get alone to minimize the clutter for now. So do post is fairly straightforward. We set the total to 0. As you can see, I'm using a big decimal now, not floating point. Get and verify inputs does the heavy lifting. It returns a list of line items. We'll look at a line item momentarily. And once we get that, we send a response. This is basically going to go to the confirm order JSP page. Get and verify inputs starts out with an empty list of line items. Let's look at line item very quickly. It's in the same package as the servlet. So as you can see by inspection, this is a POJO class. It doesn't implement anything. It doesn't explicitly extend anything. For convenience, it has a multi-argument constructor and then some read properties. Get the quantity, get the ID, get the product, get the category, get the price. Each thing you order becomes a line item that sits in your shopping cart. So let's jump back. Here's the main loop. We're going to iterate over the rows in the row set that have been checked. We're going to look for those. So I start out by setting check to check-int. Int is initialized up here to 1. So this is going to be check 1, check 2, and so on. And I'm using the old-fashioned request get parameter. I'm checking to see if that's null. So on a checkbox, if you don't check it, the value is null. If you do check it, the value is non-null. We don't care what it is in particular. It's a string, but we don't really care. If there is a check, we grab the quantity, the ID, the product, the category, the price, and then we create a line item, and we add this item to that collection. What we're doing is putting something in the shopping cart. Notice if the quantity is at 0, it's not going to impact the total price. So for a very small gain in efficiency, I filter out quantities of 0. If you have a quantity of 1, 2, 3, or whatever, then we compute the price. And eventually, we're going to send a response. The response is going to wind up here at confirm order.jsp. You're going to see it's very similar to shop.jsp, the same variable trick if you like, the same sort of for each loop. The big difference now is that the checkbox is gone. You've already checked something. The quantity stays, the item ID stays, the product name, the category, the price, and so forth. Basically, at this point, the shopper has the option of changing the quantity and little else. I once again use a hidden input field to send the size of this list. So the data source now is a list. It's not a record set from the database. And if you confirm, you go to yet another servlet. So orders, and this is going to be order placer.java. So this is the second servlet that comes into play. It's similar to the first. I like to keep the servlets separate. That way it's easier to debug, even if the code is similar. Again, we could refactor this later to take out common elements and put them someplace else. Once again, I overwrite only do post to reduce the clutter. The logic you're going to see is very similar. We set the total to 0. We get the confirmation inputs. They're the same as the other inputs. We just need to check, in effect, whether the quantity has changed. If everything is okay, we save to the DB. Right now, that's a stub. It doesn't do anything. That will also send the email confirmation, and then we send the response. The get confirmation inputs is very similar. The only thing that's changed is that there's no checkbox. There's quantity, there's ID, product, category, and price, but the logic is essentially unchanged. If everything is okay, a response is going to go back to a confirmation page. So you can see the placeorder.jsp page is where you wind up. And if you place the order, you then go back to the shopping page. That's been our first look at the underlying implementation for the shopping cart. What we're going to do in forthcoming lessons is add some functionality. This lesson introduces a programming exercise that centers on getting user inputs from an HTTP request. Let me jump down to this simple depiction. What we've had so far in all of the examples we've seen that involved user inputs is a JSP or an HTML page, and the user enters some inputs. We've seen check boxes, text boxes, and of course there are other user inputs available. And then the user submits the page, and the submitted page goes as an HTTP request either to an explicit servlet or to a JSP page that in turn gets translated into a servlet instance. So on the right-hand side of the arrow over here, what I've used in every example so far to extract these inputs is either getParameter, so that's the explicit servlet API, or in the expression language, this becomes param. So it becomes one of the parameters that we're looking for in that map that comes across. GetParameter is perfectly fine. It's an interesting method. Very early on, it was deprecated and then undeprecated, and if memory serves, it's the first Java method ever to have been undeprecated. There are others, but I think it was the first. In the shopping cart example that we've been looking at recently, the use of this method requires us to send along for the ride from the user side over to the servlet the size of the table that's being displayed, for example, in shop.jsp. Because on the servlet side, what happens is there's a for loop, so we iterate across the records. We need to know how many there are, and we basically pick out the inputs that have been checked. The size, again, basically the row count of the record set, or the size of a list, is put in a HTML hidden input, so it's very convenient for this purpose. Now, the exercise involves doing something different, and the point of this exercise is to make you a bit more familiar with the API. What I've been using in my examples is getParameter, which takes a string argument, the name of the parameter, and returns a string or null in case of failure. GetParameter is not quite the same as getAttribute, because getAttribute returns an object, not a string. So, for example, with getAttribute and setAttribute, you have a slightly richer API. But we're focusing on the parameter side of things right now. What we haven't used so far are these other methods. So there's getParameterMap, which returns, as you can see, a map where the keys are strings and the values are arrays of strings. So you might have a single key that is associated with multiple values, and so those are put into an array. So getParameterMap is very friendly, and a map, of course, has a size method, so you might say the count comes along for the ride. It's part of the map. You also get an enumeration, getParameterNames, so you can get an enumeration of all of the keys in the parameter map, and then you could use, for example, getParameter to get the corresponding values. You can also get just the values without the keys. There's also getParameterValues. Let me get now to the exercise. The core of the shopping cart app is basically two pairs. There's shop.jsp, that's the initial shopping page. When you submit that, you hit order handler, a servlet. And then there's the confirm order JSP, which is slightly simpler. And when you submit that, you wind up at order placer servlet. So the idea is to pick one of these two. If you have time, you could do both. That'd be great, and even experiment a bit. Take one approach in one, a different approach in the other. But pick at least one of these, and instead of doing it the way I've been doing it with just getParameter, on the servlet side, use either getParameterNames, getParameterMap, or getParameterValues, whatever strikes you as easiest. If you use one of these other approaches, you actually don't need the row count that I've been sending, but you can leave the JSP page as is. The hidden attribute doesn't really cause much harm. There's a couple of digits sent over the wire, so we need not worry about that for efficiency, at least not at this point. If we went into production, of course, we'd want to clean everything up. So again, the exercise is to either replace my getParameter with one of the others, or at least to augment the use of my getParameter with one of the others. So I hope you get a chance to do this exercise. I think it'll be helpful in learning the parameter extraction API available in Servlets. This lesson covers the setup that's required in order to add email confirmation to our shopping cart web app. You're looking at the working file emailsetup.txt. For convenience, I've put this text file together with a test servlet in a zip called emailsetup.zip. Let me go over the basics and then we'll do a little demo. So the big thing we need, of course, is an email server. And the problem is that we're in test or development mode. We're not in production mode. So even if you have an admin email account, for example, at Gmail or Yahoo or the equivalent, these might not be suitable for what we want to do. In other words, we don't want to actually send out emails. We just want to make sure that we're capable of doing so, that our web app code is capable of talking to an email server. In a production environment, by the way, the email server is very important. We need to make sure, for example, that it's not blacklisted, that we can talk to the server, but clients refuse to accept those emails. Now, there are all sorts of good fake email servers available for development mode. And if you don't have one already installed, I can recommend one. You see the URL on this line. It's written in Java. It comes in a jar file. It's straightforward to use. I'm going to demo it shortly. So I'm just going to call this the fake SMTP email server. Once you download it, you basically can execute it from the command line as follows. There's all sorts of options available, as you might guess. Basically, what I'm doing is running it in the background, and I'm using port 2525 instead of the default email port, which is just 25. And I've got some explanation over there on the right. We also need the email API packages. Those do not ship with core Java. They do not come with Tomcat, so we need to download them. However, they're in the email test war file because I've included that in the zip that I just mentioned earlier. So this war file is available. I leave it to you to grab a fake email server. And as I said, this one I'm going to use for demo purposes. Once the fake email server is in place and it's been started, we can run the test servlet, which illustrates the API, and we're going to look at that code momentarily. What the fake email server will try to do is to save all of your emails in a subdirectory called received emails, and here's basically the email that I'm sending out for test purposes. You'll also get lots of log information. Let's jump to the command line then. As you can see, I've already typed out the command java-jar fake smtp.jar. When you download this, it may come with a version in the name. For example, it may be fake smtp 2.0.jar or something like that. The -s -b basically means run it in the background. I don't care about the GUI. And the -p is for the port 2525. So let me start this guy. It started up. You can see there's a little GUI that comes up to show me that. Let me jump to my browser. What I've already done using the AND script is deployed a very simple servlet called email test. It's in that war file. So I'm going to execute this. Nothing happens. You don't see anything. But coming back to the command line prompt, you can see that there's a bunch of debug information. So it basically goes through what's happened. And if I come over here to a different tab, I can show you the received emails subdirectory. Basically, that was created by the fake email server. And I can show you the email that's therein. So this is basically the test email sent. Now, because the test worked, of course, doesn't guarantee that everything is going to be okay, but it is a bit reassuring. Let me now return to the Emacs editor, and let's take a look at the source code. So I just call this test. It's an HTTP servlet, as you can see. And here are the imports that I'm using from the Java email API. Now, we're going to go over this code fairly closely in the next lesson, but for now, I just wanted to give you a sense of how much code is involved. So as you can see, it's not a lot. There are some properties to be set, in particular the email host. I'll talk about that later, the port number, and then in the try block, this is actually the heart and soul of the email sending. So a message is created, certain properties are set, and then finally, the message is sent over transport, in this case, SMTP, Simple Mail Transport Protocol. Let me summarize. We need an email server. For development purposes, a test email server. We also need a jar file that contains Java's email API. We have that. It's included in the test war file. What remains to be done is to take these pieces and to integrate them with our shopping cart web app, and we'll do that in the next lesson. We're going to focus on the source code that implements the email confirmation in the revised shopping cart example. For reference, I'll call this the shopping cart 2 example. So the changes are fairly straightforward. Let me begin with line item. For convenience, I've added an override of toString because the email confirmation is going to contain a list of each item ordered. Let me jump to the command line to show you a sample file. So I've tested this, of course, and here's one of the orders that I made, and here's the confirming email. The part of interest to us is down here, the order summary. So you see that there were 2 items ordered, 101 and 102, $4.99 and change for the first, $2.44 and change for the second, together with a total. There's nothing very fancy, of course, about this email. In a production environment, we'd need to clean this up, maybe even send HTML. I have the fake SMTP server running in the background, so you can see that I've done a couple of tests. This is just a log of what's going on. So the interface in the shopping cart is not changed from the beginning with the email confirmation. The difference now, of course, that it's actually working. So we want to go back and examine the source code. So each of those items in the email confirmation is basically the toString of the line item. Now let's get to the main change. And the main change, of course, is in the order placer servlet. So the user has done some shopping, submitted the order, has been asked to confirm the order, and now we hit the order placer, which is going to write the order to the database, save to DB, and at the same time, send an email confirmation. So let me jump down to that code. It's a private method in orderplacer.java called save to DB. I have a comment here, so you can see an exercise coming. I don't actually save this to the database. I don't even have a database right now, but I do send a confirmation of the email, and that's what we're interested in. For each line item in this list of line items, I create a message, and the message is just the toString representation of each line item. Then I add the total, and then call send confirming email, which is down here. I'm pretending now that the customer has a unique email. That's the string 2, the first argument. The second argument is the confirming message. Eventually, we'll need to provide a way for users to register with us so we can get their emails. We'll have to make sure that those emails are unique, but for now, we're interested in the email part, so we're going to assume by magic that we have that. So I just hardwire that. So in this case, it's customer@somewhere.org. So it's a make-believe email. The SMTP server is localhost because of the fake SMT server that we're using. Again, the port number I've kept at 2525. It's pain-free. It's a port that probably isn't being used on your system for anything else. So some properties are set. I turn on the debugging. This just means I get bigger messages. And then the critical part occurs in this try block. So I think you'll find that this API is fairly straightforward. The first thing we do is create a message. This is a MIME message. This is standard for SMTP email messages. And the My Message wraps a session. So the session represents our connection with the email server. We set the from address. Of course, that's the infamous webmaster. We get a representation of an internet address. We set the recipients. In this case, the recipient is just going to be the customer. We set the subject, the sent date. There are other properties, as you might guess, can be sent. This is the important one. We set the text to the confirming message. If we wanted to get fancy, we might make this a nicely formatted, for example, HTML document. And then finally, we use the static method in the transport class to send the message. If anything goes wrong, a messaging exception is thrown, and we're going to, of course, get an error. But in this case, the fix is in. We're using the fake SMT server. All it does is save the email to a local file. So as you can see, the code is relatively straightforward. The real work in a production environment would come in making the message a bit more fancy and a bit more professional looking. Let me go back to the top of this file just to show you yet again the API interfaces and classes that we need. So these are all in the jar file, which is encapsulated in the war file. I've called this email-ski.war. It'll be among the working files, and it includes all of the source file, including orderplacer.java. So we have the address, the session, the message, the transport, the exception, and then a couple of utility classes. Not a whole lot. Fairly straightforward. This lesson introduces an exercise that I hope you'll get a chance to try your hand at. From the database point of view, it's the most elaborate exercise that we've seen so far. So it involves creating a table, and it also involves using Java code to communicate with that table, in particular to update the table with orders. Let me provide a little bit of context. In the second version of the shopping cart, so the Ski email web app if you like, in the order placer class, there's the method save-to-db, which we've been looking at. As you can see, it doesn't actually save anything to the database. It's got a little comment up there that promises this as an exercise. All it does at present is iterates over the line items that have been ordered, so however many things the customer has ordered, and each of those includes, again, the product, the category, the price, the quantity ordered, and so forth. It basically puts together a confirmation string, a message, and then it sends that out as an email. So the exercise, as you might expect, is actually to do the database thing. And it would be a good idea, I think, to do this in the spirit of MVC, Model View Controller Architecture. In other words, to create a model class which would be responsible for persisting orders to the database. Eventually, the class might have other database functionality as well, but for now, the persistence is the important part. The idea is this. In your database, for example in Postgres, you can use PSQL to do this straightforwardly. We've done that already. Create an orders table. That table should contain the obvious information, the quantity ordered, the product, all of that good stuff. But we also need to identify the customer, so for now, let's just assume that every customer has a unique identifying email. We haven't talked about how we get that yet. Let's just pretend it's in place. In my code, it's hardwired at present, and so you can work on that assumption. Eventually, we'll allow users to log in and to register emails. So we'll take care of that, but right now, it's the persistence that's the main point. An entry in the table would include the email of the customer who's ordered a particular line item. What the table is going to contain, in effect, despite its name, it's going to be called orders, but really the orders table is going to consist of line item entries. If you'd prefer that as a name, that's fine. If you'd like to play around with the database design, that's even better. Now, what we need on the Java side is a class. so I'm suggesting order.java, but again, you might break this up in some other way. But order.java would represent all of the line items in a given order. So basically in a given buying session. And then the recommendation for now is to use JDBC, so straightforward SQL basically, to save each line item in the order to the orders table. Eventually, we're going to move to Java's ORM technology, the Java Persistence API, and we'll move away from JDBC and see an alternative to that approach, an alternative that's higher level. But for now, JDBC is perfectly fine. In this first exercise, I wouldn't worry too much about the table design, the database design in general. The real emphasis here is on the Java to database communication, in particular, persisting things to the database through a Java class using JDBC. In this lesson, we're going to turn our attention to Java's ORM technology, where ORM stands for Object Relational Mapping. So let's take a quick look back at what we've done so far. In talking to the database, we've used only JDBC. JDBC has been around forever. It's reliable, fast, it's expressive, it's portable. It's also, as we've noticed, quite close to the metal. It's really a thin wrapper around SQL. When you're using JDBC, you are, in effect, at the SQL level. There are a few other things thrown in, of course, but mostly you're doing straightforward SQL. Java offers choices. Straight JDBC is one choice, and as we're going to see, ORM technologies represent another choice. And the really good news is that this isn't an either-or. You don't have to decide always to go one way or the other, because there are applications where an ORM may make sense. There are other applications in which straight JDBC may make sense. So we don't want to look at this as a competition. This is just a nice feature of Java that you have choices. Now, I don't want to focus on the various technical definitions of ORMs. You can find plenty of those out there in the wild. In effect, an ORM is implemented as middleware, and what that middleware allows you to do is the following. I've depicted it here in very simple terms. In an object-oriented language, you have a class instance. So, for example, product might be a class, and skis, a particular pair of skis, might be an instance of that. And the ORM allows smooth interaction between the OO level, which is the class instance, and the database level, which represents database records. Just to be clear, you could have a single class instance, the data for which reside in more than one database table. So you can have sophisticated database design and still use an ORM. Now let's look at this at the pseudocode level. This is close to Java, but it's not quite exact, as we'll see when we get to an example. But the idea is something like this. You could do a database lookup by calling the find method, what I'm going to call here a persistence manager. Later on, we're going to see that the actual class is entity manager. Furthermore, you can persist an object to the database basically in this style. You construct it as usual. You set whatever properties are appropriate. You then call persist on that persistence manager. That basically adds the product to a list. And then when you do a flush, all of the items in that persistence management list are sent to the database. So it's very straightforward. In fairness, I should note that some people are not enamored of ORMs. There's a lot of literature out there that describes an ORM as an anti-pattern rather than as a programming pattern. But as noted, we're going to look at an ORM in Java basically as an optional technology to straight JDBC, and that's the level at which we're going to stay. In terms of general trade-offs, there are, of course, always trade-offs in our business. So on the good side, it's fair to say, I think, that you have in an ORM a higher level API than you do in JDBC, which is basically SQL, but SQL is also fairly high level. You can always return to that JDBC level in a Java-based ORM because it supports so-called native queries, and we'll talk about that a bit later. On the bad side, whenever you have middleware, of course, the concern is always with the performance hit. There's another level of software that you need to go through that may hurt performance. Also, logic may be shifted away from SQL, which is quite powerful. You can do not only queries, you can order stuff, you can organize stuff. It's really a powerful language. The logic may move out of SQL into your programming code. And there are some Java programmers who very much prefer to do the logic in SQL whenever possible. So again, there are trade-offs. We're also going to see that the setup and configuration for using an ORM in Java can be a bit tricky. Java's persistence API is, of course, the official API for a Java-based ORM, but the ORMs that we're going to look at in a moment all tend to have basically two APIs. There's what might be called a native API, and then there's an implementation of JPA. In the examples I'm going to show you, I'm going to stick with the JPA implementation. In official jargon, what you have are JPA providers, and there are various choices as usual. So I've got a list down here with URLs. EclipseLink is the reference implementation. You see the URL. Hibernate, Open JPA. The good news, as usual, is that all of this is for free. So you basically visit these URLs, and then there are installers. You can also download everything in a zip file and so forth. So as noted, I'm going to use EclipseLink, but either one of the others would be perfectly fine as well, and there are other options too. In this lesson, we're going to talk about how to set up EclipseLink in order to use it in the first web app that uses ORM technology. What you need to do is download the current version. It's going to be 2.x, and again, I've repeated the URL there to the right. You can get it installed via an installer. You can get a zip file. There are various ways to go. If you get the zip file, they package in, for example, all of the documentation, so it's quite extensive. It can be overwhelming, of course, because you'll see a lot more in there than we actually need, and the critical pieces are these. We need 3 jar files. I've given you the high-level names. That is, I've left out the version numbers that are going to be included. There'll be a file called eclipselink.jar. That's the general libraries for EclipseLink. There's JavaX persistence.jar. That's the implementation of JPA, the core implementation, basically. And then there's some auxiliary things in another jar file called modelgen.jar at the very end. So if you're going to use the Ant script to do a build, you'd want to put those jar files, as usual, in the source directory. We also need, again, the PostgreSQL JDBC.jar. We still need the driver, because under the hood, the JPA implementation is going to be using JDBC. As noted, these all go into the source directory, and now we get to a rather tricky part. There's a very, very important file called persistence.xml. Let me switch to the actual version of it to get the color coding in my Emacs editor. We were just looking at, by the way, EclipseLink setup.txt. That was the working file. So here's the persistence file. This will be included in a zip. I'll talk a bit about that later. For now, we want to get the overview. So as you can see, the outermost or document element is called persistence. That's the name of the tag. I've included the attributes, although normally I take these out for readability. So let me get to the really important parts. Persistence unit is absolutely critical, and the name you use to identify it is something that you need to refer to in your code. So I call this product PU for persistence unit. Any name would do as long as I remember what that name is. I also set a transaction type to resource local. We'll worry about that a bit later. The JPA provider is org eclipse persistence JPA persistence provider. So that's the main class basically. And the class that we're interested in is something called test.product. You'll notice here, I could take this out, but I'm excluding unlisted classes. Basically, what I'm telling Eclipse is, if I want you to work on a class, I'll tell you about it, otherwise forget about it. Eclipse can also do some dynamic lookups. I've turned that off for now. Now there are a bunch of properties, and some of these will be familiar. They couldn't come in any order. You can see the driver is the same as before. The persistence URL, the JDBC URL, is the same as before. The database is ski stuff. We're using Postgres. The username is Fred, and the password again is secret. These last two properties I like a lot. Basically, what we're telling Eclipse to do is, if the table isn't already created, and we'll see that in the demo, please create it for us. And if the database isn't created, well, we need the database. We need to identify it. But basically, these two together tell Eclipse to generate the table and the required schema for those tables. Let me return to the working file, Eclipse link setup.txt. I've included the whole thing here as well, just for reference. The tricky thing is that persistence.xml file, and there could be other configuration files as well, although we're going to avoid those certainly at the start. It has to wind up in the WAR file in a very particular place. WebInf classes metainf. If it's anywhere else, it's not going to be found. So what I've done is revise the build file in order to handle that. So let me go to the command line prompt to be clear about this. I'm in a working directory. The name of it isn't so important. You can see here is build.xml. That's the revised build script. It's in that zip file you see on the right, testjpa.zip. That zip file also contains the deployed WAR file for the test application. Of interest to us is metainf. So I have metainf here. Let's look at that directory. And you can see in there is persistence.xml and an older version of that. Now, the tricky thing is this. The Ant compiler needs to find persistence.xml. And this persistence.xml has to be packaged in a particular place, again, in the WAR file under WebInf classes metainf. The Ant script takes care of that. So the idea is, if you're going to use the Ant script, create in your working directory, that is the directory that contains the Ant script, build.xml, create a metainf subdirectory and put persistence.xml in there. And if you use this new form of the Ant script, it will take care of the packaging details. So that's quite a bit. You can see already that things have gotten a little bit tricky. Once you get the configuration and the setup correctly, things are pretty smooth. But the big gotcha, I would say, is this file. It's got to be in a very precise place in the deployed WAR file. We'll take our first look at the source code for the JPA-based web app. The emphasis is going to be on how JPA fits in nicely with a model view controller architecture in a web app. You're looking at the working file ORM Code overview.txt, and we'll return here in just a second. But this first app doesn't have much of an interface. It's really a proof of concept app. We want to make sure that we can deploy JPA, that we can get it to work out of a web context. So to that end, let me jump to my bash shell. And I've already opened up PSQL, the client for Postgres. And you can see the cursor is set right next to \DT for describe tables. And as you can see, there are 4 tables listed: emps, sals, sequence, and skis, etc. We've used all of these in previous apps. Now let me return to the browser. As you can see, I've already entered a URL, localhost:8080/JPA test, the name of the WAR file, /test. Every time I enter this, GET request goes from the browser to the servlet, and the servlet creates a new ski product and places it in the database. So Superskis 1, Superskis 2, Superskis 3, and so forth. So the point of this test, of course, is to make sure that the JPA is working, that the items are being sent to the database, created in memory, and then persisted to Postgres. So every time I go back and hit that servlet, the servlet creates a new product and persists that product into the database. So to confirm, I'm going back to the bash prompt. Once again, I'm going to do \DT. You can now see that there's a products table. It's the second table in the list. And I'm going to do select star from products. And as you can see, there are 5 products in there. They've got IDs and product names. Not very interesting, very minimal, but this is enough to get us started. So let me quit out of here and go back to the Emacs editor to the working file, which does the code overview. So here's now a sketch of the pieces, and we'll look at the source code in detail in the next lesson. So what I've got are models, controllers, and views. That's a bit overstated because there's really only one of each. So there's one model. It's basically this class, public class product. So you can see it's a POJO class, but it's annotated. The first annotation is necessary for what I want to do. @entity marks this as a class associated with the database entity, in this case with the table named products. We can actually dispense with this second annotation and let JPA take over. It would name the table after the class, but I want the table to be a lower class name and I want it to be pluralized, so I put it in here. In these annotations, you see the familiar style. There's the annotation, and then you can set attributes. In this case, name equals. For the entity attribute, we don't do anything, but that's enough. So @entity is the big one. Now, the model is responsible, of course, for interacting with the database. It persists data. It allows us to access data from the database and draw it painlessly into our application. For the controller, I've got a single controller. I call this the products controller. It's an HTTP servlet, and I'm going against CRUD principles here in the interests of simplicity. So the only thing I override is do-get to make it absolutely simple as possible. I don't want to have to post a form or anything like that. And every time I do a do-get against this servlet, basically what it does is it creates a new one of these products and persists it to the database. The view, again, is very simple. Confirm.jsp. It basically says, yes, the product was saved. Would you like to do it again? So it's extremely simple, but we do have at least one of each. Now let me talk in general what an MVC would look like. In a real application, you would have multiple models. So products, vendors, customers, anything you can think of. All of your database entities would be represented in this JPA approach with a Java POJO class annotated as an entity. And the models would do the obvious application logic, data validation, formatting, and so forth, maybe data conversions. Each controller would be a servlet. It would have multiple methods overridden, do get, do post, and so on. Those would be the usual two. Those would consist of controller actions. So we could override what we like and leave the rest undefined or throw exceptions out of that. And in general, controllers are going to interact with models, in particular to get data. So to get data, to save data, that's going to be done through a model. It's not going to be done directly. In the past, I've done things like this out of controllers. I've done JDBC out of controller methods. But now we're going to have a better separation of concerns. We're going to delegate that sort of task to the models. And then finally, views would be associated with controller actions. In effect, the idea would be the controller would grab data from the model or push data to the model, whatever happens to be appropriate, and then redirect to the appropriate view, which would, for example, confirm that the action has succeeded or present data to the user, and so on. The MVC is fairly straightforward and intuitive. Having JPA classes act as models is natural. It's a very easy way to go. We're going to drill down into the code details of the JPA test web app. There are 3 Java files of interest. This one is called product.java. It's our model, if you like. You can see it's been annotated as an entity. And as noted earlier, we could dispense with the @table annotation if we were willing to let JPA pick the table name for us. But I want to make sure I get products as the name, and so I picked that. You can see by inspection that this is a POJO class. It doesn't implement anything. It doesn't explicitly extend anything. And now I've got some additional annotations, and I've put them on the fields, although you could also put these on the property methods. So let's take them in order. I think you'll find they're high level and intuitive. The ID is going to be the primary key. The column name in the table is going to have the same name. We could call it something else. That's the default. We could call it, for example, product ID if we like. And it's going to be a generated value. And we've seen this before. In other words, we're going to let Postgres generate that value. It's a long. The product name, we're going to name it exactly that, product name. And then we've got some properties. The ID, of course, is read-only because we don't set it. And then get product name and set product name. The next file is a bit trickier. I call it the persistence manager.java. I put it in the same package for convenience. I make it a web listener. I'll get to that in a moment because it implements a servlet context listener. So let me give you the short version. This is really the setup. This is infrastructure, basically. When the app is loaded into the servlet context, context initialized should be called, and what that's going to create is one of these guys, an entity manager factory. Creating one of these is relatively expensive. We want to do that only once, and so I have this set basically as a static field. An entity manager, the way I'm going to handle it is we're going to have one per session. So every client that connects is going to get an entity manager, and that entity manager is going to be saved, as you might expect, in the session map. Context initialized should take care of creating the factory. And just in case, I have a method called getEntityManager, and it checks to see if there is such a factory. If not, it creates it, and then it returns a created entity manager, again, one per client session. One last point. In this line, persistence create entity manager factory, that product PU is the persistence unit name from that persistence.xml file. That's where the names are coordinated. So this name, product PU, occurs in persistence.xml. Now let me go to my controller. I just call this the products controller.java. And as you'll see, it's an HTTP servlet. Let me go through some of the work that has to be done under the hood. I've done everything in do-get. We'll factor the code out eventually, make this a little bit cleaner, but for now, let's just focus on the big picture. So the first thing we do is get the session map and try to get the entity manager from it. Now, this may be our first hit as a client, and so we don't have an entity manager. In other words, it's not been saved in the session map, so it needs to be created basically and then stored there. In any case, by the time we get beyond this first chunk of code, we have an entity manager. The entity manager, as the name suggests, is the way we control the entity instances, in this case, products. We create a new product as proof of concept. We set the name to superskis, and then I've got an integer up above, a static field initialized to 1, so it's superskis1, superskis2, and so on. Not too interesting. We begin a transaction. We first check to see whether the entity manager already has a copy of the current product. Well, technically a reference to the current product. If not, what we're going to do is tell the entity manager to save this guy to the database. Now, this is a little misleading. emPersist actually adds the entity, in this case, the new product, to a list, and it's not until we hit the flush that it's written out. So for efficiency reasons, you might persist 5, 6, 7, 8 products at a time, and then do one flush, and that would write them all out. If something goes wrong, we get a persistence exception. The reason for the explicit transaction starting here and ending down here is that flush must occur within a transaction. So I can persist. Flush basically is the time when it's sent to the database. If I don't flush, I have to wait until the entity manager decides it's a good time to do it. So I want to do an explicit flush. Then I just send a response, and this is just a little confirmation to the JSP page, no big deal. In this first look, what we're trying to do is get a sense of how complicated is this, how much code is involved. Not a whole lot. The persistence manager code I'm going to use over and over again because I want to follow the strategy of one entity manager per session. Again, that's for efficiency's sake. The rest of the code, as you can see, is relatively straightforward. The persisting and then the flushing. And this, you're going to see, is about as complicated as things are going to get. Accessing things that are already in the database and bringing them into our program, that API is a bit simpler. But this is not bad. The judgment all of us have to make is this about the same as doing it in straight SQL? Is it cleaner? Is it better? Again, these are judgment calls. What we're doing is looking at options. We're going to talk about moving from version 1 of the JPA test web app into version 2. The working file you're looking at in my Emacs editor is JPA version 2.txt, and I'll do a demo shortly. So in version 1, we did only write operations to the database. In other words, every time an HTTP request went to the JPA test web app, we used JPA to write yet another record to the products table. The records were not very interesting. That's not the point. So everything was ski products 1, ski products 2, and so forth. There wasn't a lot of information saved to the database, but we did get to see JPA in action. Now let me bring up my browser. This is now version 2. I've deployed this as JPA test 2, and I'll include the WAR file in a zip file with some other documents later. And if I do /test after the name of the WAR file, I get the same functionality as before. There are new skis being added to the database and so on. However, there is a slight difference. What I can now do is this. If I now type /test ? So that introduces a query string, ID equals 155. There is such a record in the database. I've checked that already. What now happens under the hood is we do a read operation against the database. So we're searching for a particular record. We find it, and we get confirmation on the screen. In short, version 2 does both reads and writes. The way you do reads in JPA depends pretty much on how complicated the read is. In the first example, I'm using about the simplest read you can do. I'm using the find method. Basically, I'm telling JPA, here's the ID of a particular record. See if you can find it. Let me know. And if so, I'll display it. What I get back, by the way, is a product. So there is, if you like, serialization from the database record into an in-memory instance of the product class. Very nice. All handled automatically. For more elaborate searches, more elaborate reads and the like, JPA provides a query language. It's called QL. It's obviously modeled on SQL, but it's meant to be more portable, more expressive, and you could make the case simpler as well, although it can be a fairly complicated language. It's the job of the JPA provider to translate JPA QL statements into SQL statements. Let me remind you that in the worst case, we can always revert to straight SQL because JPA supports so-called native queries. Now, we'll get a chance to look at that code in great detail in the next lesson. Let me now move to the other side of the change in version 2. And this has to do with the query strings that we were just looking at. So I've got some verbiage, but let me jump to this very simple depiction. to review how the web container helps us in a Java environment. Let's say we're in a browser. We issue a GET or a POST request. Either one is just fine for our purposes. That request goes to the web container, so we're using the Tomcat web container. And what the web container does is takes all of the information in that request and generates from it a request map. So the request map, of course, consists of key-value pairs, and it basically passes that map as the HTTP servlet request to one of the appropriate methods, do GET, do POST, and so on. So that information is then passed to the servlet. Now the nice thing is that the API is very high level, and the API is also agnostic about whether the originating request was GET or POST. In some frameworks you actually have to know that, but in Java it doesn't matter. You can use, for example, getParameter. You've seen that used many times as well. So getParameter will work on GET requests, it'll work on POST requests. There's basically no difference. Let's return to the CRUD operations. In a CRUD world, using HTTP, a GET request, of course, is the R. It's the read, but it really has two forms. There's read all, so I'd like to see all the products in the table, but there's also read one at a time, and we saw that in the administrative website some time ago. We basically used show for read one. Now let's talk about how this works out at the HTTP level. So if you look at this first request that ends with /products, the assumption here is that we want all of them. So this is basically read all. And in the second version, we can use a query string, introduced, of course, with the question mark. And then we have the key value pairs. Key equals value, and if there's more than one, and key equals value, and key equals value, and so forth, where and is the ampersand. But we have only one. So ID equals 34. This now should be understood as a request to look at a single product, the product whose ID is 34. Now the HTTP servlet request has a getQueryString method that's very convenient. So for example, if you called getQueryString on this top one, you'd get back null because there isn't one. And if you called it on this second example, you would get the query string consisting of ID equals 34. And if there were more key value pairs in there, you'd get those as well. So we can use getQueryString to distinguish between the two types of GET requests. And then we can use the very convenient getParameter, for example, in the second request, to extract 34 from the query string. So it's very, very nice. It's high level, it's pretty straightforward, and basically version 2 of the JPA test takes this approach to distinguish between the two types of gets. This lesson reviews the source code in the JPA version 2 web app. We're looking at the source file product.java. It's unchanged from version 1, but there's a couple of points that I'd like to make about it. First, though, let me note that everything is included in a zip for this lesson. It's called JPA version 2.zip. It contains the deployable WAR file, which in turn contains all of the source code. I've also thrown in the new build.xml in case you're using the AND script, and I've included the metainf persistence.xml file as well in that zip file, just for convenience. Now let me return to product.java. As we saw earlier, this is annotated as an entity, meaning a database entity. Optionally, we specify the name of the table, otherwise JPA would give us a default name named after the class. The thing that I'd like to focus on here is the ID. So this is the primary key. I specify the column name. Again, we could leave that out, that's optional. And we want a generated value. So Postgres is going to use one of these auto ints for that. But in this code, I specify this as a long instead of an integer. So it's a 64-bit ID rather than a 32-bit ID. It's up to JPA to map that to whatever the native type happens to be in the underlying database. In this example, PostgreSQL. The point of interest is that JPA, like Java in general, is fussy about data types, so I need to provide an ID of type long when I'm trying to do a lookup. And we'll see that in the controller code, and I'm going to jump to that now. So we're now in productscontroller.java. This has changed considerably. Because I have more elaborate functionality in version 2, I've done some code refactoring to try to clean things up a bit, make it more readable. So let's go down to the only one of the doGet methods that's overridden. You'll notice I didn't put in @override. It's always a good idea, but again, it's not a necessity. So sometimes I put it in, sometimes I leave it out. But in general, it's a good thing to put it in. The deciding factor now in a GET request is the following. Is there a query string or not? If there's no query string, we are going to create a new ski product, put it in the database. If there is a query string, we're going to do a lookup. Again, this functionality is cobbled together. This is a test app. This is not a production app. Now, for good measure, I have written this out to Catalina.out, one of the log files, so you can inspect that on your local machine to see what the query string is. It'll either be null or it will be, in my example, something like ID equals 155. So again, this is a nice way to do customized logging. So if the query string is null, as before, we just persist something to the database. We put a new record in there just as a test. Otherwise, we're going to do a lookup. So that's the new part. Now, in terms of refactoring, what I've done is I've broken out the entity manager code. I've put that in a method called getEm. The entity manager is per client session. So for each one of these, I create an entity manager and I put it in the session map. Entity managers are fairly cheap to create. It's not a big deal, and it makes sense to have one per session. When the session goes away, the entity manager goes away automatically. That code, however, is in essence unchanged. It's just been broken out into its own method. Persist to DB is also essentially unchanged. We've got the transaction, because we do the flush, that has to occur in a transaction. We check to see if there's already such a product waiting to be persisted. If there isn't, we persist it. That just puts it in the list to be persisted, so it's a little misleading. And it's actually the flush that does the persistence. And again, the flush is what requires the transaction as a wrapper. So if all goes well, we send a request saying yet another record has been added to the database. The new part is in find products. So this is going to do our first read operation using JPA. So once again, we grab the entity manager. It's either a newly created one or one that's been saved in the session map. We have an object reference for a product, deliberately set to null. We have a pessimistic message, so we assume bad things are going to happen, although we have our fingers crossed. Now this is the critical part. What I'm going to do now is use getParameter on the request map, as usual, to get the ID, and I need to change it to an integer, but the integer needs to be a long. So the data type here has to be long. Obviously, I could have used long parse long, but out of force of habit, I stuck with integer parseInt. It's fine. It'll be upgraded from a 32-bit to a 64-bit number. But if this data type were int, we'd have a problem down here in emFind. So you have emFind. The version I'm using takes two arguments. The first argument is the data type. So we're looking for a product, product.class. You could use the fully qualified name, test.product.class, but this code is in the same package as products, so we don't need to do that. And then the second argument is the ID of the entity. So it's the primary key of the entity we're looking for. So either we get one or we don't. If there is no such product, we're going to get back a null. If there is such a product, we're going to get a non-null object reference. And the product will be fully deserialized in memory. So in other words, it'll be a full-fledged product instance. What can go wrong, of course, is the number parsing, number format exception, and illegal argument exception. This would occur, for example, if I just typed in here a number such as 155 instead of 155L for long in Java. So you're going to get the strict type checking. It's one of the gotchas, but it's a good feature. It's a nice touch on Java's part. What we've now seen are both sides, if you like, of the JPA operations. We've seen how to persist objects, Java objects, to the database, basically using persist together with flush. And now we've seen the reverse operation. We've gone to the database with a find, and we've gotten a in-memory Java instance out on the other end, in this case, a product instance. So you can see this is a very high-level API. It's certainly higher level than SQL, and that's one of the things that recommends it. This lesson introduces an exercise that covers yet another part of the JPA API. It basically involves extending the current JPA test application, so let's look at what we have so far. I have two bullets here, A and B. So in A, you see the URL that ends with /test. Now, if that URL is entered, either by typing it into the browser's URL window or through a refresh of that window, and that's how we did the testing, then what this does is creates a new product and saves it to the database. And as we've noted earlier, this violates RESTful principles because basically what we're doing is using a GET request to create an object. But again, we're in test mode, we're not in production mode. The other option is this. You can have a URL that ends with a query string, and the query string has the form ID equals some number, and the application, the current version, interprets that to be a lookup. And so we implemented that with a JPA find operation. So basically, we could do create and read one. The idea behind the exercise is to extend the logic so we can do create. We won't change that. Read one. We won't change that, but we're going to add read all. So we want to do a query that gets all of the products currently in the database. And as you might expect, there are various ways to do this. The key way to do this for us is going to be the named query. There's also a native query that would allow us to do this by using straight SQL, select * from products. But we want to get some acquaintance with the query language, which belongs to JPA, so we're going to use a named query. There are different ways to create a named query. The way I prefer, I find it the cleanest, the easiest, is to use an annotation. But there's also a standard programmatic API for named queries. The way you would do it is as follows. Let me start with the class. You can see I've got a POJO class called widget. It's annotated as an entity, as we'd expect. And it's also annotated with named query. That, of course, could go above or below entity. The query has two attributes. They can come in either order. There's a name. Any name will do. And then there's the query. And of course, I've left this open because the whole idea is for you to write the query in the QL. My suggestion would be to go to JavaDoc straightforwardly under named query, and you'll get lots of examples. Very helpful. All we need is a very simple query. We're basically doing a get all, so select * in effect. You can also do this programmatically. In the servlet, basically the products controller, we'd add a method called find all products. I prefer, by the way, to put the named query annotation above the class. It's easy to find, but you could put it elsewhere. So I'm just making a recommendation. The documentation will show you some options. Now this is going to change the underlying logic. The current logic is basically this. There are two cases. If there's a query string, do one thing. If there's not a query string, do something else. Now it's a bit trickier. If there's no query string, it's the same as before. But if there's a query string, there are two possible cases. You could have the old case, ID equals, that's the same. And you can have the new case, which has a very simple query string, question mark all, basically key without value. That's perfectly legal in HTTP, and in fact, it's fairly common to have query strings that consist only of the key without any value. In summary, the point of this exercise is to gain some familiarity with the name query. Once you've seen this, you'll see that the syntax is essentially the same as for a native query. The results from the name query can then be saved in the HTTP session and passed over to the confirm JSP page as before. This lesson is a wrap-up of JPA and some of the other topics that we've covered in recent lessons. In my Emacs editor, you're looking at the working file JPA etc wrapup.txt. So let's start with JPA, which of course is the Java Persistence API. It's a high-level API for talking to databases. It is, if you like, simply an interface. It's a specification. So to use JPA, the critical thing is you need a provider. So that's the term that's always used. And the provider furnishes an implementation. The popular ones are EclipseLink, that's what we used, Hibernate, OpenJPA. I'd be comfortable using any of these three, and there are others as well. It should be noted that all three of these also come with what might be described as a native API. This is particularly true with Hibernate, which has a completely separate API from the JPA implementation. So if you go online and you're looking for documentation, for example, for EclipseLink or Hibernate, make sure that you make clear that what you're looking for is the JPA part of it. That should be pretty standardized. As we know, these things are never absolutely perfect, but if you're a JPA provider, then you need to implement the JPA interface. JPA is geared towards relational databases, so table-driven databases, if you like, but it's sufficiently flexible to cover so-called NoSQL databases, object databases, and so on, and there are providers that do that. But mostly, JPA is still used with relational database systems. JPA is an option, just as JDBC is. We've talked a little bit about the trade-offs. Some programmers very much prefer JDBC. They like to do as much database logic as they can in SQL, so they want to manipulate it directly. You can use straightforward SQL in JPA through the native query. But the important point to recall, I would say, is this. JDBC and JPA are, for us programmers, basically two tools in the toolbox. There's no need to throw one of them out. Sometimes we may prefer one, sometimes the other. In the recent lessons, the other thing we covered was basically the relationship between the HTTP servlet request type and the methods that it encapsulates, and the HTTP metal. So we got into query strings a bit more, that sort of thing. What I'd like to do is just hint at all of the richness in the HTTP servlet request. And I say hint at because I'm not going to enumerate all of the methods that are encapsulated in that class. There are a lot. I've picked a couple to highlight, but the servlet request is really a wonderful data type. Java does a very nice job of taking everything that comes in through the HTTP request and packaging it as an HTTP servlet request instance. Let me talk about some of the methods. Some of these are native to HTTP servlet request, that is, they're local methods in effect. Others, of course, are inherited from servlet. For example, getParameter, which we've been using, is really a servlet method inherited by HTTP servlet request. For example, you can get all of the header elements. There's something called getHeaders, all of the headers, all of the metadata, if you like, and an HTTP request, get or post, can be gotten. If you prefer, you can just get the names because, again, header elements are conceptually key-value pairs. Key, value. You can find the request method, get or post. You may want to do filtering on that. You can get the request URI. So, for example, to the right you see an example. Technically, the URI, the Uniform Resource Identifier, of which a URL is a subtype, the URI in a URL starts after the port number with the slash. So in the example on the right, it's /myapp/doit.jsp. So if you need to extract that, you can get it. You can also get the entire URL. There's a method for that. In the case of a URL that targets a servlet, you can get the servlet path. So for example, we've been using this JPA test, and what you'd enter in a browser is JPA test2/test. The /test is basically the servlet path. So if you needed to extract that, you could do that as well. And of course, you can get cookies. We've talked about that. You get the cookie collection, and the cookie collection comes as an array, and then there are various methods to get the properties of a particular cookie. When we finally move into security issues, we'll see there are other HTTP servlet request methods that might be of interest to us if we were doing security type things, but we'll save that for a bit later. At this point, I just want to make clear that the servlet request type has lots and lots of goodies in it, and this is just a small taste.